It's real life to me. Can someone check on the link?
Okay,
It's
so we're
it's
probably live. Let's trust. Abel, open the YouTube.
Haven't
no, for
opened
me it's not showing.
That's
Okay,
a
we
delay.
are
not.
live. We are live. We are live.
We're live. Okay, cool. Hello, people. Today we are going to be doing an EGMO Livesolve. And as you can see, we have made some artwork to start us off.
Fan art.
EGMO fan art. Damn.
That was sound.
What is P1? Let's try P1.
Okay, we're just gonna go in lexicographical order.
Yeah.
Lexicographical order.
Classic order is 2, 1, 3, 5, 4, 6.
3, 2, 1. That's how I always do it.
Oh, P3 is Geo. Interesting. So it did happen.
Okay. Find out.
Guys, if n is odd, then
Wait, are you
3
sharing
divides n.
screen?
No, if n is even, then it's always possible, right?
But is anyone sharing screen?
Wait, guys. Is
Yeah,
this
if n,
sheen
if
scale
n is
visible?
even, then we win.
Yeah, n is even, then we are.
Hold on, I'm typing in
Wait,
high.
wait, one.
Okay.
Oh no.
Okay.
And,
Somebody has to share screen.
Someone should check the stream. Is the screen visible?
yes.
It is shared. It is shared. It is shared.
It
I
is
mean,
shared.
Abel is sharing, and then probably that is visible, right?
It is
Okay,
sharing.
so why does n even work?
Because
like
all the CI will
all
be
things
odd,
are
and then
odd.
or
even to 2.
yeah, so 2 will become.
Wow.
Okay, so n even done. Now we only have to think about odd.
Then
Okay,
n.
so
then you have 3 divides n.
yeah, so 3 divides.
Yes.
Because
Yeah, I'll probably do it bigger colors.
Okay.
So you have, let's just write C1 is equal
Maybe
to
let's
1.
just select directly the first prime P that does not divide n or something.
Mm-hmm.
That can help us.
Oh,
Wait.
also, like, we have observation number 1. Cm minus I is equal to n minus n plus 1 minus I equal to this.
No, so that means there will be like a midpoint where the sum should be equal to n.
Yes. But that's
Okay.
not
That's
helpful.
useless. That's useless.
That's useless.
We have
That's
3
completely
divides
useless.
n.
Yeah.
And 3 to the power k works. Yeah, 3 to the power k
Oh.
works. Okay, so we have n even works.
Oh, damn. This
How
is
is it 3
strange.
works? This is so
What?
stuff. Okay.
3 to the k
Okay.
randomly works.
Yes, it works.
Wait. I think this is a solution set. Like consider like 21 or something. I'm sure it doesn't work.
Okay, 21 have like what?
You can do
But you
start
have
with
6
15.
plus 8. Oh shit, 6 plus 8 doesn't work.
No, 6.
So C1 is 1, C2
No, 6
is
doesn't
2. What is C3?
6. 5 plus 8 doesn't work.
C3 has to be 3, right?
4.
Yeah.
4. 3
4.
must divide n. C3 has to be 4. So everything is totally fine till now.
Yeah. Then
Then C4 is.
Like
can it be
5.
5? It can't be. No, it can be 5.
Are we doing
It can
15?
be 5. Okay, we can try 15 if you want.
Okay, no.
No.
21 fails because of 8 plus 10.
Okay. It also failed because of 5 plus 8.
8 plus 10 works. This is horrible.
5 plus 8.
Yeah, 5 plus 8. 5 plus 8.
Yeah. And
so you just need 2 consecutive numbers that are not co-prime and you win. By taking
n
that
and n
mod
plus 1.
Yeah, like take the smallest prime divisor or something. So 15 we have 5. And so hence 4 plus 7. Yeah, 4 plus 7 wins for 15. I think there's a pattern here.
Wait, 15. Okay.
You just pick the smallest.
Basically, C1 to CM is sum free. Isn't that what you're being told? Something like that. No. Consecutive sums.
Yeah.
Okay, if you take 33, then 8 plus. No, sure.
10.
10.
No, 10 plus 13 wins for 33.
Wow.
Yeah.
1 second.
Yeah.
So 10 plus 13.
13, yeah.
That's so scuffed that even numbers work and powers of 3 work. That's a horrible answer, but maybe it's true.
Where is it coming from? Like, is it just
this comes from because like we have 11, right?
Maybe we take a factor which is like 11. Yeah, 11.
Yeah, so like if you have 3p, then you consider p.
Let's say we are using 3 to the power p into
p minus 1,
where p comma 3 is equal to 1.
But we needed this prime.
Yeah, so like we can
take the smallest prime divisor or something. and then you take p minus 1, comma
Yeah.
p plus 2,
Yeah.
or p minus 2 and p plus 1, based
Yeah,
on
yeah.
the mod
Yeah,
3,
yeah.
I think.
Yeah.
But is that
So-
always coprime?
Yes, because
The
P
sum
plus
is
1. P plus
no,
1 is
it's not.
P is the
What
if
if
Wait,
P
wait,
It's
wait.
the smallest prime. The smallest prime.
if P is smallest
It's
prime, then
not
why is P
coprime.
minus then P minus 2 is like basically never coprime, right?
Wait, hold on. Why not just like pick
It
some?
is
No, either
So
P
first of
minus
all, you can't have three
P minus 1 or
consecutive.
P minus 2 will be coprime.
Oh,
That's
You
wow.
it.
can't have three consecutive things like this, right? C minus 1,
It's
C plus
after
1, which are
shit.
all coprime.
No.
You can't have that happening first.
Yeah, no, you cannot.
But that's obvious because n is divisible by
But since 3 divides, then we win.
yeah, that is not.
Wait,
What
why
do we want
this
here?
is always coprime?
Does this not work?
This should work. Like, okay, so
Yeah,
we
it just feels like a bit of bashing now.
No, but the problem is 2p minus 1 can also divide.
Like, should I have factor divided, but the factor is not 2.
No, so like maybe take everything other than 3 to
It
the
could
k.
power
Like
of
maybe
3 or
take
something.
3 to the k times some n.
Okay, so P
Uh-huh,
plus
that's
1
fine.
Yeah,
is
yeah.
2k.
And GCD
Okay,
of
so
n
we
comma
have
3 is like 1.
n is
No,
equal
see,
to 3 to power k, comma
this and
times
P is
n.
not equal to, like, it's equal to 1 and 2p plus 1 is also equal. So it just works, I guess.
Wait, but no, it could be like 2p minus 1 is a prime itself.
Is
Or
a
2p plus
prime
1 is
and a
itself a prime,
divisor
and
of
3 divides.
No, but that can't happen twice.
No, we're looking at the smallest
we
prime.
can only
P.
take one of the cases based on
Ah.
mod 3, I think. So,
And we're taking it the smallest prime. So if 2p plus
Okay,
1 is
so-
also a prime, then it's an issue.
Okay.
But it
wait,
was a
what if
prime in
3
this
to
case.
power
but
k times n also works by some miracle?
Did
Wait.
15 work?
Wait, how? Which end?
Please check 15. Or no,
15 we
4 7.
check.
4 7.
Check, yeah,
No,
4 7.
3p fails for all primes p, but maybe something else works.
Does 3 squared times 7 or something?
No, I think
That
it
is very
unlikely.
random.
3 square
Or
times
maybe
7 fails for the
3 square
same
greater
reason
than
as
7.
yeah,
Wait, 2 times 7 plus
for
1
the
is
same
not
reason
prime.
as 3 plus 7.
What about 3 squared to 5 into 7?
2 times 7 minus 1 is prime though. 2 times 7 minus 1 is prime. So if we take 3 times 7 times 13.
3 times 7 times 13.
Oh, 3, 7, 13. Okay. So then we can't. 5 plus 8 is still fine. 5 plus 8 is still fine.
Yeah.
But
Yeah, that's the
11
point.
plus 14. Yeah, 11 plus. Oh shit, 14 is a multiple of
14
no,
is
11.
not
14
coprime, right?
That's so scuffed. Okay. What if this works?
Uh,
No. 11 plus 16.
20.
Oh my god.
Yeah,
What?
that works. That works. 17.
Wait, I think like let's try to find the first consecutive L and L plus
Yeah.
1, which are like both coprime. And then you get that it has to appear before n by 2.
Yeah. So here the first
Not before
C
n by
plus
2,
1
at
is
least after n by 2. But
6.
on average, you'd expect it to appear before n by 2. Because you can't like be having common factors with everything from 1 to n by 2 usually. Right? Like if you focus on the first point of time where you have two consecutive coprime, n is odd, so
Yeah.
that will happen eventually. And then you'll get
What
that.
in that case?
Okay, I mean, this case is very scuffed, but 25 plus 28. Why is 28 a multiple of
What?
7?
You
28 multiple 7.
what are you even doing?
Oh, no,
no.
23 plus. Okay, no. Okay.
23 plus 25 is like 48.
Yeah.
Wait, so did we
Maybe
find
maybe the
non-trivial
power of
source?
3
That
specialty
doesn't-
is that its quotient is like 2/3 of it. So like 1/3, 2/3 of them are not be used.
Okay, like 50 plus 53 has to work.
7 again. No.
Yeah,
It works, it
I think
works.
powers of 3 is the answer. We can find some scuffed construction that otherwise fails.
What is wait?
52.
Oh, okay.
I was thinking of going at like midpoint because n minus 1 by 2 is coprime. What probably is best.
Yeah.
We need to do something like this, right? Like get a range of difference 3 or something.
Yeah.
And because the power of 3 exists. That's all I can say.
And that's
Wait, so what did we conclude about the smallest prime p that divides n other than 3?
If 2p plus 1 or 2p minus 1 is a prime, it still
Fails.
might work.
Yeah.
Otherwise, it immediately fails. Yes, the smallest prime is probably not the way to go.
What if we look at any two non-coprime numbers between coprime numbers between 3?
Wait. Yeah. Let's use PHP strats.
Wow. What?
What?
N has few primes dividing it, but there are many consecutive
Is
things.
this combi with primes at this point again?
Probably not.
The NT has been reduced to combi. It's so sad.
How big is this number? 90.
No, like you can say something like there is some prime p that divides many consecutive sums, but that's probably not very useful.
3 probabilities.
Okay.
Maybe we just use like Chinese remainder theorem and get coprime things with good mods which work.
Yeah, that is true.
And the 3 is very important.
But then how do you control whether they're consecutive or
Consecutive,
not? That's the
exactly.
difficult
Yeah,
part.
so you want the
Maybe
things to be like
n
2 apart.
and yeah, say like n and n plus 3 or n and n plus 2. You just force
N plus
your
3 is
through
probably
that.
best.
You
Because
want
like
some n and n plus 3 pair where n plus 1 and n plus 2. So these two are coprime and n plus 1 and n plus 2 are not. So we can choose the mods appropriately.
And you want 2n plus 3 to be coprime.
Yes. And you want 2n plus 3 to be coprime.
That's
wait, so if you write this, then n is like not divisible by 3. So 1 of n minus 1 or n plus 1 is also not divisible by 3. Like let's say that's n minus 1. What happens? So n minus 1 is coprime to 3 to the k times n. And
Yes.
then
so n plus 1 is divisible by 3.
2 is also, right?
And that's where the 2n minus 1 comes. Oh shit. Does this just work?
Yeah,
Does this
just
work?
do it directly.
This one,
Maybe.
right?
Instead of taking the smallest prime, just take n. Just take n and we are done.
So 3 has to
What?
divide this. That's
Oh
what
my
you
god,
So
yeah.
what's
yeah,
n? What's
yeah.
n?
n is like
N
if you
plus
write
1
n equal to 3 to the k
N
times
is,
some other n.
oh my god, that's so
Oh.
stuffed. And
Nonsense.
for the other
Yeah.
case, we can just take n minus 2 comma n plus 1.
Yeah. You can also
And
take n plus 1
one
and
of
n
these
plus
cases work.
Wait, so but 2n minus 1, why is it coprime? It's not okay because
Wait, why can't 2 plus 1 like 2
No,
plus
2n
Like,
minus
you
1
can
will be
have-
divisible by 3. That is what will happen. Like 2n
Yeah,
minus
so
1 will have to be divisible by 3.
no,
we
it
can
cannot
have
divisible by
both.
3.
You can
Yeah,
have
and this is
one
a
of these two.
contradiction. So we are done.
No, that can't happen.
No,
because
you
mod
won't
3
get both. You only get one depending on what n's reciprocal.
Yeah,
like
exactly,
if n is
exactly.
2 mod 3, n minus 1, n plus 2 works.
So based on the mod 3 of n, we just choose one of these and we win.
No, but you still win. That's the weird part.
What?
Like if one of them is work, yeah, I think it, like if n is 2 mod 3, n minus 1, n
Oh,
plus
then
2 works for 3.
Because you
If
get
n is
2n plus
1,
1.
if n is 1, then you are going to select
n minus 2, n minus 1.
and n minus 2, right? So that tells you that it's divisible by 2n minus 1, but that's obviously false because n is congruent to
Yes.
1.
But is
And
that
so-
does that finish?
Okay.
Yeah, that
Yes, that
finishes.
finishes. That finishes.
Yeah, that's okay.
Wait,
Because
what
take the
about n
case
minus
large.
1? Why is n minus 1 coprime?
So depending on which is a multiple
Yeah,
of
that
3,
case
right?
n is congruent
Like
to 2.
in the case where n equal to 3, you take this.
And n plus 2 is coprime because n is odd. That's where the odd thing comes in.
Yes.
Yeah.
Okay, we just consider that.
I think this cooks. This is probably fine.
This cooks. We should write it up. We should be formal.
Yeah, it seems.
No.
Scam.
It is fine. Like, okay. So, n even works.
And
There is
3
no-
to per k works.
Henceforth, we're working with
GG.
n odd. Now, n odd means 3 will divide n by looking at first two.
Yes.
N odd implies 3 divides n. Write n equal to 3 to the k times n, where n is maximal, and you have then GCD of n comma 3 equal to 1.
No, this is a scuffed way of writing up. Let's just not write.
Case 1, n congruent 1. Look
Yeah,
at
like,
n
why?
minus
Case 1 n
1.
equal to 1. Case 1 n
No,
equal to
it's
1.
not n minus 1, n minus 2.
N minus 2.
Yeah.
No, it's given that n greater than or equal
my
to
bad.
3, so we don't care
n
about
minus
that.
2 and n plus 1.
You know, I'm
Now,
saying the
look at
n
the
is
things
smaller
in
than 3.
between.
Wait,
So
so
these are co-prime. You
yeah, these
have
are prime because like yeah.
you have
Yeah.
n minus 1 in between divisible by 3, so it's not in conclusion.
Yeah.
There's n also, that is also fine. So these
Yes.
two are going to be consecutive. And so you get that their sum is, which is 2n minus 1, comma 3 to the k times n is not equal to 1. But that's not possible because 3 to the k and 2n minus 1 are co-prime because 3 does not divide 2n minus 1. And at
Yeah.
the same time, 2n minus 1 and n are also co-prime.
Yes.
So this is a contradiction. And 2 more 3 of something exactly the same. Like
Yes, same thing.
And n equal to 1 works. Like n capital N power of 3 works.
Yeah.
Yes.
Yes.
Yeah. Yeah.
Because
But
if n
can-
is equal to 1, you can't take n minus 2.
But can
Like
someone check the
you
stream
need
ones?
n not equal to 1. Yeah, that's right.
Yeah, so
Guys,
we use the
can-
fact that n is
Yeah.
greater than 2.
Can someone check the
Yeah.
stream ones? Like, is
Uh,
there any lag or anything? Because
There will be lag. There
Cycle-
will be lag.
no,
I mean, you can't
YouTube
fix
shows
lag.
me a warning that the stream's current bitrate is lower than the recommended bitrate.
Bitrate.
It's
What is
a
the
bit
bitrate?
laggy, I see.
Tell them as long as the entropy is high, I don't care.
Bro. It's bit laggy, but I guess it's fine.
It's
Okay,
bit lagging.
Yeah.
That is so true. This is such a scam problem.
Yeah. So the
Yeah.
answer is finally all
Like
evens.
the only thing I like about this problem is the answer set, which is nice.
Sure,
Yeah.
sure,
Like,
sure.
Even numbers
It's
and
like-
powers of 3.
Unironically, that's probably why it was selected as well.
But it's okay, it's an NT-ish problem.
Okay,
An
let's
infinite
move on with
increasing
problem two.
sequence.
Yes.
Problem what?
Problem 2. Can someone like
2.
crop
Let's
it
just
and
copy
paste it
I
it
somewhere?
selected
again.
and paste. Like someone selected
Yeah,
and
thank
pasted.
you.
Yeah.
Someone like just crop it and paste it somewhere.
Okay, let's do
I'll
that.
just follow
Okay,
them.
okay.
Someone doing it or should I do it?
No, wait, I'm doing it.
Okay.
Okay, sure.
Okay, let's go to some no man's land. It's
Yeah,
complicated.
Man's
come
land.
here, like, yes,
All right. 50% zoom. There we go.
yes.
Yes,
It's-
thank you.
It's low, I guess. Yeah, okay, it's fine.
Sounds-
It's called
Central.
Central.
What
Okay,
the?
wait,
That
like
is so
this
weird.
arithmetic
What?
bean shit is just dumb.
Infinity.
So we just write
So first of all, switch to
Sigma-
prefix sums and then assume convex.
Yeah.
convex.
Like
Yeah.
convex.
Okay, yeah. This mean
What
shit
is
just
an
dumb.
squared? It's
Like
n times n, right?
No,
No,
n
Oh
was
yeah.
not up to n.
No,
Up to
the
n. right?
arithmetic
Up to
mean
n.
of the first an terms. Okay,
Oh,
okay.
oh,
So
my
it's like
bad,
this.
my bad.
Oh my
Uh-huh.
god, that is. Otherwise,
It's
it's n
n
into
squared
a.
only.
Yeah.
The
Come on.
arithmetic
So that
mean
there
of the
exists an
first
infinite sequence
an
of persons.
terms.
This is very strange.
It's very strange.
Show that there is an infinite sequence. So basically, you want to show that there is some like fixed points. You can't actually affect them at all.
You
Like there will
can't
be some
affect
points
them.
which
Right,
are going
right.
to be. So imagine
Yeah.
this is like
Very
powers of
interesting.
2 or perfect squares, something very random.
Okay, wait. What do you
Something like that.
think the
Then you
sequence
sequence
bn
inverse.
is?
I think
Maybe
they
it's
might be like
bn
ones or
equal to
something. Like just to like
bn equal to
average and-
n or something.
Yeah.
N.
No,
This
wait.
is a
I
Can
don't
you
know.
rigid
prove some?
problem.
Okay. Yeah,
This
let's
is
just
very
start
rigid,
writing a
like-
sequence. Let's just start writing a sequence.
Yeah, let's
Sure.
just cook some sequences.
Like-
Okay, first of all,
an
A1 is
equal
supposed to be 1,
an or
right?
something.
No.
Yeah.
First A1 terms, yeah. Or maybe a lot of, no.
Not
No,
necessarily,
Why-
not
why should
necessarily.
A1 be
Equal to
1?
AN, right?
Not
Because it's
Is
increasing.
AN,
It's
is AN
increasing.
really O of N? Do you
yes,
have-
yes, yes. A1 has to be 1. A1 has to be
A1
1.
has to be 1. Is A O of N?
And
Wait,
let's just
think
start
it's
writing the
over.
sequence. Let's just first
Okay,
start
let's just
writing
make
some
one.
sequence.
Let's just make one.
Yeah,
Okay, one.
yeah,
one.
go for it.
I mean,
Oh, by the way, I
A2
think
First
Two
A2
does not work.
terms. 2 does not work.
does 2n
Why?
minus
2, 3.
1 work?
Why does 2 not work? 1, 2, 3.
I
No,
mean,
no, 2 does not
first
work.
two
Yeah.
terms
1, 3,
have,
5
I
work.
mean,
1, 3, 5
Okay,
works.
1, 3, 5.
Does 2n minus
what
1
about
work?
just
I think
yeah,
2n minus
this
1
numbers
works. This
work.
works.
Oh, odd numbers
AN equal
work.
to 2n
Odd
minus
numbers
yeah,
work.
2n minus 1 work.
okay. Wait,
very
So-
fancy.
okay, wait.
Maybe the
Then,
answer is like all squares in this or something.
Maybe we can at least prove that AN must be at least this. Like,
Hmm.
because A2 2 was too small, right?
Yes.
yes.
And then 3 is where
Okay,
it
let's try
tried
2, 4.
I mean, if you try to induct
No,
yourself.
4 won't work, right? to
Why?
5.
When it will
Why
be
not?
2.
I mean, you don't
But-
know. We don't know yet.
Wait, what's the
Okay.
proof that A1 equal to 1?
Wait, let's try to plot this on a
Because
graph.
like it's even the
First
smallest
term is
element
A1.
in the set.
Wait, let's try to plot this in a graph. Like if you actually like
Plot it in a
mark points
graph.
ai comma j for all j at most I, is that useful?
Huh?
Like if you draw
Just,
like vertical bars at I with of height ai, does that help? It's like increasing, and then what do you know? You know that the area of the first an things is equal to like that. So that's sort of like
wait, Abel, what is it?
I'm trying to create a sequence starting with 2, 2.
But how?
It
Because
can't even start with A1 is supposed to be 1, right?
no a1 less than a2 first of all.
and even
Like
is equal
Oh,
to
even less
1.
than A2. Okay,
Yeah,
okay.
that's
Like
the
even
reason.
it's
Keep
just
increasing.
Because
Increase
like
in
even the
sequence.
smallest
One.
element in the first one, A1 element, right? And the
Or like
smallest
Yeah.
element
that-
can't be right.
like A1 plus something divided by A1 is greater than 1. A1 has to be
Yes.
1.
A1 equal to 1. Oh, yeah, so
What
we
happens if
have
we do
like
1-4?
B1
What happens
equal
if
to
1-4?
1, for
Oh,
example.
by the way, the average from a n minus 1 plus 1 to an is equal to like an plus an minus 1.
Very useful.
Could be useful.
Interesting.
Let's
So like
try
it has to
1-4.
be odd. Let's go 1-4. Let's try 1-4. Let's try 1-4.
What happens
I
with
mean,
1-4?
I
You want an
think
AP
it
of
should be
sum of
just
12? No.
Okay,
16.
1, 4. Let's have like
16,
5
16.
after that. Yeah,
Okay,
1, 4, 5, 6
5.
is the only thing that works.
Okay, that's 5 and then, yeah, 9
Is
is
it
close.
Yeah,
odd squares?
okay.
I think it's odd squares. Like at this point,
Okay,
I'm convinced.
1, 4 works. 1, 4 works and it goes into the odd numbers. It converges to the odd numbers.
Very fancy.
So now, are there
That is
sequences
interesting.
that have infinitely many mismatches with odd numbers?
No, so
Wait,
if we
was
take
that supposed
Bn
to
to
be
be the
11?
odd numbers, we're done. Like we want to be infinitely many matches with the odd number.
Yes, but
Yes.
like that's what I'm asking. Like, is it possible? Is it just true that it's always odd? Like,
Yeah, I think we can rephrase the sequence, the problem to prove that an equal to 2n minus 1 for large enough n.
But can you do that? Like,
Do that.
are
Wait,
there
no,
not
it is 11,
I think
13.
that's true.
Wait, it's 11, 13 over here. What if we, or it's 11, 15? What if we replace it with 12, 14? Does that change anything?
No, so here, like 5 square, right? You have 6 square, so the sum has to be 36 of this whole thing.
Yeah, exactly. But 6 includes
Oh,
next one. 6
no,
includes
so
4.
11 is fixed, but 13
No,
can be
no.
something else. 13 can be something else.
Yeah, so 13 becomes 14 and 16 becomes,
Okay, let's do that. 13 becomes 14.
and 17 becomes 16. 14, 15, 16.
Okay.
Oh yeah, but it again converges to the odd numbers.
Yeah, no, like we just keep flipping in the between. So it's
Yeah,
like
yeah,
it is
yeah.
the odd numbers,
So
but infinitely many.
yeah,
exactly. So
exactly. So there
this
are
claim is
sequences that have
false.
many
This is
mismatches as well.
false. This is false.
So it's not eventually true.
But it matches with the odd numbers infinitely many times.
Yeah.
Interesting.
Yeah. So,
Maybe look at an
Odd.
minus 2n minus 1.
Yeah,
let's
create a new sequence called
satisfies. That
an
no, but the
minus
satisfies, right?
2n
the summation
and prove that
has
it's
n
0 like
terms.
infinitely many times or something.
The summation
Right,
has n
right,
terms.
right.
And it's not true that n is always at least 2n minus 1. 6 is less than 7.
Yeah,
True.
that's false.
Yeah, like if it is summation to the first n terms, it is so much more clean. Like summation to am terms is just scuffed.
Very interesting.
Do you have upper bounds on an? That's what we
Yeah,
want.
like there should be some size bounds that we should be able to get.
Hmm.
They want to be tight though, right? Because 4 is more than 3 also.
True.
Can we do 1, 5?
Uh,
Okay, that will just be more.
Way more painful.
No, 1 5 does not work because 1 plus 5 plus 6 plus 7 plus 8 is too much.
That means we should be able to get some upper bounds.
Yeah,
Yeah.
maybe we
Okay,
have
let's
like
just do some
this is
stupid
very
upper
wishful
bounds.
thinking, but we maybe have something like this.
2n minus 1, 2n, 2n plus.
Oh,
That's all.
that is.
No. We have one more number to consider. 2n minus 2 also.
2 minus 2.
6 is 2n
Well,
minus
yeah.
2. 6 is 2n
Yeah.
minus 2. And this is possible.
Yeah, like we
Hmm.
basically want.
We just induct on this and just do
Yeah.
something.
Lamau.
That will be lame.
That would be funny.
No, that's too wishful. Wait, can you come up with a counterexample? I don't think so.
Wait, I think it's like.
Let's actually look at the difference, right? That should be useful.
It actually seems true, right? Why is this not true?
No, but
Yeah,
A
this
and
like
first terms is weird. That's the problem.
Like suppose that we are reached a point where it so far it's identical to odd numbers, then maybe we can prove that within 3 steps or 4 steps it has to return to the same state.
Come back to the odd numbers again. Exactly.
No, like yeah, one odd number. Like for example, here first point is 1, then 5,
And
then
then
9,
5,
right?
and then 11. Yeah.
Then 9. 9 also matches with odd numbers.
Then 9. Yeah, and then 11.
Yeah, but 9 is the point we care about because the total sum till now also matches with odd numbers.
Yes, yes.
So we like you look at these points and maybe prove that these points are like returning soon.
Hmm.
So suppose you write an odd number and so
Seems
far
like
it
it.
is matching odd numbers.
Wait, so you said we have an equal to O of n. What is the bound on like that? What is the constant?
In fact, an
Right,
is
giving
equal to
this.
2n
Giving
plus
this,
or
right?
minus constant. Like an minus
wow.
2n is bounded.
That's pretty good, right? Now, like, look
No,
at
we don't
A.
know it. We don't know it.
We don't know it. We're just conjecturing.
Conjecturing.
No, but you wrote here an equal to O of n.
No,
Yes.
that's also conjecture. Everything is
Oh, that's a conjecture.
Everything is a
Okay.
conjecture.
Everything
I
Yeah,
thought you
that's
proved it. Okay.
So we have proven it. I only proven that A2 is not A2 is 3 or 4.
Maybe we should break lexicographical order and attempt the geo or something.
Nah. Let's just
Wait,
finish.
no,
Let's wait for something.
Come
Yeah,
on, geo.
Okay, if we have reached 2n minus 1 and everything is matching odd number, what can be the next term?
So you want to prove that it comes back to the odd numbers again. Like, let's say we have some
Like,
ak equal to
if-
2k minus 1.
And
It's
like
equal
even the
to 2k
prefix so
minus
far
1.
is fine. Even the prefix
Yeah,
so far is
and we
fine.
don't care about the prefix apart from the
No, we
fact
do.
that
It's
no,
sum.
apart from
The
the fact that
prefix
the
is
first
important.
2k minus 1's numbers sum to ak squared. That's how we
You can't
calculate.
know that 2k minus 1 is more than k.
No, but as you put in more odd
Oh, yeah.
numbers, won't you have more space to do random nonsense? Because like it doesn't
But
start.
you have to always come back. So the gaps can get larger and larger, but you always have to come back to the odd numbers.
That's the claim. Okay, now first k numbers, the summation is whatever it's supposed to be.
Okay, let's say the sum is s, like a1 plus
It's like
all the way
k
to
square.
ak is equal to s.
It's k squared, like ak is 2k minus 1. Right?
Can you prove that s equal to k square? Can you prove that?
Huh? Like, aren't you assuming ak is 2k minus 1?
Wait, this happens at all an points. Like,
No,
like,
no.
That's
S
literally the
equal to k
problem.
square only happens if
I
there
see.
exists
If
there
k
exists
equal
fields
to
such
ai,
that yeah, exactly.
then it happens. Yeah.
So you know what you want? You want like ak is equal to 2ak minus 1.
Wait, so okay, let's rephrase it this way. If you have a random,
Okay.
maybe it doesn't matter that it happens at the
Yeah.
first an terms. It just happens at
Yeah.
some terms. Maybe that's what matters.
Yes, exactly. What if
So
you have
basically,
something
if
like
these sums, if this is like a convex sequence and it's achieving equal to square multiple times, then the differences should take odd numbers infinitely often.
wait, do you have some claim like this?
No, so basically imagine that you have this sequence P1, P2, and whatever, such that Pi equal to I squared infinitely often.
Yeah.
Okay.
Pi
And
equal
at
to I
the
This is what you
same
want to
time,
prove, right?
and at the same time, you also have Pi minus 1 greater than Pi minus 1 minus Pi minus 2. So you want to
Yeah.
show that this will take 2i minus 1 or something multiple times.
Oh, so we don't care about the ak square. We just
Yeah,
say
you don't care
infinitely
that it
often.
happens at an,
Sure.
like the first an terms,
Sure.
the
Yeah.
first some things.
Okay.
Wait,
Yeah, and since
what do you want to
Pi
show?
And it feels like
is
because it's so tight, like it will still be
yes.
fine.
Wait, what do you want
It's
to
like if
show?
Pi
you
equal to I
draw the
square
graph of y
infinitely
equal to
often.
x square, it's like hitting all points of that graph, multiple points of that graph. It
Okay,
also
so
has
this sequence Pi is an increasing sequence and the derivative is also increasing.
Wow, derivative.
It's convex. That's
that's
right.
why I said it's
Or
complex.
sure. Now I realize the meaning. What is a convex sequence?
Wait, what do you want to show here? You want to show P minus 2m
It's
minus
like
10.
taking 2 minus 1 many often. Basically, you have many consecutive
But this
points.
is weaker than the statement, right? This is stronger than the
Yeah,
statement.
I think the weaker statement might be true. And if this weaker statement is true, it's good for us. Right?
Yeah, but is it
No,
true?
this is
Yeah.
stronger
Stronger
than the
statement. A weaker condition, stronger statement.
Stronger statement, yeah. And the problem is like a subset of it.
Is this true?
It could also be false, but I mean, I don't know. It feels very hard to get everything to match up so well. Like
Yeah, like you have like actually graph the sequence. You have this nice Pi sequence. It looks like this. And
that's
then
not
you
nice.
have
X square
f of
is
x.
what's nice.
Yeah, x square is like this. All right. And then
So it should go up and down with respect to I
Yeah.
squared, right?
yeah,
But then
something
how
like
can
this.
it go up and down? Can't go up and down.
This has to maintain convexity while going up and
No,
down.
it can go up and down because it only have to maintain like
The
finite
double derivative
convexity.
goes up and down.
Okay, we can't differentiate this shit. It's a
Yeah.
discrete
Right,
sequence.
it's called finite differences is differential.
Finite difference.
Finite difference is something like sure.
Like you can just like have these eyes very, very far. Like maybe the
Yeah,
sequence
But
is
okay,
very,
so
very
maybe,
slow.
so maybe
Yeah.
And
like
his eyes like very, very far. And like you can probably do some tying and something to miss out 2i minus ones.
sure, but
But again,
eyes
you can have
can't be
them
very far. Let's
infinitely
try to
often.
use that then. Like we
Yeah,
know that the
sure.
eyes have to be pi minus 1 type far.
Sure, possible. Like, I just
Yeah,
feel
I
like there
think
should be some
convexity
size
plus
thing, right?
intersecting
Like,
with this x square is finishes maybe.
like we just
Well,
use the size just do some bounding. Like that's just something I feel
no, this problem is
should
all
work
about
out.
plotting y equals x square. That is the
Okay, let's make a beautiful plot. So you have your coordinate axis. Where's the magic drawer?
Yeah, come on, Aditya. We shall
That's
do bounding.
good thing here.
Yeah. So first, assume first n terms sum up to n square.
Yes, this right?
Uh,
Where are we?
yeah,
And-
that only.
Yes.
And it's not 2n minus 1 here, it's like
Hmm.
4n minus 3.
I like 4n minus 3. An is
2
equal
into n
to
minus 1 minus 1.
an is equal to 2n minus 1.
It's
This
4n
is equal
minus
to 1 second. Oh, this is so annoying me though, right? You have to switch between pen and gestures.
We are at 4n minus 3 and we're looking at what happens afterwards. It can't be 4n minus. Can't be 4n. Basically. No, 4n plus 1.
That's what we hope it's not, right?
Yeah. And the idea is if it's
So
4n plus 1, then the first 4n plus 1 terms are too big.
too big, yeah. So
Yes.
first 4n minus 3 terms.
Not 4n minus 3 terms, 2n minus 1 terms.
2n, what am I saying? My god. First 2n minus 1 terms have some 2n minus 1
2n minus
square.
1 square. And then the next 2n plus 2
And then
terms has some 4n into 2n plus 2. Right? Yeah.
it's like plus
Yeah.
4n plus 1 plus 4n plus 2.
Yeah. Till this is 2n
Where
plus
is
2
it end?
terms. 4n
Oh
plus
my
2n
god.
plus 2.
4n plus 2n plus 2 this.
Yes, we have to check if this is more or less than 4n plus 1 square.
This.
And this is the claim, right?
Oh, this is a size argument. But what if it just overshoots, like it goes to the other side of
What?
2n minus 1?
I like if this is true, then we are getting good progress. If this inequality is true.
Do we
Yeah.
win if this is true?
Almost.
Not win, but like very, very nicely.
Let me just check this thing.
2n plus 2 plus.
Okay, yeah, this is like
4n
easy to
minus.
check, right? Just sum it, whoever
Wow.
is timed.
Wow. How helpful. Very helpful.
Thank you,
Yeah.
thank you.
Just some.
Wait, not 2n plus 2n plus 2. Yeah, 2n plus 2 term.
My bad.
Oh,
I
arithmetic
just saw the
progression is fun.
constant here too, and I like just went plus 2 and
Plus
then I've got to
n
add
plus
2
1
and
into 2n plus 1.
do that fast. Thank you.
No, n plus 1 into 2n plus 3.
Yes.
Yes,
Okay.
Yes.
that's right.
Very
Very nice
nice.
summation.
Or
Very
in
nice
other words,
expression.
it's basically
8
10
plus
n
2
plus
plus
3. 10 n plus 3 times n plus 1.
How
Huh?
do you expand that fast, buddy?
Yeah, like just half this thing and
n
put an
plus
8
1.
in
N
over
plus 1.
here.
10 plus 4 is not 16.
Yeah, you have
Which
10n
fails.
plus 3 times n plus 1.
But 10 plus 4 is not 16, right? Right side is 16.
Why should
Left side is,
it be 16?
right side is 4 plus 1 whole square, 16. Coefficient of n
Yeah.
square. Left
Yeah,
side
so we win
coefficient.
for large n at least. Yeah.
No, we lose for large n.
Lose.
Left side is
14
10 is
seconds.
like. Did you?
Oh yeah, then we lose. That's sad. That's sad.
Yeah.
14 and 16.
Size arguments don't work.
That is unfortunate.
That
But
was a
4n
nice
plus 2.
bounding try.
No.
That just shifts everything by 1, doesn't like.
Like it doesn't change the coefficient of n square.
Yeah.
No, if you shift everything by 1, then you're adding the whole sum by 2n plus 2, right?
That doesn't change the
Then
coefficient of n
then
square.
the inequality holds.
No.
Coefficient of n square doesn't change.
Coefficient of
Coefficient of n
n
square.
square doesn't change, and if it
Oh,
does not change, then
coefficient of n
everything
square
is
doesn't
okay.
change. Oh, fair.
Should we recheck what we have done? Why is it not true?
Yeah, like
Why?
So
4n minus 3
again-
is like 4n minus 3 is the point where everything is as odd, right?
so an
How
is
much
equal to
2n
2n minus 1, right?
No, a2n minus 1 equal to 4n minus 3.
Ha. k2n minus 1. Let's just write it. Let's just write it as like simplest to get the
Arshit, are you still on the calculus idea?
No, I'm doing
Right.
slightly
Okay.
different stuff. I'm like trying to assume if some two AI values are like consecutive, if they're like x and x plus 1, then you can probably get something from that. And so they should be at least 2, usually.
Maybe we
Like, so
should
if
quit
it's equal
trying
to
to
1, at
prove
which
the
points can
stronger
it be equal to 1?
statement. We should
Can we
just
at
prove the
least
weaker
prove,
statement.
can we at least prove that there's very few like consecutive AIs which are like having difference exactly 1? So like zeroing in on that.
So
Maybe.
the difference is going to be 2 most of the time, which gives us.
Yeah, exactly. That's what we expect. Or at least 2 at least.
But if we just say equal to 4n plus 1 to this case, then we know that the sum of first 4n minus 3 terms is equal to 4n minus 3 squared, right?
No. 2n minus 1 term. Sum of first 2n minus 1 term. We know this, but we
No,
only
no,
have
we
2n
do
minus
know
1.
this. We do know
We know
this.
this.
And
We know this,
Yeah.
right? Yeah.
Yeah, we know this.
no, now consider the number a 4n minus 3. We want to prove that that is equal to, let's say,
That is
8n
for-
minus 5.
That's what
no,
we were
7.
doing, right? We were assuming that
Okay. Yeah, that is good. That's good
2n,
progress.
like p2n minus 1
Right.
P2n minus 1
is
is
equal
2n
to
minus
1
1 squared.
squared.
We know
And
this
we're
and we know this
trying-
as well.
Yeah.
No, does that imply a 2n minus 1 equal to 4n minus 3?
No, we are assuming this. We are assuming a2n minus
Okay.
1 is 4n minus 3 and p2n minus 1 is 2n
Yeah.
minus 1 square and getting a similar point later, hopefully.
Yes,
Hopefully.
yes. And can we extend that to 8n minus 7 as well?
I don't know if 8n minus 7. If anything we have is good, but we have nothing.
Yes.
The bounding is not first.
No,
The
like you want
bounding
to prove
is
that
not
a
bounding.
4n minus 3. Oh, but the bounding idea fails. That's sad.
Like why 4n
Maybe
minus 3? It could be any number. Why 4n
Yeah,
minus
it could be
3
like
only?
some interesting thing. We can just probably get some.
Like anything between 2n minus 1.
Wait, hold on. There is a very funny thing going on here. If some two consecutive things are off by 1, then one of them is a correct odd fixed point. So first of all,
Why?
if the statement is false, then multiple times it's increasing by at least 2. This is like very weird.
Wait,
that could be useful for what you're doing.
Sanity check what I'm doing. So like
Okay, what-
define P as prefix sequence.
Where
Now
are you?
suppose that an plus 1 is equal to an plus 1.
Okay.
And you have like, if you subtract, you just get that an plus 1 minus an. Sorry, pan plus 1 minus pan is equal to an plus 1 squared minus an squared, which is equal to 2an plus 1 minus 1. And this is equal to an plus 1. So basically, if you have something like that, then you already get like a correct fixed point. So if there is finitely many fixed points with odd thing, then that tells you that eventually, after a long time, it's going to increase by at least 2. So we get an.
So every increase will be at least 2?
At least 2, yeah.
That could happen in
That
bonding.
finishes.
That
just does it, right? Because
after a point, that does it. Like we have ak, and then for all what do you call n greater than k, we have an is equal to ak plus 2n minus k or something.
At least, not.
Yeah, greater than or equal to. And if you sum all of that, you win.
Yeah, because
take large and sum, and you get that ak is equal to 2k minus 1, and all them are the odd.
So the idea is like we take the last n, so that an plus 1 is an plus 1, right?
Yes.
Yeah.
And then an plus 1 is like even further.
Or you can even do like ulta. You can just assume that suppose finitely many fixed points with odd.
No, but you need this also. But you need that at some point you can assume that all the odd. Like you need the prefix and that value to be correct at some point, right?
Yeah.
And that also is given here because an plus 1 is 2 an plus 1 plus 1. That is there.
Yeah.
I think we're done, but the last sum is like very weird, and we need to formalize the whole thing. So like, let's first assume for contradiction that there.
No, it's like it's clear until an at least 2n minus O of 1.
No,
beyond that
is fine.
So the formal argument is this, right? Case 1, an plus 1 equal to an plus 1 occurs infinitely often. In that case, we are done.
In that case, we are done. So otherwise, there is a point ak such that for all n greater than k, we have
I think it's better,
an plus 1 greater than or equal to an plus 2.
I think it's better to state it like this. Let's say the last n, so that n plus 1 is an plus 1.
Okay.
So that's the last n. Then we know that an plus, like we know this.
Yeah, then we know that a n plus 1 is equal to 2 a n
Wait, can
plus
someone
1.
write it? I don't have mine.
Yes.
Yeah.
Yeah, and this an plus 1 is further away than n, right?
Hmm.
So this is, after this point, after
It's
an plus
increasing by
1,
at least.
Yeah,
increasing by at least 2.
an greater than or
and
equal to n is obvious.
Oh, this is a very nice way to write it because you already
Ah.
know that this is a fixed point, and then beyond that, it is certainly not fixed any longer.
It's a fixed point.
Okay, so in
Sum
that case,
so
we're
far
just
is also
proving
correct.
infinitely many increases by 1, in other words as well. But this is a nice way to write it.
Yeah, so like after this point, increases are at least 2. Up till this point, prefix is also correct. Because
Yes.
p n plus 1 is n plus 1 squared.
And
We
next, you
also
consider
know
the
that.
first time it increases by 3, or at least 3, and
No,
that's a
it
good
doesn't
thing.
matter.
It doesn't happen. That can't happen.
It might increase by 2 every time, but it's still fine.
It has to increase by 2 every time, right?
Yeah, that's it.
Because at this point, everything is correct. Like prefix is also correct, value is also correct.
Yeah.
Then after this, you can show it. It's right off. Down.
Wait, we need to formalize this properly.
But why is this formula?
This is
Yeah, this is fine.
Like at this point, at the an plus 1th term, sum and prefix match odd numbers. After that, differences are at least 2.
And that forces all of them to be at least like exactly 2.
So
Because if
exactly
it
2.
increases by
And
at least
exactly 2,
3,
and that
at
forces
that
all
point
of them
you'll
to
have
be
a problem.
the odd numbers as desired.
And it's
But
because this
that
value is also
forces
correct.
statement is.
So it's like very strange. We do not have any characterization for the sequence. Like it's like some of the things get swept under.
Like it's possible that plus 1 occurs infinitely often. That's not a.
Yeah. In the case where plus 1 occurs infinitely many often, like there is no characterization. Like it just hits the odd numbers infinitely many times, but it can be some random thing otherwise.
Yeah.
Oh, honestly, both of these are like scam.
This one's not scam. This is nice.
Nah. This one is like more scam than the first one.
Yeah, like just
First one was
randomly consider
ultra
differences
scam,
as
right?
one. Like, nah.
Hey, that's a nice idea. Okay. Are we
Let's move
sure
on to the
that we are
geo
done
now.
with this? What
Wait,
if we
yeah.
fix all this? That'll be very
Hopefully-
sad.
Did we fix?
We haven't.
So we have complete formal proof.
Yes,
That is
we have
not
completely.
formality.
Can you just like
I disagree with the formality.
I mean,
Wait, come here.
Yeah.
okay.
Wait, Eben,
Where is Aditya?
yeah. Is this fine? Is this part clear? Is this part fine? Is there any
Yes.
fix over here? No, right?
Yes.
Everything
No
here is
fix
true.
out, no fix out.
So the two important things here: p n plus 1 is n plus 1 squared.
Basically,
Yes.
we know that an
These
plus
are
1 equal
equal.
to an plus 1 implies that an plus 1 is equal to 2an plus 1 minus 1.
Yes.
That is the important part.
So
And
this
that
thing
with
is
the
true.
differences of 2 finishes basically.
Yeah, because at an plus 1 term, prefix and value also match, both match. And after that, differences are at least 2. Right, but even if you look at the an plus 1 term itself, because of the an plus 1 term, or
Can we write this up on AUPS or something?
Yeah, we'll write after like stream.
After
Maybe
the
like
last one.
stream that.
Maybe after day 1 we just write everything on AUPS and then do day 2.
No. Do it all at once, like I think.
Yeah.
Sure. Okay. It's time for the geo. I don't know if you fix all this, but it's time for
The
geo.
geo
Oh,
play of the first.
Yeah, I also don't understand the full solution.
Okay, back to fan art.
Oh damn! Someone attach this somewhere else.
Someone do it.
Okay,
Thank you, someone.
Hopefully,
I will do
hopefully this
it.
is not scam. Hopefully.
The orthocenter
it
of
is
the
P3.
triangle
P3 is
is
like
the point
least
of intersection of its altitudes.
Who's pasted it well?
I pasted it.
Where?
Where is it?
I can't find. Okay, I found.
Okay, please check.
Oh, I can't
I
find.
do not see the pasted thing.
Follow.
Yes, I found it.
Come to
Follow anyone who's on your screen and then you'll reach.
I do see.
Who's
it
drawing
now.
diagram? Who's drawing diagram? That's the first person.
I will draw diagram using magic pencil.
No, please no. No magic pencil.
No.
Let
magic pencil. Wait.
Let Archit draw the diagram. Let Archit draw the diagram.
Okay, sure.
Magic pencil is cringe. Magic pencil
is so good.
Sometimes it doesn't work though. Sometimes it does cause an issue.
And then you'll have like half good and half squiggly. Like that's wrong. You just have all squiggly. All lines should curve with some curvature.
Just make
half good is better than 0 good.
I guess like the triangle should be like a bit more obvious.
Oh my god, this is that random config.
What?
Okay.
Remember, we were discussing this kind of at some point. Like, is there some properties true in
Wait,
this?
guys. We should work
Is
with
that
triangle
trisection
ABE.
points?
Yeah.
We should not work with
trisection?
ABC.
Oh
Yeah.
no.
Random ratios will show up now.
1 plus
Wait.
5?
5?
No,
We
it
should
was like,
it was
it was
work
like
on
3 plus
triangle
root 5 by 3 or
ADE,
something.
Yeah.
and we should
Wait,
make
what?
B and C later.
Read the problem first, bhai. Like, I haven't even
No,
read
just
the
look
problem.
Wait.
at it.
Get
It
rid of
is
this
the
diagram. This
it is
diagram
the-
is like very bad wrong. Like this is like very weird. Not wrong, but weird.
What is going on?
Just
Why are we not
look at the
centering?
problem. Everything is based on ADE. Like no one cares about B and C
Okay,
in the problem.
fine.
This is very interesting because if you are reflecting
It
P
is
over
very
D,
bad.
then after a certain inversion, it should become very good. Like if you root PC invert, then all of these points will be
Yeah.
harmonic points.
I think
So that's
midpoint of
what you-
arcs is what you get. I'm not sure.
Midpoint
No,
of
midpoint
arcs.
of arcs.
Midpoint.
Of course you
No,
don't.
not midpoint of arcs. You get the harmonic
Yeah,
points.
harmonic.
Somebody name N. Why is N?
Yeah, name then.
Yeah.
HV source center. P lies in lines BM and CN.
DHMP cyclic.
So it's like
I-
DHMP
I-
cyclic. Any 2 points.
No, DHMP
No.
cyclic. It's
P
unique.
is fixed. P is fixed.
So it's-
Okay, that's okay.
Somebody decided.
Wait, this is also true, right? Surely. I mean, no. Is that true? That should be true, right? By power of
What is
Come on,
true?
it has to.
No,
it has
it's
to.
not true. It's not true. It's not
Oh,
true.
what
What
am
is
I
true?
drawing? What am I?
EH and Q are
It is
cyclic and
asymmetric.
pairwise
It is
different.
asymmetric. What the hell?
No, it's not.
Yeah.
Why is it asymmetric? It's totally fine.
They said EH and Q are cyclic. They've given you that.
Somebody draw CN properly.
Somebody draw
Yeah,
CN
I
properly.
will
What is this
fix
CN?
CN is scuffed.
Hold
Yes,
on.
and
The pen
faster
thickness is completely wrong, and you're not color coding. Like this is a very bad idea.
Yeah,
This will not
magic
work.
Yeah,
pencil,
like-
just trust in magic pencil.
No. Whose line is
Somebody
this?
said 1%.
Like,
1%
let's
draw
just
the
1%
diagram.
draw the diagram. Let's just
Yeah.
1% draw
Okay,
the
yeah,
diagram.
People will put drawing the diagram.
Wait, what's the BM?
Wait, why is
This idea-
BM
this
like
CN
some
is better.
random
This CN is
squiggle?
better.
Like
Okay,
nothing
what
BM.
about
Bro,
What is
let 1% draw
Bro,
the diagram.
stop.
Please.
Like everyone stop.
Please.
Okay.
Please.
I'm drawing
Who's drawing?
I'm drawing a slightly fresh diagram a little below.
Yeah,
I'll
let
do
us-
it.
Only Archie draw that. Only Archie draw
Let
that.
Guys,
Archie
we
draw
should
this.
ditch this
I'm just
diagram.
deleting. I'm
We
just
have
delete-
this diagram. We can use.
I deleted it. All gone.
Yeah,
We shall do things
I'm
nicely.
deleting the scuffed one. Okay, so it sucks.
Yeah, completely deleted. We'll draw a
Okay,
better
sure.
diagram. Thank you.
Why
Color
statement
is very
deleted?
bad, Archie.
Why statement deleted? Somebody bring
Why
statement
statement
Statement is
deleted?
coming back. Statement is back.
Okay.
Statement is back, guys.
Okay.
The magic pencil
this-
diagrams are not
Actually,
going.
are you working on?
Magic pencil is the best.
Nah.
Okay.
Circle,
Wait,
circle,
but where's
diagram.
the circumcircle of ABC? That is no ADE.
Yeah. Why we need circumcision?
Sure.
I mean, why not?
Circumcircle could be
Always
useful
just
in-
circumcircle.
It's just a good practice.
Yeah.
Whenever you have a triangle, just draw the circumcircle. first.
Just draw the circumcircle.
But like,
It's like superior.
Why not draw the incircle?
No.
Wow. I think
Incircle is
let's
not
draw
good.
like every possible.
Let's draw all X circles.
Let's draw the trisection point.
Let's draw the Seba circles or something.
Let's draw the trisection
Why is it
point.
dotted?
Let's draw the mixed linear insert.
Because
Yeah.
we don't know if the circle exists. Because this world could be unreal. You never know.
Wall could be unreal. Jaldi bana diagram.
I haven't read from
Wait, Arjun made the diagram. Make a diagram.
P and
Can
Q
you
lies
draw
on
DN and EM.
HMP
What
cyclic.
statement? PQ and M cycle.
Oh,
Power
I
of
see.
point.
I see. This is a.
How about we just rephrase, like, make this B and C
Oh, does it lie on the circle? Is
and
that...
Okay.
like make these D and E?
No, we
How
can't
about
rephrase
that?
like that.
Why
confuses
not?
Do it
the
later.
problem.
Brother,
Do it later.
I don't want to work with H as an orthocenter of
I
AD.
agree, but like H is the
Let's do it
orthocenter of
later.
AD.
The
Like
diagram we
they
drawn,
made
let's do
this
it
just
later.
to confuse people, but sad.
I mean, it won't confuse once you start doing.
Yeah, like just
Nah.
just
We're not
It
renaming
would
them
confuse
to
random
D and
viewer
E.
who comes in between and then he's like,
nah, we messed it up completely.
So let the diagram be drawn first and then we'll rename if you want.
Fine.
Okay, Arshad, circle.
H and E.
No, guys, if like Malay comes in randomly and sees DC, DE switch, like it's not good.
Wait, do they meet on DE? Do the circles meet on DE?
Ooh,
Maybe.
interesting.
Oh, okay. Yeah,
It's a-
that's
No.
the
Why?
awesome.
No. Why is AM and cyclic?
HM and ANs are not cyclic. That's not true.
Okay, maybe some homogeneity sort of thing from
M and PQ, do
What
they
is
look
this?
cyclic? They're
you have to show PQMN cyclic, right?
yes.
Yes.
H inversion.
Let's do
H inversion.
Let's do
What are
angle
those?
chasing
No,
first,
let's
guys.
not
No, but
invert,
like,
Let's
let's
start
not
angle
invert.
chasing. It's not angle chasing.
Yes, yes.
Thank you.
Angle chasing is
H-
for
Angel chasing is the
HMP.
best.
Okay, that's
HMP is
He has some good angles right
no.
here.
HPM is fine. HPM is better.
okay. Yeah,
Yes, this
it's
is
like 90.
very nice. 90 minus A.
Yeah.
Like,
It's
okay,
also
good
90
angle,
minus
but
A.
like, how does that help
Ooh.
in proving it's cyclic?
Brother,
oh
we shall go slowly. We shall go
Oh,
slowly.
maybe what if this point is this is a parallelogram or something?
That
Yeah.
might be a
And like this
parallel.
is a reflection of
PM and
H, and then
CM
you
slope
just
is
use
wrong.
power of
BM and CM
point to
angle
win.
is not going to be nice. Why is
Yeah,
random
it
Yes.
can't be
bisection
nice.
going to be
It can't be
nice?
nice. It
But
can't be nice.
neither is PH and nice.
Yeah.
Yeah, so both are non-nice. Oh wait, that makes
Wait,
no
I
sense.
do the wrong. I do the wrong.
Yeah,
My
you
bad.
draw the okay. This
What
is
did you do something wrong? Oh yeah.
yeah. Yes.
This.
HQ. Okay. Now it makes sense why it's not a parallelogram.
Diagram wise, diagram is not there.
The diagram
is
is
here.
squiggly lines, guys.
Prove that you believe whatever the diagram makes you believe.
Okay. Can you prove
That's
that
okay, because
this?
is
Oh
good.
wait, aren't we just
Don't
doing
do that.
radical axis? Yeah, just prove that these are collinear and you win. Just do radical
Ah,
axis.
Yes,
right,
yes.
right,
But
right.
like how you show
Like
Get
that?
that
radical
kind of
axis
structure.
for the win.
DHM and
Wait, this should be,
DHM, do they have
be
some
like
point on
very,
it?
very doable with trilinear or something.
With complex bash or
That's
Barry
No.
bash. Easy
Barry.
with Barry
Why?
bash. Like
Wait, I mean,
D, M, N, everything is good. Except for the orthocenter, everything is good. So we can just like
What even? Why? What is this?
do a
Okay,
root
wait.
see
This point.
complex bash.
This
Even
point is
the
actually,
orthocenter is good.
guys. Wait, listen.
Guys, let's complex
Okay.
bash.
Wait, no,
This
what
point
kind
is
of what
very
can you
nice.
say?
Guys,
This
What
point
guys,
is nice.
No, wait. What?
calm
Oh my
down.
god. So call this point X, then MXN is 180 minus 2A.
What?
Okay. Yes.
Yes.
angle chasing.
Yes.
And yeah, so R
So
is
That's
MX
nice.
X
That's
is the
nice.
angle
Nice.
bisector.
Is
X
R the
And so,
center of MA?
X is
No.
bisected as well.
What am I?
No.
yeah. So
it's angle
wait,
bisector
we
as well.
can draw M in line. Wait,
It is R the circle.
we use this condition, right? Probably like because like M is midpoint, you can like MD is parallel to AC.
Is XMRH
MD is
XMRH?
Like,
parallel to ME is
you know,
parallel to
Let's
AC.
if you introduce
So
circumcenter
ME.
of AMN, if you
Okay.
introduce circumcenter of AMN,
It
then
can't
you
be.
have
It
this
can't be.
cyclic.
That would
XR
be
passes
very
to
wrong.
circumference of AMN. XR passes to circumference of AMN.
XR passes through
XH,
its
XH,
circumcenter.
XH.
Yes.
XH.
So
Circumcenter
you
of
want to prove
AMN
that
lies on this
R
line.
also lies on that nice line.
Huh. That's what you want to show.
That should be
Yes.
very doable.
Yes.
Yeah, like now it's just
Now complex bash.
Now
brothers.
complex. Like
Okay.
before
No,
also
like
complex bash
obviously
was now
complex
also
bash.
complex.
Yeah, it'll work. It has to work.
Yeah, like you just want to
No.
prove
Sure.
that.
So now you replace to AMN, right?
And now let's
Yeah.
just
No,
rephrase
now
to AMN.
yeah. You don't rephrase to AMN. You just want to prove
Wait,
that
not?
H, O, R are
Wait,
collinear.
Euler line, bro. Euler line, right?
What?
No,
What?
no.
No,
H
like
is not the
AMN.
orthocenter of
AMN.
AMN. H is
H
the
not
H is
orthocenter
like the
of
foot.
ADE.
Yeah.
What is
No,
H? H is going to be
H is
double of
Wait, no. If you use this very well-known fact about this ratio, like this ratio is good, right? This ratio you can literally compute by Cheva or whatever.
Yeah, so
This
you
is
can
so
get R. You
bashable
can
that we
get
should
R.
just straight up
Mean loss,
bash.
not Cheva.
Yeah, you
What
can
is
get
that ratio?
1
Just
by
want to show
4.
some random Barry
This is
point.
1:2, and so
What?
Why is that 1:2?
I mean
Wait,
AQ by QE.
why O line?
Why is AQ by
like
QE
this
1?
point S1, then AS1 by S1E
Yeah, I got it. Why is it 1:2?
2
is to 2.
into 2. That's it, 1:2. Yeah.
Why?
But Menelaus.
Menelaus by.
Oh, good check.
How about we do some harmonics, guys?
And so this is 2 to
No.
3.
Why is no one listening to me?
No. It's not 2 to 3. It is 2 to 3. Is it? What am I doing? Yeah, it
Wait,
is
just
2 to 3.
Menelaus
Sorry,
at
dude.
fast. Isn't it 1 to 2?
AS1 to S1, E is 1 to 2. AS1 to S1 will be different.
Guys, is anyone against bashing here?
Yes.
Yes, thank you. Let's just. I'm gonna draw a new
Dude,
diagram.
this is not
recent
bad.
into-
It's just
That's
figuring
false.
out that ratio and then
2 is to 3
resending
is not good. 2 is to
Menelaus
3
is
is not
not
correct.
bash. Guys.
R, you have R trilinear. You're done.
Wait, no, 2 is to 3 is not correct. How is 2 is to 3 correct? If it's 2 or 3, then it's 5.
This is 1:2. So like let's assume
This
the
is
total
1:2,
state is like
exactly.
3. Then this is like 3/2 and that's 1. So 1/2. So this is 2:1.
Wait, so now you have
Wait,
like
2, 1.
S1,
Yeah, 2
S2
is to
is
1.
also like
Yes.
parallel, right?
Yeah. Okay,
So,
yes.
parallel with centroid.
R
or
is
something.
median. So R is a median.
Okay, yeah, 2:1 and so.
Okay, this might be good. Like, it's not bad. This is just.
Okay, fine. This is not bad. I
That's
believe
what I'm
you guys,
saying.
huh? So,
This is not bad. This is like random ratios and win.
But the problem has random ratios. Like 3, 1 is to
Yeah.
3.
Yeah, like the problem is given with
And now-
BD equal to D equal
You
to
want to show
Yes,
this point, circumcenter and double of altitude are collinear.
reflection of Earth center.
No, not reflection for the center.
Wait.
Double of for the center.
It's
Homothetic.
reflection. Like basically this, right? H prime
Yeah,
is
yeah.
that AH is equal to H.
No, it's just
I'll
the
read the
midpoint of AH. The midpoint of AH is the ortho
No,
center.
no, no.
Or
H is the double of A.
the reflection of H in
A and
A.
H, yes.
A.
Yeah, whatever.
You want to show this
Bad
here?
diagram.
What is?
Bad diagram.
And how are we defining R again?
R
Wait.
is this ratio 2:1, 2:1.
Oh, okay. R is just defined by the ratio. This is so
Wait.
bashable.
Oh,
This is
wait. What's
bash is
O is the
speaking out.
circumcenter of?
This is also
This is also
This
like.
triangle. This triangle.
Okay, so
So
wait,
Why is it called
Yeah.
H dash? Call it
why
H. Why
it
call
has to
dash?
be like
अरे
why?
पुराने प्रॉब्लम में ये H है ना, that's
I mean, but
Okay,
we're rephrasing
so-
entirely.
Okay, hold on.
Rephrase
Just
problem.
hear me
Yes.
out. Hear me out.
Okay,
Hear
fine.
me out. Like, don't judge me. Hear me out. This is 0. This is
No.
Oh no, we are not hearing you.
No.
this is A plus
Hearing
B
some.
plus
Bro,
C.
this
Hearing
what
some,
is the
hearing
bash?
some.
Like, okay, fine, wait.
And this is computable.
Okay, wait. We're done. We're done. No bashing.
Oh, you're
No
done.
bashing, thank you.
Makes sense. It should
So,
be
A-
doable.
No,
AR
why,
upon-
why,
AR
why
upon
is this a
RMS4.
P3? Why is this a P3?
AR upon RMS4.
Here upon RMS4, yes.
That should be
Yeah.
easy.
Yes, that
Right?
is 4.
Okay,
And
yes.
AH dash upon OMS4.
H.
What?
Are you using? Oh wait, bro.
Oh,
Just look at
Oh,
this.
AH dash upon
okay,
OMS4.
sure.
Done.
Oh no.
Oh, we're done. We're done. We're
Yeah,
done.
yes,
This is
yes,
like
upon
OM is
OM4.
R. This is
Yeah.
2R. Wait, no, not 2R.
No, AOM is not
This
R.
It's not
Wait,
R.
why,
This
why
is
is OMR? OM is not R. Wait.
OM is
Yeah.
it's a
Give it a
fact.
different
H
This
to
is X,
OM.
this is 2x.
Call
this
it
is
X.
2x.
2x,
And so
yeah.
like,
Guys.
4:1 done.
and
Okay,
because this is false to 1, we intersect at R. So we're done.
So we are done.
Lovely.
Yes.
Lovely.
Oh my
Wait, by the
god.
way,
This is the
can you tell
biggest
like
scam in existence.
Wait, what?
why O has to lie on like RH?
Yeah, XH bisects. XH bisects and MX and O are cyclic.
Yeah.
LHS. And XH bisects. And OM equal to OM.
Wait, why MH O are cyclic?
Angle
MX
phase. MX sign is 180 minus 2A.
Oh, okay.
MO is in a
Yes,
180 minus.
okay, makes sense. Yeah. Okay, yeah. Done. We're done.
What a fraud.
Oh my
Wait,
god.
the
wait,
difficult part in this
that was
problem is-
too fast. That was too fast. Like,
The
have
difficult
we
part in this
reduced the
problem is-
problem to proving that HOR is collinear, right? That much. we
That's
can-
OR. Like we
Yes.
replaced
No.
problem, it became H dash.
Oh, okay. So you're
The
centering
difficult
it
thing
at
in this
AM.
problem is
Like,
to
sure.
avoid the urge, resist the urge to complex bash. That is the difficult thing in this problem.
Okay, so you have ABC and you have these weird ratio which define
Yes.
R, and you
Yeah.
have the reflection of the ortho center which gives
Yes.
you H dash.
Yes.
Prove that H dash. How is this even true? Okay, yeah.
Like,
let's
It's
say
true.
this is
The
a-
diagram is bad. Diagram is
True,
bad.
we just
Yeah,
proved
but-
it.
Okay, so
See-
how do we prove it again? Let's
So
just
OM
prove
is
it
to
again.
H dash upon OMS4.
So you just have to
Yeah.
show that some ratio is something, right? Like look at this AM ratio. You just want to show that this divided by that is like some certain ratio.
Wait,
Wait.
Equal to
So
like this by this.
X
Wait,
is
what
equal
would
to
explain?
OM, right?
Okay.
Yes.
Emil, listen. The OM is like some ratio, and 4 times of that is like H dash. And we
Why?
also
Why?
proved like
But that's
because
some
like
well-known thing.
True.
H
equal
H
to
is
OM.
2 OM.
H is 2 times of OM.
Oh yeah, H is 2 OM. Yeah, okay,
Yes.
4x.
Okay, and then we know like AR by RM is 4 by 1. So this is
Also
just like,
ARM collinear as well because
Yes.
of
yeah.
Seva.
Yeah,
Seva.
ARM collinear by Siva or something, and then
And then you're
Yeah,
AR
done.
by
yeah,
RM compute.
You compute.
If you want
that's
by your areas or whatever.
whatever
So,
you
so
want.
we are bashing
No,
under
it's
the
similar
bridge,
triangle.
basically.
Areas,
Wait,
areas.
formalizing.
Yeah,
Tell, how are we
We don't
doing
need a
this?
bash. Like this is
In areas.
It's technically yes.
Yeah.
Area bash is like the mildest form of bash, but it's still a bash.
It's
Computation.
It is ratio of lengths. Like
It's called
just-
IOQM.
Yeah,
It's
it's just
called
length
IOQM.
bash. Okay,
Yeah.
I agree.
Yes, it's just kind of length.
It's
But
called
we are
IOQM.
done like
Bro, this
I don't know
problem sucks.
why
Okay,
it's
let's
P3,
go to the
like-
next
So
one.
honestly, like this, all these problems are like scam.
Yeah.
But
Telling you,
P3
random
is the
ratio of
scammiest of them
targets.
all, and P2 is the best problem.
No. I think
No.
Peter is like the most scam.
I think P1 is the best.
P3
problem.
is the most scam.
Okay,
P3
wait,
is
this
the
problem.
most-
Why is it a
let's just
P3?
do one more scam Geo then. Yeah.
Oh, 4 is also
Uh,
Geo.
Yes.
Okay.
what
Okay,
else?
guys,
My
we're done
God.
with day 1, right?
Yes.
Yeah,
yes,
done with
yes,
day one.
Scam day.
Yes, scam day one. Total
What is
scam.
scam day 1? You know, where the hell is...
Okay.
Now D2
uh,
must improve.
intersect.
Okay, someone paste day 2, please.
Someone
Yeah,
paste
okay, we just like paste P2. Okay, I will paste D2.
just paste the entire D2.
Okay, sure.
Where are
Also,
you?
someone should check
Paste it-
stream in between
Paste
if
it
someone
here,
checks
paste it
stream.
here.
Guys,
Oh,
if
yeah,
someone-
yeah, yeah.
I'm checking stream. There's nothing.
Everything's fine, right?
Evel, come down at like the P3 only.
Oh, there, okay.
There's nothing
Yeah.
special in stream.
Okay, bro.
It's
Okay.
working.
Okay, we are
Okay, you
here.
only
This
put problem
PQ.
4.
No
Oh
question.
my.
And consider RM parallelogram. Okay, some random.
Where?
In
the
center
hell?
config.
Why is it 2 over there?
Okay,
A2.
perfect.
Yes.
It's
Wait,
A,
what's the
it's
R? Okay. So
AQRB.
QRB.
Q.
Bro,
That's R.
that is
Lovely.
cringe. Wait, I've seen
No,
this before.
Wait, AQRB is reflection, right?
Parallelogram.
No.
AQ.
AQRB. That's
AQRB.
here.
Oh, that's even worse.
Yes.
That's worse.
Oh,
That's
wait.
worse.
Then we
That's
have
very
BQ is equal to BR. Like this is some weird parallelogram where the triangles are isosceles.
Okay. So T.
It's not even a rhombus.
Yes, like what even
So
is
this
this?
is
No,
this
it's
is
not a rhombus. It's a
Wait, no,
parallelogram
guys,
where
guys,
these,
don't
these
draw things.
zigzag
Don't draw
lines
things.
are
It makes it
equal.
Guys,
inconsistent.
no one draw things. No one draw
Wait,
things. No one
no,
draw
no,
Only
things.
no.
Only Archit.
Wait.
Only Archit shall draw the diagram. Everyone
But Archit's
remove.
not here. Archit's doing what?
What is
where
Archit
are you?
doing?
I am drawing.
Uh,
I am drawing.
Archit is doing fan art over there. He's...
No, I am drawing.
Archit, don't
I'll do.
write.
I'll do fan.
I
Don't
literally
worry,
do this
Archit. I'll
whole
do
thing.
fan.
Like, get rid of this line. What is this line doing?
This is 90 minus C.
Now, what do you need to show? We need to show T is the intersection of RB and SC. DDIT incoming?
DDIT,
No,
nah,
no.
bro.
This is
No.
P4, bhai.
There's no.
Before.
Wait, okay, so this is like RB.
What does
Can
E4
you
have to do
draw a
with
better
DDIT?
R?
This is like angle C.
Yes, you should at least try to do with the video.
Wait, S should. Okay, yeah. That's
R is
that's
anticyclic,
better.
right?
That's better.
It's
Yeah.
just
Not C. That's
chase
not
this
C.
by.
That's not C. That's
Not.
C by 2.
Yes. What?
It's angle
No,
C by
it's
2.
C. It's C,
No.
I guess.
QAB C.
Because
By
like
2.
AQB is 90, 180 minus C, so RB A also 180 minus.
You know, RBA is 180 minus.
Oh, okay.
Wait, I feel like
C by 2.
BTIC concyclic and RTIC
Wait,
No,
concyclic,
C by 2. C by 2.
Okay,
Yeah,
C by
yeah,
2.
yeah.
which basically tells you that I has to be the spiral sim sending DC to
Okay.
RS. That is what we want
Yes,
to do.
yes.
This is my
But
conjecture.
how do you have BTIC concyclic with him?
I think because like you can angle chase that, right? Because BT parallel.
Yeah. You know angles. Like C by
Yeah.
2 and the B by 2 over there.
Yeah, we know
You can draw B
angles,
by
so
2
we
over
can
there.
actually, we might as well do the computation and prove that.
I mean,
BTIC.
bro,
No, we
look
did
at
it.
this.
BTIC is
Look
done.
at this.
We
Look
just
at
did it,
this
right?
angle is equal to this angle,
Okay,
which is
yeah,
equal
fair,
to this
fair.
angle, which is equal to this angle. Happy? Okay.
That's better. Okay,
So we're-
so we have BTIC. We want to prove
Now we
that.
just want to show IBC and IRS are similar, which is again complex bashing.
Yes.
Like if I just write out
We're not
ABC
that's not
and do
complex bash.
everything.
We are
No,
not
That's
no,
not
complex
complex
bash.
bash. That's
That's not
similar.
No, this is going to be a very
Very,
trivial
very
complex
easily
bash. Like
proven.
believe me.
Bro,
Like,
but let's solve it two
just-
ways.
Just
Let's
let's
solve it
solve
two
it.
ways.
Yes,
Let's solve it
thank
two
you.
ways.
Thank you. My God.
Just
Bro is
stop.
not stopping. Bro is not
Bro,
stopping.
stop bashing.
No.
We can prove IBC similar to IRS very
We just
easily.
solve. We just ignore.
We just,
Yeah, we just
I
ignore.
mean,
I'm
it
going to
depends
get
where
it
Abel
before
is.
you guys. I'm like
Okay,
very
we just have
Yeah,
to
yeah,
like prove like
Sure,
Archit already
bhai,
maths where
Archit.
Abel is.
Okay,
Abel is studying.
What is bro doing?
What is R? Oh,
No.
R is what?
Okay.
Okay, Archit is
Actually
just
done, I
despoiling the diagram with random equations. Like, stupid
I'm
stuff.
actually just done.
Actually
at
does.
this.
He's actually done though.
You have to compute ratios and prove they're equal.
And now it becomes like if I
Yeah.
subtract everything, if I make I equal to 0, then that just like brings
Okay.
R good. Like R becomes what? Just subtract it.
But you have to do ratios. You have to like write some equation and prove that it's.
No. I don't have to. I only care about similarity. So I will first
Wait, no,
subtract and
I want to
scale
do
that.
some easy angle chase to prove this.
Yes, thank you.
Okay, can someone compute IRS?
Wait, we
Very
can
nice
just
angle.
compute the things, right?
Wait, I'm done.
Wait,
Wait, BR
we are
upon. Wait,
No,
we
we are
can prove
done- we are
IBR
done
is similar to ICQ.
No, guys, I'm done. Like,
I'm done, yeah. But,
so this side is equal to this side is equal to this side. This
yeah.
side-
Yes, thank you.
Yes,
And
yes.
this ratio are like these triangles are similar, so the BC is parallel to RS and
Oh, so IRS
done.
is similar to ABQ.
No, what you're proving is IBR is similar to ICS. IBR is similar to ICS.
Yeah.
I'll be
You want to prove that BIC is similar to RIS.
no the T, yeah, okay.
But now the whole thing is similar to like QAP.
What? No, like, so what you are proving is IBR is similar to ICS first. And that's because IB by BR is equal to IC by CS.
Yes.
Easy to
We
prove.
prove that BIC, yeah, okay, sure. But
Yes.
the end result we want is BIC similar to RIS.
Yeah, if IBR is similar to ICS, then IBC is similar to IRS. Parallel.
Yes.
I am also
okay.
done, by the way. Just to let
We
you
also
know.
done. We
Nah,
did
nah.
before you.
We did it before you.
No,
We
no
did
comment
it
for you.
triangles.
No, like I was
That is a
done,
computation. You
I
have to
was
prove
done
it's equal.
mentally. No, I was done mentally. Like I knew it's
Yeah,
going
done
to work.
actually.
You
That
guys
is
didn't
definitely
have
not
that
good.
faith. No, you guys didn't necessarily have a provable faith. Like I had provable faith that it would work because these all expressions
Well
are
done.
like,
We-
I am
we
also
just-
done. Like, this
Okay,
factors out.
well done.
We
We
did
solved
okay,
it
okay.
twice.
actually done.
Okay. I'm pasting the P.
That also
Okay.
reduces to B plus A by C plus A.
Okay.
Can we
Guys.
go to P5?
Yes,
This
yes.
just
I'm
this is just
pasting
proof that
the
if you
problem.
have brain and if you know complex bash,
Guys,
everything is going to work.
guys. Turbo snail
Yeah,
is
like-
back.
Both
What?
the geos are just bashing.
Yeah.
That's
Guys,
so sad.
Turbo's back.
Turbo is
Oh,
black.
turbo
Oh
is
my
black.
god.
Yeah.
And
Oh
it's
my
a
god.
gold.
Answer is 2.
Ah,
Yeah.
okay. We are N into N board.
I think this is the first real combi we've seen.
Okay.
No, like
Oh.
yeah,
Yeah,
correct.
it is supposed to be the first copy.
Yeah, like P2 was algebra. That's fine. We have NT algebra, Geo, and then Geo combi, and probably NT maybe.
Bro, I have literally seen 5-6 problems this year based on exactly this. Like
Counter
not even
problem.
lying, like on random places.
No,
I
you know,
can
like
confirm those answers.
2025 is the
Yes.
year for square grid problems. If
Yeah,
you can
square
make it
grid
45
with
into
arrows.
45.
Arrows placed in
Arrows.
places
Yeah.
and it's
Sure.
following.
But like 2048 will be the best year for combi problems.
Oh
Spam
my
powers of
god.
2.
Wait, why didn't they put it
Right?
45? Why did they? Okay.
Oh,
Wait,
interesting.
so all cell like rotate by
Wait, is the name actually Turbo the Skibidi? Okay, it's not.
Wait,
No, no,
wait,
so the trick here is that
wait,
after each
why you
move,
draw
the arrows
such a
turn.
large diagram?
That's
What
the
is
that's
7 by 7?
Oh, who is drawing random arrows? Like, what are they doing?
And
No,
then
the-
what is 7?
And who is draw 7 cross 7? Start with
Yeah.
some like 1, 2
No,
cross 2
no,
or
7.
something.
Okay, wait, just take the subset 3 by 3 square of this 7 by 7 and let's work with that.
Okay, sure.
This is the
2 cross 2
subsquare.
first.
No, so like
2 cross 2.
so
My
like the
god,
weird
what
thing
is going
here,
on?
It's
the weird
fine.
thing here
It's
is
fine.
that the cells rotate 90-degree counterclockwise after you move. That's the weird
Guys,
part.
wait,
So, drawing
counterclockwise
arrows
is
is-
this.
Okay,
The
so
arrows
instead
change
of
Fix one
size.
thing.
the cells
Fix one
rotating, can we make turbo rotate maybe? Or like make it equivalent to something like that?
But the
Um,
grid, it's like the grid.
No,
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 no, that will not
No,
work.
that's
So we
fine.
can't-
We rotate the
Like
grid
that's
maybe.
rotating of thing is very local change.
Yes.
Yeah.
Everything else
Yeah.
is very global.
Yeah.
Sure.
We have to rotate whole arrows.
Just the
Okay,
arrow.
that's fine.
Back
Do we
to
actually do the process?
Start
Arrows
with-
all
Okay.
cells rotate
Wait,
90
wait.
degrees.
We should make 4 copies. We should make 4 copies.
Yeah.
With multiple rotations and you move from level to level and they're like placed.
Yeah, and then you
weird
return back to the first level.
circular
Okay,
thing.
fair.
Yeah.
Sure.
Okay.
Okay,
I'm making 4 copies.
you know what? I think Kana is right. We should do a
No,
2 by
don't
2.
put it this way. Like you need to stack them so that they come around circularly. So it's sort of like
No. It's a cycle like
it's a right
before
point.
seasons.
so it's like no, it's like make it sort of circular. It should be
Yeah,
like a-
like no. Look at the 2 by 2.
It's
That's what we
3D.
want.
Let's just
3D,
do
can't
2
do
by
it.
2, guys. Someone do 2 by 2.
I agree. Let's do
You
a
can't
2
do
by
it
2.
by one.
So it's like you have this random graph.
But let's see the statement.
No, so you have this random graph on 4n square vertices, and you want to find the number of cycles that it could have. No,
But
not
the
the
point is,
No,
it's
no.
not a random
but
graph. Like there are a lot of
Okay.
you want to
things to
visit
it.
everything.
Yeah, we have to
Wait,
find
no,
90 degree
Hamiltonian cycle.
clockwise.
we don't
Hamiltonian
want to
cycle.
visit like all 4n. We just want to visit like all squares.
Oh, okay, no,
When
yeah, all
you
square.
stop,
Wait, are there n where you can visit everything?
Like,
that's what it's asking,
even you
right?
cannot even see what you.
No, it's
Exactly
asking
what it's
if
asking.
if you can visit every cell, but not necessarily all 4n square cells, only n square cells.
No, I mean,
Okay.
like, can we obtain that starting from any cell you're going to win eventually?
Wait,
So it's sort of like,
I think like what is it asking? Like, do we just have to reach out at the original cell like once, like cycle back once, or do we have to like completely just keep on
you
cycling?
have to visit all cells and you have to reach back to the original cell
Yes.
eventually.
Hmm.
And
So we want to find
You
the
want to fall off
biggest
after that?
cycle, the biggest possible cycle.
No, why does it matter?
no, not
Hmm.
biggest possible cycle.
And
Wait,
there is something
Why
special
does it
with a
matter?
cycle. Like you
No,
have
why
to
does it
visit
matter?
every cell exactly once in some sense.
No, so
Yeah, and
this is
after
across the
when-
4 copies. So it's a bit
Why do you want
tricky.
after?
Yeah,
No,
and
why do you
across
want
the 4
after?
copies, the vertices, the 4n
After do you
vertices are
fall off or
divided
what?
into equivalence
Why does
classes
it
or
matter?
something like that.
Like you just stop at there, right? Once you
Yeah.
just
Why
come
does it
back
matter?
and you visit everything, you just stop out there. So,
Why
like
does
you
it
can
matter?
just keep on doing it again and again, and then it fails, right? Like
No.
No.
Okay, no, you stop there. Like, is it
It
possible
says
to
stop
go
exactly
and-
once, right? Exactly
Yes.
once, and then you stop.
Exactly
Like,
once is
just want
important.
some path.
I mean, yeah, like if you fall off, then exactly once actually works out. If you don't fall off, then it's like, come on, it's rotating somewhere and it's not.
No, not necessarily. What if you go somewhere twice before coming somewhere
Let's
once
try
or
for
something?
2 by 2. I think 2 by 2 we should
Why?
try.
No, this
Listens to me,
is
man.
like
No one
wrong because
listens
like
to me.
whenever
This
you
is
go there, you just come back, which is like wrong. So we should draw something different.
Someone
Orient
draw-
all of them this way, and now what
Okay.
happens?
Okay.
Now-
we already have
And
it.
turbo
all
goes
else is
there,
pointing right.
It works,
and turbo
yeah.
goes there.
Wait,
And
no.
turbo dies.
No,
No,
that will
it
not
will-
happen.
No,
It will
no,
rotate.
it rotated.
It will rotate.
It will
Go
rotate.
here.
It'll get fixed. This will actually work. Like I think
Did I
everything
not read
starting.
the problem?
It works. It
For
works.
For two things it
It's a
works.
problem. Karan.
Yeah, for
For
two
two
this
things it
works.
works.
For which two things?
Oh my god, I'm
The left
sorry, I
two.
didn't even read the diagram.
No.
Guys, what if
Doesn't.
it's so
Wait,
scam
wait.
that for every n the maximum is 4, like the answer is 4?
Guys, bro, that has to
What
happen.
is the
This is
answer to
turbo,
this 4?
like
Like turbo means answer is 4.
Wait,
We have a
wait.
construction
Anyone?
for it
Guys,
right
guys,
now.
Turbo means
wait,
answer is
wait.
O of 1. Answer is independent of n except for casework.
Wait.
Okay.
Wait, I have a question. What's the answer for two? What's the answer for this thing? What's the answer for this thing? Why is it 2?
1, it's 1, it's not 2. It's 1.
Yeah,
It's 1.
Wait,
Only top left.
how do
Only
you
top
come
left.
back? I am
Only
not
top
sure
left.
if you come back.
Come here. Come to this
Oh,
diagram.
I got it. I
No,
missed that
so you
problem.
literally fix a path and then you offset
Go
everything.
here, then we go here, we go
Wait,
here.
that should
Okay,
already
okay,
finish.
okay.
Like, take a good cell, look at its entire path. It has to be a correct cycle, and then you're just offsetting, and that's a grid. That's your grid. At that point, everything is determined. You
No,
can't
you're
do
not
anything.
offsetting.
Yeah. But
Yeah.
maybe okay. So we
Because
just
you're
find
visiting
something
every
else
cell.
also works. We
Huh.
have to find something else also
Wait.
works.
We now need to see if two cells can work simultaneously or not.
Yeah, like can two cells in the same cycle both work?
Mod n just doesn't work.
No, oh yeah, every cycle that is mod 4 will also work. So if you have a cycle of length C, then you already have at least C by 4 things. So the answer is probably not O of 1. If you can
Why?
get one.
What?
Oh, right.
If you can get one good cell, then you just start at a correct residue and then it will be fine.
No. That's only pen is even. That's only pen is even and n square is a multiple of 4.
That doesn't matter.
Yeah. No,
Why?
guys,
Because cycle, no.
it is order of n squared. Okay, like I have a construction for n minus 1 squared.
How?
Just orient all the arrows right, and n minus 1 squared works.
Right.
Because you get a lot of 2 by 2 subsquares, and all of them are cycles.
But
So
you have to
n minus
visit
1 squared
everything.
works.
Every vertex.
You want to visit
shit.
every
That is
vertex.
sad.
A
Every
cell is
vertex.
good
Also,
only
wait,
if you
one
visit
question.
everything.
Wait, if n square is
Every
not a
vertex.
multiple of 4, cycle
I
does not
see what you
repeat
mean.
itself. Yeah.
Oh.
If n is even, then answer is at least n square by 4.
Maybe it's like for n even, it's n square by 4, and for n odd, it's O of 1. This is our new turbo
Nah,
stuff.
nah.
That
N
half
a
odd,
turbo.
if it's O of 1, that would be wicked.
Okay, let's try 3 cross 3.
Wait.
Okay, sure.
Wait.
Can you prove it's not more than n square by 4? Can you prove it's not more than n square by 4? For an even. An even seems
Yeah,
easy.
you
Like n square by 4
consider a
is
Even
easy.
should be
cycle.
easier, yeah. N
You
even should be
consider a
easier.
cycle for n even, and you have that it has n square by 4 right arrows, n square by 4 up arrows, n square by 4
Why?
down arrows.
Why?
Because
Why
after
not? You don't
traveling
need
the
it.
whole cycle, you reach the original place, right? And now you
No, like-
consider
But the
the
flips, but the
location of
rotations.
each square and where it was reached mod 4. Like if it was 2 mod 4, it was upside down when
No, but you're not considering the
turbo
fact that the
reached
arrows
there.
change in between.
As a rotated in between.
Yeah, exactly. So you
I mean,
take
like, look at this construction. All were
Like,
right. It worked.
All were
All
right,
were
yeah,
right. It
like,
worked.
exactly.
yes. Okay, maybe
But
try
what you can
4
say
into
is
4 by
4.
4 grid.
Try 4 into
What
4.
you're taking is you're taking a cycle and then we're just flipping it mod 4, right? Or of its position.
Yes.
You want to show?
Okay, let's try a 4 by 4.
And you want to show that something else also doesn't work.
What are the odds that Nikolai Belohov made this problem?
0.
Nah. He's
Nah,
not
Nikolai
making
Bello
turbo as
doesn't
a
make
pivot.
such cheap problems. No turbo.
True.
He makes like high-end problems.
But he isn't
High
having
problems, not high quality, high problems.
High problems, yes. I wouldn't say high quality. I don't like his problem.
Guys, we're on a stream.
Oh shit. Shit. What if Nikolai Beluho was just watching the stream?
We're sorry,
That-
Nikolai. We love your problem.
Right, so just want to show a path. Can't
Very
do an extra.
interesting.
By the way, construction for n square by 4 is also trivial. Like, just take any cycle, offset, and then it wins. Like,
Okay. So
N
let's do the even case now. Prove that n square by 4 is optimal.
Yeah.
So how you
so we are basically trying to show that if something works, then any out of phase particle will not win. It cannot win. Which makes sense because if it was working perfectly, now it shouldn't.
Wait, maybe look at the borders and so that somebody is going out.
Yeah.
I don't know.
Or maybe you induct
Somebody's.
on the border.
Yeah.
Like
Right,
within
so
the first.
at the border element, there's one phase that is going to be pointing outward. So that phase is eliminated. So how are we going on the borders?
Wait, the answer is
We can't talk about this.
But the order
phase-wise.
changes, right, in which you visit, like if the arrows are.
So in that original cycle without the offsets, at a border like which borders are at the border I can point in all three directions.
Okay, n square by 4.
So we can prove that at most n square by 3n square by 4.
3n square by 4.
Wait,
At the most 3n square by
Okay,
4 because at least one of the options is.
What if the
okay.
answer is this n square by 2?
Wait,
just
how do
to
you
be
prove at
funny?
most 3n square by 4?
Because
Right.
look at the border element, there's going to be some phase where it's pointing outside the grid.
Yeah.
Those 3n square by
I
4
mean-
elements all fail.
I mean, okay, but why do I have to reach there? It's not.
Yeah, why
mean,
do I have to
if I
reset
did-
in the same phase? What if I
I mean,
reset
like
in a
when you
different
change the
phase?
phase, you are rotating it, right?
You're
Like
not
you-
But
rotating.
the order
Four
also changes
steps.
in which you visit.
Oh, the order also changes, right?
Yeah.
If you change the phase, then it's not isomorphic
the
to
whole
the
problem,
previous
like,
one. It's
the
a
order
it's a
of-
the
different
order
cycle
changes,
altogether. So we can't treat the phase change as a trivial transformation. It's like changes everything.
Hmm. Let's try to prove this for even 2 by 2. Why can't 2 by 2 have two things which pass?
Wait.
Double log, let's say we want to
for
get
which
these
for
two
which
passes.
2 by 2 we get like 2 answers.
Okay, can we achieve 2 in a 2 by 2?
Wait, what if you do something like this? Does this work?
Wait,
No.
what, is this the cycle without the?
No, this will not
No,
work.
it's
This
just
will be a zero.
doesn't work.
All of this
Okay,
level
let's say we are
rotate
first
90
trying to make these two guys win. So
Okay.
what is the only cycle that starts from here and visits everything? It has to look like this, right? Like this has to be the path it takes, for sure. There's nothing else.
Yes,
That
and
Then
hence
just like
the original has to be like this. It has to be
So-
pointing like this,
So
and
this
we are done.
basically forces it has to look like this.
Yes,
This is basically
and
Sridhar,
so
I
only
think
one
that's
is
what-
possible.
And
But
so
then
it just
this won't
forces
work.
one.
So what is your construction for the 4 by 4 where 4 works?
Wait, so for 2 only one is answer. Okay.
Only
Yeah.
one is answer. Like we are sure about that.
Yes.
I mean,
We are
in
searching for
terms
any
of
quantity.
path, you could select stuff like, I don't know, this.
Okay.
Okay,
so
that's the path. Sure.
then it has
Wait, what is this path? It went here and then it. What?
Hold on.
Something's wrong. Wait, it's
Yeah.
like this.
This, yeah.
So it will
If
look
the
like
dark red person, remove your dark red.
Yeah.
Dark
it's
red,
not
remove your dark red.
Dark red person, remove your dark red. Alright, this works. And so you
Yeah.
just take this path and consider the zero mode for elements in this path.
Yeah,
and then-
exactly. And like all of
Okay.
them will also win.
That
Yeah.
makes sense. So for
Yeah.
odd
Why
numbers,
will
it'll be
something else
more
fail?
scuffed.
So let's actually number these. This is 0, this is 1. This is
Okay,
2.
wait.
Yeah.
Does this just mean odd is just not even possible?
Okay, we'll think about
Why?
odd later because
Bro,
odd is scuffed.
odd, you don't even have a Hamiltonian path, right?
You don't?
What?
Oh yeah, parity. Parity wins.
Parity by
Bro.
chessboard color. Odd doesn't, odd is 0. Turbo is back. They lived into its
This is called
expectations, man.
troll.
I was right. For odd, it's
Oh shit. Okay, no path exit. That's so dumb.
that is so dumb. Oh my
wait,
god.
wait. For odd what it
Lama,
For odd,
just
it's
check
zero.
about color
Hamiltonian
them
path.
and
They
no
No
can't do
path
any
Hamiltonian
exit.
good
cycle.
stuff.
There's no
Okay,
Hamiltonian
okay,
cycle for
that's
odd.
very good. Like they just wanted to troll us.
Amazing. Now it
somehow.
has to be 0 and n square before. So the O
That
of
is
1
nice.
conjecture was correct. I just didn't realize it was going to
The
be
turbo
0.
lived
It
to
was
its
O of 0,
expectations.
not even O of
Yeah,
0.
Turbo has lived up to its expectations. Exactly.
I think it's a tradition now. Every contest P5 has to be turbo now. With a constant
Yeah.
answer in some case.
Yeah.
Then Lama P5 has to be a troll combi. Like otherwise you're not living up to
Don't
the
spoil, no
spoilers, no
spoiling on
spoilers.
Lama. No spoilers on Lama.
weird thing. Shit.
Okay, now how do we prove n square by 4?
This is so scam, man. I'm just.
Oh my god, that was okay. So we have the lower bound of n square by 4. We just want to prove that n square by 4 plus 1 is
Maybe
not
it's a
possible.
parity argument again, actually.
Yeah, I feel like it has to be
Yeah.
parity. Like,
I mean the
Um,
argument of,
Except
like,
here it's mod 4, not just
So do
parity.
mod
So,
4
like,
I mean,
stuff. So like you
yeah,
could
just
encode
between
every
things.
move as like something from I to 1, like 1 I minus I, whatever.
Like,
Wait. There are not
co-
4 numbers
pick-
mod.
just pick coordinates on like 0, 0, 0, 1 and so on.
No, pick complex numbers.
Hey,
Complex
bhai,
numbers
this is
also.
same.
Oh, stop. You can't bring
Complex
complex numbers into a geo as
Did
well.
we complex bash everything?
Yeah, we
All of
complex
day 2 is
P3,
complex.
P4 and
All
you
of
P5
can
day
as well.
actually do this like complex numbers.
We
Like
was complex all of day 2.
Like apart from P1, we've complex bashed everything.
P2?
How did we
complex
do
bash
it?
P2?
I don't know.
Graph we write it in complex way. Right?
yeah.
Oh, we wrote it in a
Yeah, we
complex.
did some
way.
What
very
about the
only
P1?
P1
Let's
we
say
cleanly solved.
X,
Okay,
X
P1
plus I
just-
square.
Cam.
How brilliant. Okay.
Wait. Like how is your like the bound? Are we
Okay, so
doing?
we have a lower bound of n square by 4. We
Yes.
know that f of n greater than or equal to n square by 4. We've proven that.
Yes. Yeah.
We have not proven
Anything
f
else?
of n less than or equal to.
Wait, this is just like we cannot have Hamiltonian cycle with odd length, right?
Right.
Yeah, odd is just like.
Yeah. Okay. I was thinking same odds shouldn't work. Okay, so this like
In this path, can we now everything one is rotated one clockwise?
One is rotated one time, two is rotated two times, three is rotated.
Yeah.
So no,
Yeah.
consider take the
Archit,
original path and take the
Archit,
mod
complete the
4
numbering.
things in that.
What
Just
numbering?
complete the numbering. Right? 0, 1,
Okay,
2,
wait,
3,
I'll
and then
complete
stop.
it. I'll complete
Okay.
it.
Wait, same color, right?
Same color, yes. Thank
This
you.
is not the same color, is it?
You don't have same font. Get rid of it. Get rid of it.
Bro, there is no font in handwriting.
Guys,
only
guys, just
Archit
let
did, only
Archit do
Archit,
it. Let
only
Archit do
Archit.
it. Stop,
Okay,
April.
yeah,
April,
yeah.
stop. Take breath.
When visuals are important, it should be like you should be consistent with what you're writing.
But if the font sucks in any case, like
Wait,
doesn't matter.
Don't. I'll write.
Okay,
Let Archit do it. Let Archit do it.
Sure.
Hi.
Oh,
Oh, EGMO
Hello.
solver is here.
Oh,
That is.
we now have a participant from the actual contest join us.
So true.
Hi.
How's it going? What do you think of day one?
What do you think of the troll of P5?
Turbo lived
I
up to its
will-
expectation.
Like,
Turbo is
do you
living up
think
to
that it's as good as
expectations.
IMO in trolling?
I will not comment.
Yeah.
What if she's
How-
just secretly seeing us like fake solve this entire problem? What if we are horribly wrong and she's just laughing?
Yeah.
That's- Maybe,
What if the answer
maybe.
is n square by 2? It's not n square by 4.
Wow.
Uh-huh.
I mean, why does it fail for n equal to 2 then?
Yeah, it has to be
Oh
answered by
yeah,
four,
true,
man.
true. Fair.
Or maybe just like
Okay.
Or maybe it depends on the mod
Maybe
4
it's
of
like,
n. Because
this is the
turbo is
case
an
too.
ultra score.
Like for n 2 mod 4, it's like O of 1.
Yes. For n 2 mod 4 it's 1.
Okay.
For n odd it's 0.
No,
And for
that
n
can't be the
0
case.
mod 4
That
it's
can't be
something.
the
square
case.
by 4.
because-
F of that is square by 4.
Yeah,
No,
like
that'll be
f of n is at
something
least
else.
n square by 4.
Like for the first 5 minutes
Yeah,
in the contest,
we
I was
have
so
a
confused
low bar.
because I thought that we had to like traverse through all the edges and not the vertices, and I was like, wait, for n greater than 2, it cannot happen. We cannot have a Hamiltonian cycle, no, Eulerian cycle. And then I was just very confused for the first 5 minutes about that. And that's because I thought I saw turbo and I was like, okay, this has to be very scam. So that's why.
I mean, so
Tell
far
me
it
you
is
would have-
pretty scam. Like our progress at
All
least is
just
pretty scam.
Okay, Sai, no spoilers.
Anyways.
What did you think of day one?
Scam. That's the only word we
P3
have.
sucks. Like P3 sucks to the core. Whoever made that like sucks.
Every problem so far has been complex partial except for the obvious non-complex.
And everything has
So
been
you
scammed.
guys complex bash P3?
Yeah.
complex
we did.
by P3.
No,
But
we
it's-
didn't complex. We length bashed
Did.
it to some
Yeah, we length
extent.
bashed.
Archit wanted to, but we didn't.
How did you bash it when Om is in this meeting? I don't get it.
Yeah, we
We
did
did
bash
not
it.
bash. We just ratio
didn't
bashed
bash
it.
it.
We don't
Like,
have
the
to.
thing is,
Archit
Om was the
bashed it.
one who completed the length bash. Like Om
Yeah,
changed his
correct.
stance.
What is happening?
Om is committing.
No, and I feel length bash is like you cannot consider ratio bash as a problem.
You had to
all
length bash
Archit
over here.
influence
The
of
question had a
bashing.
length condition. 2:1.
Okay,
You
guys,
can't start
let's
length
solve
bash.
P5. Let's solve
Yeah, let's
Turbo's
solve it.
ability.
Okay, okay.
Wait,
sure.
now. Okay, hold on. For one, the path that no, but the order. No, the order doesn't matter because like. No, the order does matter. Of course, it matters. Yeah. No, let's actually fix the
like-
direction of these arrows, right? Currently, this is the path. Can someone fix
Okay.
all the directions? I'll do that.
You do it. You do it. You're the one who's
Isn't
drawing.
for one every like just this thing just shifted by one, right? When you're starting at
Wait,
one for one,
Wait,
one's perspective.
counterclockwise, right? Yeah, counterclockwise.
Wait, do not do
Counterclockwise
this. Don't
shift
do
because
this.
it's going to
Wait,
shift clockwise.
Don't do this. Don't do this.
Don't do this. Don't do
Wait,
this.
Archit,
Don't
no,
do
it's
this, Archit,
pointing
don't do
up.
this.
The one is pointing
Just
up only.
keep the path like this. Now, when you're starting
Yeah.
from one, isn't from one's perspective the path is like completely shifted by
From
one.
one's
Right?
perspective, you instantly
No,
leave,
no.
first of all.
In one's perspective, you die immediately. See, in one's perspective, it starts like
Counterclockwise
this.
is
No.
counterclockwise goes upwards. Counterclockwise is
What
Yes,
I'm
like that.
saying,
yes.
what I'm saying is like
Wait, Abel
okay,
don't draw.
now
Abel don't draw.
No, so
Abel
we'll
don't draw.
draw the original, the actual thing
Wait,
in
no.
red
One will
color.
point inward. One will originally point inward. So
No,
it will-
No,
counterclockwise
one
is
will
like
originally
that.
point outward.
Huh,
Because
so
after 1
it
second,
started at
shifts.
0, and then things turned counterclockwise, and it became like this, which means it was like
No,
this.
it
That's why
turned
turned-
clockwise,
No.
not counterclockwise.
One starts
Turned
by going
clockwise.
right. No. One starts by going
No,
up.
one
Once
starts
original-
One starts by going
upwards.
up.
Yeah,
Up.
once-
One starts by going
No.
up outside.
One's actual state is down because that's when after it turns counterclockwise, it becomes like this.
Archit
Yeah,
is turning
right.
clockwise.
It's -1. It's
That's
-1.
right.
Not
That's
+1.
right.
That's just right.
Like after you move counterclockwise. So after it's counterclockwise turn, it's that.
Yeah, so
That
one
is-
will
Also-
move down.
Oh,
Also-
counterclockwise is clockwise. Counterclockwise is
Okay.
clockwise now.
Yes.
You're right, you're
Also,
right.
second.
Yes. Okay.
Like if you just look at this path, like forget about turning the arrows, like remove the turning arrows. Isn't from one's perspective the path just these arrows clockwise by one?
Yeah.
No.
Yeah.
Yes.
No, the
No,
order
because
changes.
one
No,
The
the order
order
changes.
in
The order
which-
changes.
The order
is not the
changes.
same.
The path
Yeah.
itself changes completely.
Yeah.
Okay, that's the problem. You reach at different residues mod 4 again.
So clockwise, you
Yes,
go
yes.
here,
But
I
like,
then you
think
rotate this one clockwise.
I think it makes sense to split into 4 things and prove that across these 4 there's at most n square good cells or something. Like that could maybe work. And so like
Hamilton
in
is no longer
particular in one
Hamiltonian.
layer you have at most
Hamilton is no longer Hamiltonian.
huh.
At least you can chessboard things. Like at least if you chessboard color it, then blacks are always like the same thing and whites are always the same.
And
Like
only
same
half of the blacks
X or
win or
Y.
something.
Something.
It's scuffed.
If you can do a 4 coloring,
I mean you can
So-
color I plus j mod 4.
4 color theorem.
Okay, so we can know that for each vertex, we know it's going up, down, or left, right. We can say that up, down, or left, right. We don't know which one, up or down or left or right.
yes.
Can this lead to a contradiction?
So what if you keep some things on the border and there's like 3 of them which are up down but distinct in some way, and so like when it reaches that it has to leave. It can't survive. Something like that.
But so it is something. But so you can't have 2 sets like this, right, on this border. No.
Like the order in which you visit, of course, that is what messes everything up. Like
Right.
Yeah. The
I
only thing
think,
we know is
I think we
up, down,
should
and
work with the 4 copies version. Like that.
The
is easy.
hypergraph version.
It's not a hypergraph. It's a regular
a graph. A regular graph where there are equivalence classes between the
not regular.
vertices.
either.
It's
Like-
just
by regular
simple
graph,
graph.
standard graph, simple graph.
Simple
Nah,
graph.
you have an
Simple graph.
element
It will be
matrix,
directed graph.
and then you take the 4
Result which is-
phases of it, and you consider that as a graph.
Let's run a DFS. Like we should run DFS of
What
node,
is going
comma,
on?
I think we
residue.
should
Very
just,
good, yeah.
we should just
Libre.
complex bash P5 as the pattern continues.
So we're going to store the vertex label as a complex number.
Yes. So 0 is 0, and this is like 3 plus 3i.
Stop it. Stop.
It makes sense.
Yes, I absolutely agree with you.
I have no words.
Like we can assign like complex number to each and like rotation as some
Yeah,
rotation.
like you just multiply the whole
Yeah.
thing by I every time. Like
Yeah.
so the arrow is stored as 1, -1, I, or negative
Yes.
I, basically.
I'm actually doing this.
Yeah.
Every vertex
Like,
is real or
it
complex.
makes sense. In every phase, you just multiply by
Yeah.
I or negative I, one of them.
Yeah.
You multiply
Yeah.
by
That's
I.
right.
It makes perfect sense.
Congratulations.
No, let's just work with the multiple copies version. Like I
Okay.
should-
Sure.
Like this is
Let's-
so clean.
let's-
You have a 4x4 grid where the entries are 4th roots of unity, and you multiply by I.
So this
After
is like
every
state 0.
thing.
This is rotated by rotation here is 1. Here rotation is I. Here rotation is -1. And here rotation is I.
Yes. Perfect. I
Yeah,
squared
complex
minus I.
bashing.
Yeah,
Like,
minus.
there are like 3 problems. Complex.
Okay.
And now like you want to prove that there can be only one cycle that visits everything. Like there's that
Yeah.
one good cycle
Yes.
which goes through everything on the graph.
Yeah.
So basically you just want to show there's at most n square good vertices in this new version. Like not n square by 4 because now
Yeah, because you multiplied everything by 4.
Yeah.
Yes, that's correct.
Yeah. Sure.
Wait, is I clockwise or anti-clockwise?
I is clockwise.
I is counterclockwise.
No, see, because when you actually do it, 1 is over here and I is over here. Like that's
Huh.
how the number line is written.
Yeah. So like
And this is
multiplying
I
by
is
I
not
is
one.
counterclockwise.
multiplying by I
And
is
this is
counter-
negative I.
Sure.
But also it doesn't matter. I mean,
It does.
Yeah. We just like
We must
no.
respect the
it does matter.
counterclockwise.
It
Let's
doesn't.
do something actually. Let's actually do something.
Yeah, okay,
Yeah,
let's stop
Yeah.
complex bashing again. Yeah.
Thank God.
Okay. So.
I do have a game theory problem in which you have to complex fashion. There's no other way out. It may or may not appear on LM.
All our viewers are very excited.
Yeah, people check stream like in between.
Wait, guys, can you
I
check
should
if
have
stream
checked.
is even working right now?
It's working. It's going.
Okay.
Do people not have any questions? Normally there are comments and questions.
Let's just
Let
check
me
the
see
stream
comments.
chat
There's
for
a
a
question.
second.
What is even happening? Understanding 0%
How
Average
did I
raising
scroll
100%.
from Minecraft to this?
Yeah. Where is Minecraft?
Why so?
Yeah, this Archit sir has a comment as well.
Oh shit.
My
Wait,
God, do not do that.
Okay,
Do not do that.
just a second. Okay.
Able. You,
Able,
that's like
able,
Okay,
don't
infinite.
do
this is
that.
good. This is good.
Why so complex is a comment.
Because the
Okay.
EGMO is too complex. It deserves to be complex.
What? Or like EGM is not too complex, so we add the complex. Okay, let's just do this. Like, why are we?
Why are we not okay?
Yeah.
Why are we just like labeling and not doing anything?
Yes. We can forget I. Every arrow is either this or this. Like we can for sure that when it's going.
Let's stop labeling. Whatever label we have to like.
This is just an
We'll start
arrows
doing
problem.
something.
This is just an arrows problem. There's nothing more.
Wow.
Let's actually solve it.
It's like when you shift mod 4, the cycle has to like split in some sense. Like imagine that you were being a brute about it and you were like, no, it will stay preserved, the cycles, the order does not change. Then the problem with that is like, if it does change, because see, the parity is preserved, right?
That is preserved.
What is so every time there's a mismatch, it sort of breaks the cycle into two pieces or something, but it shouldn't, it can't, because the cycles have to be like completely merged anyway.
What?
Something like that.
If there is something at the border that's going down, it has to stay going down.
Hmm.
It can go up. What does it mean?
By the way, note that the answer always has to be a multiple of n square by 4, right?
Yes.
No.
Yes.
Oh,
Yes.
okay. If something works, all phases work.
Yeah. So
So we have only 4 candidates for the
Yes.
answer.
Yes,
Yes.
so there are only 4 candidates for the answer. This is a case match problem. We just have to figure out what the cases are.
But hence the spaces are preserved, right?
Wait, is n square actually possible? Like
Wait.
No,
If
n
spaces are
square is
preserved, right? We'd have
Oh, maybe it's possible.
like now we take a configuration, right?
Huh.
Now for the n square by 4 plus 0 mod 4, this is the only path that works. This is the path. If there's a path of 1 mod 4, and we look at the 0 mod 4 things in the 1 mod 4, which includes the 1 mod 4 thing, it can't include a 0 mod 4 thing, originally 0 mod 4 thing. Because then that would mean that 0 mod 4 thing had two parts corresponding to it. One the 0 mod 4 path and the 1 mod 4 path. So the faces are also
Yeah,
preserved.
the vertices are disjoint, so it has
Faces are preserved. Then. So if two faces intersect, then that intersection has two parts, which is not possible. You only go by one part.
no, but that does not mean that the labels are correct. That does not mean the order could still change in a way. So like
But the faces same. Faces are same.
Faces?
I mean, like
Faces.
what is
considering each face
like the
change.
disjoint thing? Like for one path,
Like he's saying
the distinction into four subsets.
So you're saying it's
four
like
subsets
it's like a finite state thing. Like it does not know anything beyond like every
Finite
vertex does
state
not know
automaton.
anything. Yeah, exactly.
What? Why automaton?
no.
What
It's
is saying
just
is every
automaton
path.
all these things
the paths
like
is same.
yes.
Every vertex is local in some sense. So like
Yeah,
after
it
everything,
has only
it doesn't
one edge
care about
going
the
out
rest,
of
it just rotates. And turbo
No,
is just
no,
like
that's like-
a
that's
random
like a-
snail on the automaton.
In the 4n square vertices graph, every vertex has exactly one out degree. Like exactly one edge.
No. What I'm saying
Yeah,
is that
if you consider it to be the phase change, yeah,
wait.
obviously.
Like the n square cells can divide into four subsets, and these four subsets are the same thing for every path. These four subsets.
As in
Yeah.
like 0, 4, 8, 12, 16 in this thing is going to be
16, that's not
same.
16.
This whatever
4 and
0,
Yes.
and then 1, 5, whatever things. These
Yes.
are all going to be just split right there.
The split is going to be same. The numbering
That can be rewritten in like a different way as well.
Let's not do
by
it. Let's not do it. Let's not rewrite it.
No, the 4n square vertex graph also does that. Like it is
What?
basically does that.
Oh.
Because like what you're saying is that if at any point of time you visit a different type of vertex, like if basically you're saying imagine that this is the path for a 0 mod 4 thing, and then you have a 1 mod 4 thing. And so if you do have two like cells having the same direction, that's the same vertex in the 4n square graph. So it's like you have these two different vertices, and starting from there you reach the same vertex, which is not possible because this is a bunch of cycles. I mean, not a bunch of cycles, but like this is
It's a bunch of circles.
yeah.
What do we have? So we have this.
So we
two
proved
things that
it's
same.
done. N square by 4.
No. But the order
No,
is
we're
the same.
not
It's not
done
necessarily same order. It could be 0, 1,
You're
2, 3,
done.
4. It could be 0, 3,
No,
2,
because
1,
the
4.
starting point could only be a 0 mod 4 cell. There can't be anything else. That's what you just
Why not
proved,
1 mod
right?
4? Why not 1 mod 4?
Why not 1
The
mod 4?
ordering could see first ordering is 0, 1, 2, 3, right?
No, but
So there
that's
could be
what
1,
you
2,
proved,
0,
right?
3.
If the ordering changes, then at some point the cell should match with this cell, like what is on this, but that can't happen.
Wait,
No,
what?
like the partition is same, but the numbers of the
Yeah,
partition may be different.
like this,
first,
you're not necessarily going from 0 to 1 to 2 to 3. You might go from like 1 to 4 to 3 to 0.
Oh,
Whatever.
But you
I
can't
just said some random numbers, but
because
yeah,
if you were
1,
to
4,
go
and
there,
0 I said, but yeah, whatever. You got
but if you were to go there, you would just follow this correct path that it was following all this time.
no,
No,
1
not
to
necessarily.
0. 0 is in the phase of 3 now. 2. 0 is in the 2 phase now. So change the start.
Like you can go to a 0 mod 4 during when the time is 2 mod 4 or something like that.
Yes.
But it is all 0 mod 4s are 2 mod 4s then. That's what you know.
Yeah,
Yeah,
because
like-
of parity. Okay, but
So like
parity
once
is
you do
Not
like
only parities, because the subsets should be the same. Otherwise,
right.
one vertex has 2 paths.
okay.
Okay, so what we know is that all the 0 mod 4s are like together. How do you know? Now the question is, can they all rotate? Right.
Wait. We should try to. So every vertex has something that can go into it. That tells you something, right? That tells you that all 4 of its neighbors have to like satisfy something.
What work? I didn't.
No, so yeah. Hold on. So imagine that you have two. So you're going to start from this cell only. Let's say this is your starting cell, and you're just trying to see, can it work with 0? If I start with 0 phase, if I start with 1 phase, 2 phase, or 3 phase. Clearly, the problem is equivalent to this. You agree?
Yeah.
So now imagine that you start with 0 phase or 1 phase or whatever. So if you look at some fixed cell, you're going to visit it, and you should visit it in both 0 and 1. So that tells you that these
What?
4 neighbors.
Not 0.
You should visit it in the 0 phase and the 1 phase.
Yeah. So that tells you
Yeah.
that for every fixed cell, if you look at its 4 neighbors, whenever you have a 0 or 1 phase, there is like that one particular point of time where it'll have at least one edge going into it, which is where it actually came from. But this is not always guaranteed. So this should give us something.
Repeat what?
No.
Like this cell has 4 neighbors that could potentially come.
And it's coming in two different ways corresponding to this 0 1.
No, not 2 different ways. It can only
Yeah, it
come
has
in
to be
one.
2 different ways. Why? It has to come in 2 different ways because the
Okay.
way it
Each of
came,
these
it changed.
individually is in 2 states. Yes, I agree.
Yes, it will go in 2 different ways.
But it has to come in
So
2 different ways corresponding to 0 and 1.
Yeah.
wait, doesn't that no? So yeah, exactly. It has to come in 2 different ways. Now there's exactly one residue for which it will actually point inside and actually enter.
Wait,
In all
guys,
other
just
cases,
consider
it will
the
not.
corners. No, consider the corner cell.
So each of them has 1. Each of them has 1 phase. So 4 phases out of them.
Yeah, out
And
of
they
them,
are
you're
all
selecting
supposed to be
only
distinct.
2, and in each of those 2, there's at least 1. That tells you the number of distinct phases is at most 2.
At least 2. And at most 4.
At least 2. Yeah, sorry.
And at most 4.
Hmm.
But corners have at least 2 and at most 3.
Yeah, so if you consider the corner in
No,
0 and
corner
1,
has
like if you want the
corner
corner
has
to
exactly
work in
2.
both phases,
What?
then you die.
You don't die. But one
Like
of the
say you have a corner
at
that
most 2
works
phases. At
in
most 2
phase
phases.
K and K plus 1, and it's a corner phase. All right, so in phase K, let's say it looks like this. I'm talking about some top right corner. So it looks like this. In phase K plus 1, how is it going to look? It's all
Pointing
rotating
leftwards.
counterclockwise.
Pointing
First of all,
leftwards.
answer is at most 3 n square by 4 at this point.
No, at most n
No.
square by 2 at this point.
N square by 2. N square by 2.
Because of the corner cells.
Yeah, because of the corner.
only bottom or left. It can't.
Yeah. So for
Yeah.
corner, we know that there are at most 2 phases at work. So it's n square by 4 or n square by 2. It's one of them.
You just want to get rid of one more residue by saying that some other corner it will disappear.
Yeah, just take the correct corner, like take the bottom left or top right, depending on which one it is. I think
I'll take all 3 corners.
all 4 corners.
All 3.
From one corner is starting in the
For
corner.
currently starting.
No, for any corner starting, it should work given the correct phase shift. Right. Like if this corner works for 0, 1, that corner can work for 1, 2 or 2, 3.
Wait, there may be
3, 0.
No, that's fine. Okay, so for each of these subsets, you can't have 2 of them having the same phase as this. Right? Even if the ordering is different, like what did you say?
Nothing.
We have n square by 2 or n square by 4 is done.
Wait, hold on. So W log we can shift everything and it doesn't matter. So let's say that with zeros okay, let's assume that this is oriented this way. I can probably do that by rotation. No,
Yeah.
not necessarily, but
Yeah, do it.
No,
Yeah,
can you?
Or some
Yeah,
phase, in
you
some
can.
phase, in
Flip
some
by
Flip,
reflection or
flip,
something.
do something.
Yeah,
It doesn't
fair.
matter. Now, so if it's pointing this way, then it's basically telling you that in states 1 and 2, things will not work, right?
Yes.
So 1, 2, first of all, are off the table. And
Yeah,
that
One,
tells
two.
so
What's
the
one,
states
two?
at work
One
are
is the
3, 0.
this is 0 mod
Correct.
4. Now 1 mod 4
Yeah,
will
this
make
is
it point up now.
that fails.
yeah.
2 mod 4
So
fails.
3,
3 mod 4
0
works.
are the two
No,
states at
3 mod
work.
4 doesn't fail. 3 mod 4 points down.
Yeah,
Yes.
3 mod 4 works. Yeah, 3 and 0
Yes.
work.
So 0 and 3 are the only things that are interesting to this vertex.
Yes.
Now focus on like every single vertex. It should also be 0 and 3 for all of them if there's more than one.
Yes.
So
Yeah.
that
Why 0 and
gives
3?
a
Why
lot
0
of
and
the
3?
direction.
0 and
Huh?
3 could mean something else. 0 and 3 could
Parity,
mean
I think.
2 and 1.
No. Like we consider the
0 and
4
3 for like
phases
what?
as the 4 things
No,
in
so
the
now
4
imagine
cycle
that
graph.
this is 0. So then it enters here, right?
Then, yeah.
And now, if this is working, then it should work in general as well, that guy. And because you have two different, like, so, okay.
Wait,
So
what
first of
is-
all, if you have,
Yeah,
yeah,
0 and 3
bruh.
could mean something else for
Wait,
somebody
wait,
else,
wait,
right?
wait. No,
0 and 3
this
could
is,
mean
this is
something
very good. This is very good. See, there's, first of all, at most 2 possibilities at every place, right?
Yeah.
And if you look at the 0 phase and the 3 phase, the phase in which you visit that thing will have to be different.
What? Repeat what?
Yes.
Oh, so you're basically
Wait,
saying
repeat.
if you have a working cycle, then if you flip the direction of everything across the correct direction, it can't still be working. That is what we need to prove.
Yes.
It could be a different direction for each thing.
No,
For
so
this one, it was 90 degree
Like
clockwise.
if one cycle is working
pair up
with
these two and
everything
pair up
in-
these two. What we need to
Then
show
it's-
is that if you have a working cycle, then you can't have a working cycle if you shift all of that to that. That is what we need to prove. Because it must
But
visit
why?
different phases.
Wait,
Wait.
not like
So wait. At this
Okay.
top left corner, right things to bottom, right? So there is a 90 degree clockwise rotation.
Yeah, no. So
But
like
for
suppose
every
the
cell, it
top.
may not be 90 degree clockwise rotation. It could be a 90 degree anti-clockwise rotation as well.
Yeah.
For some other cell.
No. So
Why?
every cell has at most 2 choices. You agree?
Yeah. And
So
they are
consider-
angle 90 with each other.
So consider the path in which you start at 0 and you do stuff.
Okay.
And now consider the path in which you start with 3 at the leftmost corner and you do stuff. I claim that for every single cell, the orientation in which I visit it in 0 and 3 have to be different. In
Yeah, that's
particular,
right.
they're inverses.
Yeah.
And so,
Not opposite direction. Not opposite direction. They are 90 degree to each other.
yeah. Wait, no. Why
no,
not?
they're
No, why
opposite.
Why?
Their parity is fixed. Their parity is determined already.
0 and 3 are opposite parity.
You are opposite parity.
No. That 0 and 3 are different. It's a different parity I'm talking about. I'm talking about the parity of the Manhattan distance from the top left cell to each every other cell.
The parity
Why
of
can't it be?
Manhattan
Why
distance.
can't it be
That
90
is-
degrees to each other?
No, so like it's moving by 0, 1 or 1, 0 every time, right? So x plus y changes by exactly 1, no matter what happens.
Yeah, so the phase you reach at it is.
So basically, like
Okay, I
forgetting
see.
whatever you do,
Yeah. Okay,
there's at
so
most
it's
2
up and
choices.
down. So up
And
and
they
down.
have to be different for 0, 3. Because if they were same, that's actually just the same cycle in the 4n square vertex graph.
Yes.
Fine. Okay, and the corner contradiction.
So basically, what we need to show is if you have a completely working cycle, if I flip everything in some direction, like
Wait,
these
wait,
two-
aren't you done? So
Yeah.
what are you saying?
Yeah,
What are you
exactly.
saying is that every vertex it has to once approach from one direction, one approach from the opposite direction. But the
Yeah.
corners it obviously fails. You can't do it.
Oh.
No. My claim
Wait,
is you
wait,
can't.
How
Why-
can it corners? How can it
Why it
corners?
has to be
Hold on.
opposite?
Let me explain what my claim is. My claim is the problem is it's sufficient to show this at this point. So call orientation of arrows correct if it's like a complete cycle, a good cycle, whatever.
Yeah.
Now, basically the problem fails if you
Why do you
can't-
need to? Why do you need to do so much? I think there's an easier way to finish, right?
No, call these two like complement or something, complement directions, so like left, right, up, down. Now, if I take a working cycle and if I take the complete complement of it, like I flip every single thing, then that cannot
That does
work.
not work. That cannot work.
That is all we
But-
need to show.
But a
Wait, why?
90-degree rotation
Wait,
can
why
work.
do you need to? Why do you need to do this? I don't see why you need to do this. I think there's an easier way, right? So now you showed that for every vertex you either come by the top or bottom, and 0 to 3 chain is
Oh,
the.
wait, this reduces to the 2
corner.
by 2 case by looking
Wait,
at the
what?
corners in some sense.
Wait, why? Wait. I
Like
think
you
there's an
can
easier way.
treat the corners
Achal.
as a 2x2.
Wait.
But actually, there's a much easier way, right?
Okay, what is it?
I think like so now at each vertex, as you said, like you either come in the 0 and 3. In one of them you come from the top, one of them you come from the bottom.
Exactly.
What about at the corner?
Oh, Lama.
Yeah, exactly. It is done.
Wait, why it has to be one
Yeah,
of them?
we are
Because
so done.
parity,
Like
parity.
just consider the four corners, right?
Wait, but this
It
will
has
actually
to come
work.
to
I
this
must
corner
know.
like this. It
Yeah,
has to
yeah,
come
it
to
No, this does not
this corner
work.
like this.
Works, but like I just
Like that's the
one
only
second.
way you can come and go from the corner. So we're done. Like
Wait,
the
no, wait,
corners
actually.
form a 2x2.
No, it has to be a
Like,
certain offset from the starting.
Wait, Archit.
Like
Yeah.
No matter
Wait, one
what.
second. Wait, 1 minute. So now this 0, when you change from 0 to 3, everything changed by 90. Maybe.
Yes.
Everything could change by 90 or not. And then you start looking at the Manhattan distances, right?
Right.
So we don't know that exactly.
Yeah.
Wait, Aditya, wait.
Wait, what are you
So
saying?
in
Wait, this doesn't
any
work.
working
Yeah.
path, like consider any working path,
Huh?
you have to enter the corner like this and exit the corner like this.
Or the
Yeah.
other way.
Or the other way. So let's assume it's this way. This corner has to be entered like this, exited like this.
Why,
This corner has to
why?
be entered like this, exited like
Why
this.
not like this? Why not like this? Why not enter like this and exit like this?
Because then you get trapped.
No,
You
because
get
then
tired.
you'll come
Not
here and
necessarily.
you'll die.
I mean, why it will come by like some complicated way, like come like
No,
this,
there
like
can't
this,
be.
like
No,
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 you
no.
can't. You
You
can't.
get
You
trapped. You
can't.
get trapped.
You
It'll
can't.
be
get
self-intersecting. So
Yeah.
the only way to do it is like this. And now if we show that the corners are in 4 different mod 4 things.
Okay,
If they're
that depends on the parity of
0,
n.
1, 2, and 3 mod 4,
It depends on the parity of n.
then we're done. If we
But
just
it
show this,
depends
we're
on the
done.
n. It depends on modulus of n and stuff.
No, we
No,
take
no.
the mod 4 of the
N is
Manhattan
even.
distance.
N is even.
Okay,
Yeah,
no,
n is
no.
even. So
Okay, but
2n is a
different
multiple of
distance.
4.
So
Yeah.
these are in like only at most 2 classes.
Like see, the Manhattan distance till here is n minus 1. And here it's also n minus 1.
Ah.
And here it's 2n minus 2. So if this is 0 mod 4, this is 1 or 3.
Oh,
and
I
this
thought
is
you don't
corner
need to
thing
go
is
here.
2 or 2, and so one of them will
And you
leave.
treat this as a 2 by 2 and
No,
win.
no.
You're done.
Wait,
And this is 2
wait.
mod 4.
You don't need to come like this. You can go like this as well. And it could
No, you
change the
can't.
parity from. So it
Yeah.
could be
Doesn't
like
matter.
0.
Due to Manhattan
It could be 0,
distance,
1,
the
2,
mod
1.
4 stays correct.
No, Manhattan distance only gives mod 2, not mod 4. Manhattan can't do mod 4. It only works mod 2.
It
No,
works
is it
after
mod
the
4
mod
or
4.
mod 2? Does it work mod 4?
Manhattan gives mod 2 only because you
No.
can take a small
No,
event cycle.
see, Manhattan argument will tell you the state of a cell relative to the starting cell, not independently. And that's
So
And
can we
only
do
mod
that in
2.
some
Only
mod
mod 2.
4
if the
sense?
Only
original
mod
state
2.
itself is changing between 0 and 3, which is even and odd, then you don't
Which is
know.
not going to possible.
And Manhattan only gives mod 2, not mod 4.
Yeah.
No, but if you prove that we know that these two are same parity in Manhattan. So if you prove that they are in opposite parities mod 4, like if they're 0 and 2 mod 4, we win.
No,
Is
this
there a
and
case where
this
both
and
are
this
0
and
and mod
this.
4?
This
Then
and this you
follow
want
by a
both.
symmetric argument.
Yeah.
But how do you prove?
So
Why should they be different?
No, is there a case where this corner is 0 and this corner is 0 as well? Can you make a construction for that?
Is it possible to get everything in 4x4? No, we certainly can't get everything. Can we get n square by 2?
By parity, these two are
Can we
odd
get n
and
square
these two
by
are
2?
even.
It could be possible that we
don't
can
think
just get
so.
n square by 2 sometimes.
But that's not equal. That's for not n equal to 2.
Yeah.
Numbers are
Not
equal to
true
2.
for n equal to 2. Maybe it's true for multiples of 4 or something.
Maybe for n equal to 4.
We are doing a lot of mod 4
Is
stuff.
there some Manhattan way to get that?
Manhattan gives mod 2. You can't go more
Yeah,
than
Manhattan
that.
No. Is there a path like this, something like this, but this fails?
Yeah, you get trapped.
You get trapped, but no, something like this works. Yeah.
Huh?
Okay, that is fine. If you do this, then you have 0, 1, 2, 3, 0, 1, 2, 3, 0. Okay. So that's sadly untrue.
Wait, 1, 2, 3. Okay.
Someone is genuinely concerned for all of them. In the live YouTube stream. Someone is again genuinely concerned.
Now, if it
for all
will
of
say
you.
it is just DDIT, I'm genuinely concerned for all of you. Wow.
Who is this?
Archit just says DDIT.
It says DDIT.
Yeah.
Just say we're trivially done by DDIT. Let's go ahead.
Actually, me.
Wait, we can actually apparently it's
Wait, let me open the live stream link. What is
animating the arrows, right? So we can use MMP at some point.
My God.
Wait, what is the live
Turbo is
stream link?
moving after all. Turbo is moving after all. Moving point.
Yeah.
Yes,
Oh yeah, like turbo moving point, TMP. Yeah, that works.
But Turbo is now annoying us. Very bad.
Turbo is such a scam, bro. We need to solve this quickly.
Yeah, we need to go to sleep.
Oh, we have P6 after this as well.
Guys, we have the final boss after this. If Turbo is...
I think you said... When did you start P5?
Start at 10, right? 10 is.
Yeah, we
No,
started
at least
P5.
at P5.
P5.
I think we spent like one
10
hour
only.
on the
Like, I
first
don't
four
think we took
problems
any
and
time on
like
the other
1 hour on
problems.
P5.
spent like
Like
yeah, we
literally.
spent too
So we
much
spent
time.
whatever P5 they want, P1 to P4.
Yeah, easily.
Yeah.
Like, remember in our RMO Livesolve, we spent 2 hours on P6 and no
Wait,
time on
wait,
anything else.
this we made like 40 minutes. Like we spent like
Yeah, but
on like 40
almost
minutes.
like 4 times than all other 4 components.
Yeah, easily.
But like
Even
P6 is
P3 we just solved in 10 minutes. Like, it was,
yeah, P3 was like, but P6 is hard. Like I
how do you
mean,
know that?
yes, I know that.
All you need is an open mind.
Okay, sure.
No, guys, if you were in a
How do I
contest and
get-
you tried P5 for 1 hour and you didn't get it, we would like obviously try P6, right? You wouldn't just stay stuck on
That is
P5.
fair. That is
Yeah,
fair.
So we
Yeah.
But
should
there
be
are
trying
also
P6.
5 of us.
No. Let's just
Sure.
finish this. How bad?
And especially if P5 involves a snail called Turbo, you definitely have to switch problems. It's very ample motivation.
Plus the answer for our case is 0 as well. So.
Yeah, like they had to do that. They had to troll us in some sense.
Just give even, nah. But okay, I mean, then you might ask question, why
No,
did you
like
give?
why not? Why not? Just give
I mean, then you won't name it as
0
well.
for an hour. The idea
But
is
then
if
it's
you have
not
a
a turbo
chance to
problem,
troll
right?
the
This answer is
contestants, just
not
take it.
bounded for some cases.
With a grasshopper hopping.
Okay, so have we got that f of n is either n square by 4 or n square by 2? We
Yeah.
have that much, right?
Just
Wait,
between
So,
two.
yes,
wait, hold
yeah.
on. So you at least agree that there will be like, you have some cycle and there are like 2 choices for every vertex on that cycle. Can we say something
No.
about
Because 0 to 3 it could change. No, okay,
that's I'm not
two
saying
some
they're
choices.
opposite. I'm not saying they're opposite.
Some 2 choices for everything.
Yeah. So can that not help us? Like,
That is hopefully helping us.
wait, hold on. So we need to like use both arguments together. So you're starting with 0 mod 4 here and 3 mod 4 here, right?
Yeah.
Where
So
are
now,
you?
Down. Yeah.
Wait, where is
so
Arshit?
like pick some cell and suppose that it
Then
has
you will follow Archie.
these 2 states from Manhattan. Like in the 0 mod state, it had these 2 possibilities. And let's say it actually finally chose this. And in the 3 mod state, it has like these 2 possibilities then.
Or maybe these two, or maybe the up down itself. We don't know.
It can't be up down.
It can be up down.
Because like at corners,
That is the point of the Manhattan thing. It can't be up down.
wait, why?
Okay.
Yeah, Manhattan
Yes,
can't be
yes.
up down, right?
It can't be up down. And like the preferred
So,
direction,
so
if it correctly
is this
behaves,
true?
will be like this guy, I think. Because like no,
Wait,
that's this guy.
so the 0 and 2 mod 4 states become 3 and 1 mod 4 states.
Yeah.
Hmm.
You know that. So you know that 2 mod 4 state became a 1 mod 4 state. So we know that even that one is rotated
It's
by
like
90
very
degrees.
forced thing because the number of lefts you take has to be equal to number of rights.
And number of ups has to be number of downs.
Yeah.
And under rotation, they have to be the same. So number of lefts equal number of rights equals number of ups equal number of downs. Like all of them
The
equal
number
n
of
square by
lefts
4.
plus number of rights is fixed.
No, like because it's works under rotation as well. You have something that all of them are equal.
What?
So, like even after rotation, you'll get like ups
No,
become
you don't
left,
have all
down
equal.
become
You don't have that.
rights.
You don't have
Like
that.
even after rotation, you have ups become left, down become right. So all you get is like
So they can
ups and
still be
downs are
unequal.
equal. Yeah.
So we have so you have like L equal to R equal to what? N by 2 minus some S and U equal to D equal to S, something like this, yeah? Because the total number of moves is like fixed or something.
And square.
Oh, yeah.
Square by 2.
What? Square?
N square.
Terms.
N square cells, not N cells.
No, this is also N square by 2 plus S.
So 0 became 3, 1 became 2 became 1. What became of 1?
Wait, n square by 4 minus.
Okay. That's
But I think 1 has to also become 0, right? Because look at this top right corner cell. It got rotated by 90 degrees clockwise, right?
Yes.
You want to somehow like induct on the path it following, something like that.
What? No, no, no. I'm not inducting it. I'm just saying that 0 became 3, 1 became 0. Everything got separated by 1. 0 became 3, 1 became 0.
Mm-hmm.
So it's like the same path, they just rotated it by 90 degrees.
No.
Yes, I proved that, right?
No, you will visit in different order. That's the point. Huh?
Yeah, but I proved that we're visiting the same order.
How?
Not same order, but it's somehow still it's still like that.
Same
See,
residue
see.
on 4.
Yeah, like look at this. Bottom top left, so it's from 0 to 3, right?
Yeah.
And there was a 90-degree clockwise rotation.
Yeah.
Now look at bottom. Now, because 0 became 3, 2 has to become 1.
Yes.
Yes.
Now look at 1. 1 can become 0 or 2.
Yes.
Yeah.
If 1 became 2, then 3 has to become 0.
Yes.
And everything at odd has to rotate 90-degree anti-clockwise, counterclockwise.
Yes.
But look at this top left one, top right one. It is going 90-degree clockwise. Left enter, then exiting down.
Hmm.
I mean, you
Wait,
can
no,
also have
no.
this way, right?
No, wait, in top left, this, no, in top left, something like, no.
By the
It
way,
could be
you
either, it could be either,
could
it could be
also
either,
have
it could
you
be
could
either.
also have stuff like this, by the way. Hold
No,
on.
it could be either, it could be either.
It could be like this
Mm.
also, by the way. Like it's not like the order is
Yeah, the
fixed.
order complete reverse.
And wait,
Yeah.
this is not what it's not what you're looking at. You're not looking at how the path is going through that vertex. You're looking at how the path going after that vertex. Right? So it could be either this, no, either this or this, and we don't know how it's saying.
But
It's at one way. If it's like this, then is this impossible? Can people come here? Is this impossible for the corners?
No idea.
Yeah, it has to be right. Like if you come like this, you're like dividing into two halves, and then it is going into this half.
I mean, okay. So like imagine the working.
So,
Imagine the.
wait. So is this impossible in a path? This going right and this going up is impossible, right?
No, wait.
Or no,
Why?
no. Yeah, no, it's not true.
yeah, it's not cooking.
No, so imagine that you.
Okay, but wait. Okay. So now in 0 it's like this, and in 3 it's like this.
Yeah.
And because
Yeah.
and 0 went to 3 and 2 went to 1, right?
Yeah.
So at this top bottom right cell, it should be a 90-degree rotation anyway. Because 0 minus 3 is minus 1, 1 minus 2 is also minus 1. 2 minus 1 is also minus 1. Both of them are right? No. 2 minus 1 is not minus 1. Wait, I'll. What is 0 minus 3?
1.
Wait,
2
bruh.
minus
Wait, hold on.
2 minus 1
This
is
is.
also 1. 2 minus 1 is also
I think
1.
I'm done. Wait, no. Yeah, I think I'm done. See,
What?
always like when you have some path like this, the opposite corners will have opposite orientations, right?
No, not necessarily. Not
Not
necessarily.
necessarily.
That's the thing
No,
that we
always.
proved.
No, like
No.
Oh,
no,
like
I'm
yeah,
talking about a working path that
a
works.
working path.
Like not
Okay,
talking
then.
about
Fine.
what the actual direction is.
Uh-huh.
So now, if this is
What?
0, 3, this can be like 1, 2 or something.
No.
But
Where are you?
that will not match up with this because the original things are different.
No, what
No,
if this is also
it will
0,
match. It's
3?
matching exactly. So 0 is corresponding to 2 and 1 is corresponding to 2. Right.
I think con is not the solution. Wait, guys, have we reduced the problem to showing that if there is a working path, then a rotation of 90 degrees is not a working path? Like if we prove that, are we done?
No. We are not
No.
close to that.
No,
Just that.
because
We
that is
haven't
Not
easy.
the turbo thing, but if
Yeah,
we have a
so
working Hamiltonian cycle and we rotate it by 90 degrees, and
it's
if
not
we also
equivalent.
get a
It's not
Hamiltonian cycle,
equivalent.
then we have n square by 2.
Yeah.
Yeah,
Right.
but
So we
that's not
prove this
happening.
not possible, then only n square by 4 works, and we're done.
No. We don't know that. It's not
No,
converged.
actually,
Purely
by
one.
the way, it's not like guaranteed that you have n square by 2 then, because like the order will change. So it's not even like.
In the new Hamiltonian path, right.
So you have like even got mentioned.
Yeah, it's
Wait,
so special.
all zeros became all 3s, so all 2s became all 1s, right?
But that's not necessary, is it?
Why? What will become 2 become? Manhattan
Like
created
if a
raised to
2
get
and a
Manhattan
0
3.
get swapped with each other.
I'm not taking corner. See, all zeros became 3s. What happens to all 2s? It can't become 3s because both zeros and 2s can be 3s.
All the zeros became 3s.
All the 2s can't be, none of the 2s can be 3s. So all the 2s have to be 1s.
We know all of them have to change parity. So if 0 becomes 3, 2 has to become 1 for sure.
Yeah, so every vertex, the rotation is by 90-degree clockwise.
Let's actually just do a 4 coloring, like
Wait. Can you just check what I'm doing?
What
All
are you
zeros
doing?
became 3s, all zeros became 3s, and all 2s become 1, right?
Yes.
So everything's 90-degree clockwise rotation.
No, in a correct version of the path, yes, but like
I
randomly.
assume that there are 2 correct versions. Assume the answer is n squared by 2.
Okay.
Once it became 0 to 3, then the 2s become 1. So everything has
No,
been.
but like 2 could also become like
No, 2
3.
has to become 1, right? No.
Oh,
Parity is
threes
like
are
parity
threes.
switches.
And 3s have like n squared by 4 capacity. All zeros became 3s. Because if a 0
No.
splits in, yeah, all zeros became 3.
Zeros,
Wait, I
some
want to
zeros
see
will
the
become 1,
problem
some zeros will
statement
become
again.
3.
That's what Aditya proved. That's not possible. Like sets
Why?
will just stay constant.
Why is that? That was an argument, right? I said.
Yeah.
Like I agree
Well,
that
yeah.
zeros and 2s will go to 1s and 3s, but it's not like 0 will only go to some fixed guy, I think.
That was
What
an
if some
argument.
zeros
Aditya
goes
proved
to
it at some point.
1s?
Aditya proved it at some point.
Yeah.
Nah, this is just cuff. We're just saying we just proved it at some point and just doing something.
Right.
We're doing nonsense.
Yeah,
right now.
we proved it at some point.
Guys,
Oh,
how about we just like
there
solve
was
the
a big.
problem from scratch and we like forget everything we did?
No, don't forget n squared by
Because
4.
we're just like clowning hard.
No, I think this actually is tricky. Like, I don't think this is.
It is a P5, but it is a turbo P5, so it can't be that tricky also. Okay, let's just solve this thing.
No, this is a
Yeah,
turbo
yeah.
because now it's tricky. You expect it to be trivial, but
Yeah.
I
Let's
mean,
do
odd
P6. We
numbers was
expect it to
like
be
so
hard.
trivial that it was tricky.
Yeah, that.
we should like do local arguments maybe. Like
Yeah,
instead
I
of
think that argument does not work, right? Yeah. Zeros can become 1s and 3s. What's wrong in that?
yeah,
What if
exactly.
some zeros become
That's messed
1s,
up
some
now.
zeros
So
become
basically,
3s, some
we
2s
are
become
back to
1s, and
nothing,
some
guys.
2s
We are
become
back
3s.
to
Yeah, back
like
to nothing. We're just back.
we are back to scratch right now. Everything is gone.
That's good. That's
Wait,
good.
do you think for 4 the answer is n squared by 2? Why can't it?
No. I'm pretty sure the answer has to be n squared by 4. Like it's not
Why?
like just n equal to 2 is 1, man. Like there's no
Bro,
way
it
it's
could be
not.
like 4 divides n answer is n squared by 2.
Nah.
Yeah.
I mean,
Because,
that would be
because that will
nice,
actually
but that
open
would
up
be
some
like
ideas for like parity arguments.
too
You realize,
hard.
for example, when n is like something, you have something important going on here. I don't know.
Also, like we are back to scratch. We can probably just go into P6 and come back to this later.
Yeah.
Right now, we're as good as we were 50 minutes ago when we realized that odd doesn't work. That's the only thing we
And
have
n squared by
right
4 works. Yeah.
And n
That's
squared
what
by
we
now. And
four
n squared
works,
by 4
yeah.
works. Like, that's the only information we have and we're working with that.
Yeah, and then you just like fix all it.
Yeah.
And after that, we just
But
clowned for
maybe
45 minutes straight
yeah,
and now we're
maybe
back to the
there's
P5.
some stupider arguments like something much
Alright,
easier.
let's leave it come back. Let's leave it.
Yeah, let's leave it and let's go to
Okay,
P6. Let's try
fine.
P6 of time.
Let's
If P6 goes
do
bad,
P6
we
and come back.
can just
Like,
like
we're admitting defeat to
come back.
turbo, guys. That's sad. Wait, someone pastes
I mean-
P6 though. Let's just see it.
I mean, a lot of people admitted defeat to Turbo.
Where to paste?
I do not
Even
see
when the
this.
answer was like 3.
Okay.
Someone
P6.
pastes P6.
There's
I don't
P6.
see it either. I will
I see
follow.
P6 over here, but this
Also,
is going to come somewhere else.
Wait, someone pasted or like.
Who do I follow for P6?
I'm
Okay,
following
Follow
you,
me.
Abel.
That is
Okay,
P6.
paste.
Okay,
I pasted.
follow Om. Follow Om.
Yeah, I pasted. Okay.
Oh.
I was on Zoom all this time. I wasn't even on
Why
the
is this a
I was just-
2025 to 2025 grid?
We have a doubly
Again,
stochastic
again.
matrix. Let's go.
Bro, we have a
No.
45 to the power 4 squares. Like,
What is this?
gosh. Hey, I like this problem.
Why are
This
you
is,
asking
like,
Chinese? Okay, I shouldn't say.
Guys, we have a
nice. I
doubly
swear, bro. I swear.
This is pause
I
for
sa-
celebration.
It's like 100%
No.
well known in China or something. R by C, it's not R minus C. Very interesting.
Okay, you have a magic square.
Not magic. We call it doubly stochastic. You're a
Yes.
math person. Guys, you have to listen to me. Let's start with 2 by 2. Like,
Let's
this
start
time you
with
just
1
have to
by
listen
1.
to
No,
me.
let's
No,
start with 1 by
Really
1.
one.
1 by
So
1
you
is
have
just
f
one
of
genius.
f of 1 equal
Let's
to
do
1.
No,
I
guys.
don't think
This is
n
about
order
static
even has anything to do with the problem here. I
Yeah.
really don't.
This
Let's
is
just start
this
with
is
2 by
just
2.
regular n. Just treat any n.
Let's just start
Good
with 2
2
by
for
2.
the
We'll do a
yeah,
2
2 by
by
2.
2.
2 by 2. Agree.
Good.
Thank God.
Yes.
I mean,
Oh,
okay.
guys, 2 by 2 is like completely trivial.
Why? 1 minus A.
Because one is
W
okay.
stochastic is like, yeah, answer is 1. For 2 is
No,
1 as
no.
well.
That's not the
Wait,
2
not
is
no
not
no
1.
no
What
not
if it's
1, not
something
1.
else?
Yeah, 1.
Not
It's 1,
1.
it's
You
1.
can do
It's 1, it's
better.
1.
Brother,
No, it's 1, it's 1, it's 1.
it doesn't matter. Like, sum is all
How
1.
do you
All
prove
rows
it's
are
1?
identical, all columns are identical,
Oh,
everything is
yeah. Okay.
identical.
This is cuffed. Okay. 2
Okay,
is 1.
sure.
Two is
So
one.
we
Okay. So
have
that's why we should do
1 by
3 into 3.
n minus 1. What do you think? 1 by n minus 1.
And for 1, it's 1
What?
by 0.
N
This
equal to
is
1 is
supposed to be
N equal to 1
greater.
is 1.
N equal to
N equal
1
to
is
1 is
a
1.
thing to that.
Bro,
One.
we wanted greater than 1, right? 1 is already attained. So, like,
Guys, what if it's 1 by n minus 1 factorial? Like that would be
First of all,
so
you can
hard.
always obtain 1
Hi.
because like you can just
Well,
select
guys,
Greater
let's
than
just
1.
permutation.
put
But
3 by
why
3.
are you?
guys
Oh,
give
what is 1 by n minus 1 factorial? You want something greater than 1.
Like,
Okay, then do N
What
minus
is
1
oh
factorial.
shit,
N minus
what
1
am I on?
What are you
factorial.
guys doing? You want something greater than.
Okay,
N minus 1
okay, remove
factorial
the
is
1 by,
answer.
remove
Okay,
the
also
1
like,
by.
let's just slow down, guys. Let's
I
just slow
meant
down.
n
Let's slow
minus
down.
1 by the way. Like I meant r by c equal to n minus 1. 1 by n minus 1, I was just saying ratio. Like I wasn't
Okay,
saying
wait,
the answer is at least n by 1 minus 1. Like you just
You're
want
saying
to
N minus 1
largest
factorial.
possible
properties
value
of
of
that
r by
ratio.
c.
Okay,
Wait,
let's
guys,
do
do
this
3 into
slowly.
3.
Wait. Let's do
Okay,
let's
so we want Ri
let's
to
do
be
3 by
really
3.
big,
3 by
right?
3.
So
3 by
first of
3.
all,
Yeah, let's
is
do 3
it
by 3. Let's do 3 by 3. And
3
like
by
we
3 is
want
here.
Ris to be very big.
like,
So like
Yeah.
having a perfect matching is a very bad idea, right?
Yeah, because
Yeah.
then
And then for
make
the
r and c
maximum
equal.
things.
We
So
don't want that.
you want a lot of the maximum in the rows by 100 kya likhiye, some 1 hai.
No, no, no. Watch this.
Actually,
How
you want
about
all the
something like
maximums
this?
of the row to be in the same column. Maybe
Yeah,
you can
yeah,
Yeah,
convert
like
that.
you
You
want
can
how
that.
have
about
that.
something
You can
like
run some
this?
partition.
Able, slow down. All
Yeah,
things have
guys,
to be some
2
1.
it's not 1. For 2
All
it's
things
I
not
have
have
a
to
1.
be some
strategy to
1.
get strictly greater than
2 is
1.
not equal to 1. Why is it
Yeah, for 2 it's
named?
not 1. Like take
Bro,
this.
what
Why
is
is that important?
it's
guys?
not working. Yeah.
Guys, just
I have a strategy to get
what
strictly greater than 1 by the way. Select everything distinct.
and probabilistically do something, eh?
No. Please don't probability. Guys, for 2
We'll get a magic
for 2
square.
the
We'll
answer
get a
is
Guys,
magic
2.
square.
For 2 the answer is 2.
Someone slow down. Someone just like
Yeah.
we should
Let's
take
not
deep breath.
let's not
It's
talk.
all so very,
Maybe
very
like
slowly just walk. We want maximums really big, right?
yeah.
Like all maximums, we want
No,
something
no.
like
We want
this.
the maximums of all rows to be in the same
Oh,
column.
observation.
Can't
So that
happen.
gives you an
Sums
We can
are
answer
assume
of
we can
n.
assume
Sums are
rationals.
same.
We can assume everything as an integer. Like we can do that. We can assume everything is
Okay.
rational.
Fine.
What I mean.
Okay, wait. Okay.
I mean,
Yeah,
Able.
sure.
Able, like,
Hmm.
sum has to be same for
guys,
every column.
sum has to be same for every row, every column. Everything is
Yeah.
1.
Wait, so
Not
that
one,
means we
but
can see this as simply like the sum of multiple permutation matrices. And that's probably the way to think about it, right? It's like you have multiple permutation matrices and you're taking some random scales and then you're just adding them up. That is what every such matrix looks like. And so you're really trying to figure that out.
I think this is normal things.
No.
let's just
This should be fine.
So for 1
Let's
it's
just
1,
have
for 2
some.
it's 1.
Let's just have a
It's
construction of
probably
something bigger than 1, like an explicit non-probabilistic
No,
construction of
so
something
pick
bigger
some
let's
than
two
1.
pick a magic
permutations
square. Let's pick a
and add
normal
them
magic
up.
square. Pick a magic square it will.
Wait. Okay, and we
Guys,
can
can anyone do for 3 something that's not 1? Like, can
Let's
anyone
draw magic square.
just
How do you draw
achieve that?
magic square?
just do magic square and scale it down to the
1.
Okay, guys, wait. I'll give you a magic square. That is not
It's like
an
this,
issue.
right?
That's not how you make magic square.
This is how you draw magic squares.
Bro, wait.
No.
No, wait.
No,
I don't
this is
know
wrong.
magic
This is
square.
wrong.
Okay, this
okay,
is a magic square.
I only know that 5 is in the middle. I have no other info.
No.
Yeah.
5 is in the middle if you want it to be diagonals also summing to the same. Otherwise, this is a magic square.
Okay.
The diagonals do sound the same. But
Oh, guys,
Okay.
this is useless. You just got 1 as the answer again.
Oh,
why?
So,
Why?
wait,
8 plus. Why? 8 plus
8,
7 plus
9,
9 and
7.
6.
8,
Yeah,
9,
8,
7 is
9,
a
7 on
perfect
both
matching.
sides. That's so
Bro, no one
sad.
listens to me. You guys
This
are
is what I'm
just
talking about. This is what I'm
evil.
talking about.
Don't do like 5 in the
It has
middle.
the sum of multiple permutation matrices, like and like fix good permutations now. Like find permutations for which the structure is easy to think about.
Maximum.
Oh, what is? Why are
maximum.
you erasing that? What is disabled?
What did you even write? R1, R2, R3. Wait.
Oh, I'm making a construction. Okay, just
So
Alright.
let's fix
Who
random
these you guys
permutations,
are?
tau 1, tau 2, and so on.
Guys, whoever makes a construction for R by C greater than 1 for n equal to 3, I'll give you a chocolate when we meet.
Okay. I'll beat you guys soon.
Right. I'll scale by 6.
Scale doesn't
Okay.
matter.
I think I have something.
What do you have?
I think I have a construction for if it
What is
works.
3 plus 3 plus 4 and 3 plus 4 plus 2? I have it.
How is this?
Identical to 9.
Where are you?
Yeah.
Wait.
I can't
Like
see it.
top right of yours.
Oh, very above. Yeah, basically same. You just multiplied everything by what?
6.
Some random number.
Oh, okay.
Whatever. This works,
Basically
guys.
same construction.
Forget about scaling,
what's
right?
the answer you
First of all,
got in
forget
here?
about
9.
scaling.
What is 9 by?
You
What
just
is
want
9
column
by
sums and
10?
row sums to be equal.
This is like 10 by
What
9.
is 9 by 10?
One is just
What is
better,
9 by
right?
10? 9 by 10 is 9 by 10.
10 by 9. This is 10 by 9.
10 by
1.
9.
What are you
Okay, so
doing?
you got something like 1 plus 1 by n square, basically.
Wait, what
Wait, this is a
No,
random
what did I
construction.
do?
Right, this is not
So,
to
wait,
get
we got
optimal.
1 again? No, we did not.
Wait, is
No,
it,
we didn't get
am I
1.
not
We
like
got something better.
We got like what is this?
10 by 9 is
Aditya,
it,
why are you
right?
working with fractions? Work with integers.
I'm working
Figure
with
it out.
9 by
integers, standard working fraction.
Yeah, I'm
I'm
working with
integers,
fractions.
I'm here.
10 by 9,
Okay,
right? 10 by 9.
so
10 by
you
9.
got 1
10
plus
by
1
9,
by
yes.
9, right?
And 9 by 10, 10 by 9.
Okay, wait, this construction should generalize, right? You'd
Yeah.
want something like this, right? The first column to have all of the big numbers, like all of
That's
some
all.
big numbers, A. Then
Yeah, like-
I'm 0 right here, let's say.
Let's call it n.
Okay, fine, let's call it n.
No, n
Very
is the size
helpful.
of the grid.
What
N is
what
the
Yeah,
size of the
exactly.
grid.
It is n. That's what I'm claiming actually.
It doesn't matter.
N.
It's all equivalent to scaling. Okay.
Okay, fine, happy.
Yeah, and then you have column of 1, n minus 1, n minus 1, n minus 1 also, right?
And yeah, like this is basically averaging out, right? N minus 1, all n minus 1s. Like
So
everything
here's an
right
idea.
here is filled with n minus 1s.
So here's an idea. Hear
And
me out.
right here is what you're trying to fill the remaining number, right? What is this number?
No,
It's n minus 2, n
N
minus 2, n minus 2.
Yeah,
All of these are n minus 2. And what
Except
is
for
this?
this one,
2n.
which is
Yeah.
is it
No,
2n?
no.
It's
2n
not
minus
2n.
1.
It's not
2n
2n.
minus 2.
It's 2n minus 2.
Yeah,
minus
whatever.
2.
2n minus
Wait, so
2.
imagine like fixing the like the topmost guy, so like the leftmost corner, and imagine
Archit,
permitting
where are
this
you?
for all permutations. Like, I'm just explaining. I'm not drawing anything. Like I'm just
Okay.
saying like fix P1 equal to 1 and then permute all the other things over all permutations and scale this up to some large n thing. So what that ensures is that this guy has like n times
It is
higher
direct
value than the other
What are you
guy.
doing? I don't follow. What are you doing?
Me?
No, Archit.
No, I'm saying like we can get something like this
Where are you?
and then zeros. And if you like
Someone
take
want
the
to
Why
help
is
with
this good?
expansion.
Why is this good?
and if you
No,
take
this
like
is-
the sum of two such things, that should probably help.
Well, here R and C are all equal, right?
Let's go, guys. I
No,
found
they are.
the general answer is this.
No, I think Kanav's answer is good. Like, no, the construction at
no,
least might be
wait.
optimal.
I don't think so.
It fits for n equal to 3. Probably
Yes, n squared plus n minus 2 n squared. This is the answer, guys. Such a
Okay.
lovely answer.
N square plus n minus 2. Okay, so basically 1 plus n minus 2 by n square.
Yeah.
So it's nice.
What did this?
Bro, that fails for n equal to 1 and n equal to 1. Yeah.
Okay, yeah.
It works out n equal to 2.
It works out n equal to 2. N equal to 1 is garbage.
No,
Wait, it doesn't work.
any polynomial that works must work for n equal to 1. Otherwise, like
we're considering n minus 2. That's why n equal to 1 not works.
I'll tell you what to do. Like write n minus 2 times n minus 1 by n squared.
Oh yeah, that is a good idea. So you
No.
just homogenize it or something.
Wait, so this is like you consider like n minus 2 in all the columns and like you equalize here. And this should work. So we
Is
just
that
like
an answer even more optimal than kind of conception?
Wait, what I was saying right here of n minus 1, isn't that what you've done up there as well?
Yeah.
No.
This is a 1, right?
Maybe. Oh, yo, man, what? No. Oh.
Like multiple copies of this you add, like in different ways.
Where,
Are we doing that?
Where are you? Archit?
Are we doing
Like
that?
this thing.
This okay. Wait,
Like this is your building block, right? That's why I said like take this and then like consider different versions of this, scale them up and add them. Here you're taking the same scale. What this ensures is like first row large.
Also, this constant is a bit weird. Value is a bit weird, right? Like, what is n square plus n minus? How are we going to get n square plus n minus 2? Except like without differentiation.
Okay, okay.
Find the maximum possible value far by C.
It's like n minus 2 and then.
Here, by the way, the answer is 1.
Wait. Columns.
Hmm.
This should be the answer. Like this has to be the answer. No, this is not the answer.
No, that's
No,
not.
what
are
is the
you?
answer for this, guys? What is the answer for this thing I've drawn here?
Is it?
Like n minus 1 and then a bunch of ones, n minus 1 and a bunch of ones, and then all 2s in here.
It's
Oh,
like
you're
what?
right.
2n minus 2 plus
It is
2
works.
2 times 2.
This works, but like you
Wait,
can
why
do
then?
even better, right? You can extend this and make it all 3s or all 4s after adding one more n minus 1 or something like that.
What's this? It's like 4n minus 6 and 3n minus 3. Right?
Yeah.
Right.
2n minus 2.
Which is like weird.
N minus 3 upon
This
3
is
n minus
better.
2.
This is a
No, it's
better
not
bound than the
better.
1 by n square one at least.
Is
But
it? Oh,
yeah, yeah.
No, it's not. It's not. It's not.
Like for n large, take n large.
No, it's not. It's not.
Wait,
Still
why
not.
yours is like O n? Yours is
Oh,
O 1
what
by
am I
n.
saying? Yes, yes. This is like strictly better.
This is getting 4 by 3.
This is
What
without
even?
a doubt. It's better.
That is surprising.
There's probably an optimal number of n minus 1s to take. You're taking like n
Yeah,
minus
yeah.
1.
Let's just take.
Maybe
Let's
it's
just take
like
some
root
Yeah,
k
what
n
if
n
you
minus
minus
take
one.
even more n
Yours
minus
is,
1?
yours
Like
is,
take
yours is
Yeah,
more
very
let's
n
take
different
minus
k
than
1.
our
minus.
perception. Hey, Achit, yours is very different
And
than our
what if
perception.
the number of
Does
n
it
minus
work?
1s
Wait.
you should take is asymptotic to like root of n? So for 2025, you take 45 of them and it just works out.
Oh.
That makes so much sense if it's true.
No, no.
That's it. This is it. This is what is cooking.
Otherwise, 2025.
Take k of these, and then you have a bunch of zeros.
Yeah, and we'll find it as some equation in K which we want to maximize.
It's not all ones. It's not all ones. I think it's all
It's
k
not
minus
all
ones.
ones.
Wait. This won't work. Like,
Achit,
Yeah, it's not this.
is it all ones or is it all k minus 1?
This is something different going on. Very, very scam.
no,
Wait,
We have
is,
to add
is
this
this correct?
property.
Is it actually like 4n minus 6 by 3 minus 3 or not?
It is. It is more optimal than the perception.
Yeah.
But does
there might be
taking-
something even more optimal than that, right?
But does
Yeah.
taking multiple help?
like what are the tools like?
Is what we're trying to
What
figure
is
out.
this? Is this like k minus ones and then k?
I
Like a
think
bunch
so.
of k minus ones right here.
Yeah. Right.
Yeah.
Yeah. And then
That's the
k.
case.
And then the rest are Ks, yeah.
Yes.
That works.
And so what's the maximum? It's
What's
like
the optimal?
k
Okay,
times
now
minus
find the ratio for this one.
plus what? N minus
N
k
minus
k.
n minus k times k. Yes.
And for this,
R.
it's like n minus 1 plus. Yeah, n minus 1 minus k. Oh my god.
So n minus 1 times k plus 1.
K minus k square
Just like
minus.
subtract one and then you're left with like this, right? N minus k by n minus 1 times k plus 1. This is what you want to minimize. Maximize.
Maximize.
My bad.
Are
You want to
sure?
maximize this. So find k in terms of n that maximizes this equation.
Take
And
derivative.
it will be k small.
Wait. No. Wait, it's not correct, right? There's a k plus 1. It's not k plus 1 over. Just k over here. Bit
Oh,
different.
my bad.
Yeah,
My
wait,
bad.
where did this term go? Yeah, this term.
Sorry. Once.
Wait, what is the ratio? Is it like what is it?
Oh,
Explicitly, it's something like this, which is like okay.
oh
We should factorize this. I guess.
This is n minus 1 times k plus 1. And the top one is, I don't know what the top one is.
we want to maximize some very weird quantity. What is this one?
Like just
Who wants to
differentiate and
maximize it?
maximize it or something.
Who's take the derivative? First,
It's not this. It is not this.
It's not this. Oh, okay. What is it then?
Yeah, no.
It's not
It's
this.
like just do the original thing. Like just it's not this what I've written either. It's like
Like
It's
Aditya is
this.
just so.
course.
It's
True.
not this. His
Agreed.
original just flows out of him.
So true.
Yeah.
Or Zora.
Or
Yeah. Someone take derivative.
Archit, like you complex bash everything, you can differentiate.
Yeah. Yeah, you can do.
Archit and Aditya are the only people who do 12th, right? So you guys know how to differentiate.
No, we already done
Like
12.
who do
No, we have to
CBSE
do 12.
calculus? Like come on.
No, we have to do 12. Get ready for it.
I haven't done calculus till now. No calculus now. You guys have done it.
Wait,
You guys
is
do
there
it.
no calculus in CBSE 10? That's pretty lucky.
No, nothing. You have
Is it
all
11?
GCSE?
He passed 11.
IGCSE, yeah.
Able.
But I took a subject called art maths.
Why GCS? Chad. I have no
Yeah.
excuse.
We did not differentiate in 11th.
There is no differentiation there.
No, like I got
what is
stuff
the
like
differentiation of k by k plus
differentiate
1
x
with
squared,
respect to k?
stuff like that.
Write it as 1 minus 1 by k
So
plus
1
1.
minus,
1 minus
right?
1 by k plus
minus
1 and differentiate that. Like Archit,
what doing by?
what is the CBSE 12th question?
Right.
How did you pass? How did
So
you
I think
pass?
k small is what's best. Like k small.
Like
So,
as small as possible. K
1,
equal to
why
1.
this 1 that?
Why?
Then
One
isn't
doesn't
k equal to
work.
0 the best? But that is obviously not true.
No,
K
k equal to
1 doesn't
1 you
work.
can't take.
Why?
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 Wait, 1 is getting n minus 1. How is it getting n minus 1?
There's some
Something's wrong.
calculation error.
Something's wrong.
No, k equal to 1
No,
gets
k equal to 1
1.
gives 1. K equal to 1
K
gets
equal to 1
1.
gets
So
1.
k equal to 1 gives
K equal
bad.
to 2 gets better though, which is weird. So it's like 2 is best.
No,
I think
2
can't
might
be
not
2
be
is
best.
best.
Some
2 can't be best.
function of n is best. Like
yeah, like
it could
has
be
to be.
root
Or
n
n is best. Or n minus 1 is best. Is n minus 1 best?
So, bro,
Oh yeah,
someone
No,
what
no,
is
no,
n
no,
minus
no.
1?
Differentiate.
No.
Let's differentiate. Somebody
Just
I
differentiate.
someone
differentiate. I'm
differentiate.
getting this. This is the derivative. 1 by k plus 1 whole squared minus 1.
What?
No,
What?
no.
No,
Not
no,
even
no.
possible.
That's
What
not correct
happened?
by
The n.
experimental tests.
Oh, 2n,
What
2n,
happened to this
2n.
2n?
Ah, bruh, 2n equal to k plus 1 whole squared.
No, no, no.
Yes,
What?
some root
Why is the 2? Why is the 2 there?
Root n. Oh my god, that is.
Why is the root of 2n?
No.
It's there. You guys put the 2n, so it's there. It did go.
Wait,
Wait,
something's
wait,
Get
wrong
rid of
here.
it. Get rid of it.
How did you get?
No, we got it. Why did I get rid of it?
No.
Wait, we are differentiating this, right? We're like
Yeah.
absolutely scuffing that.
No, it's correct. It's correct. Look at this. From this, you go to this. From this, you go to this. From this, you go to this.
Wow.
No.
That's
So
fine.
you're basically differentiating k by k plus 1.
Wait. No. What happened to
Plus-
2n? No, it becomes 0.
There's no 2n. Plus
Wait, even
nk
follow my
minus
arrows.
k square.
Even follow my arrows.
Alright.
It starts over here. You go
2n
here.
minus k minus
N
1
minus 1 is
times
ignore.
k.
N minus 1 is ignore. Then you go this next arrow here.
Yeah. Also, alright.
Just follow this arrow,
By
sir.
k plus
And then you go this kind of arrow.
Okay, so 2nk plus k plus 1 minus k.
Minus
Yeah.
K. And then you go
that
this
is good.
bottom arrow.
Alright. Wait, is this
Oh, it
correct?
has to be
2n
like
by
10.
k
Like, it
plus
just
1?
has to
Wait,
be
do
10.
these
Like,
values have to
there's
be
no
like positive and all, right? I imagine. Like that is probably the condition.
Yeah, they do.
Non-negative,
They're
non-negative.
non-negative real numbers, but does
Non-negative.
that matter? We can just add something to all of we can't.
Adding,
Why?
adding will make it
Adding
worse.
only multiplying works.
No, you can
Um,
add, but adding will make it worse.
K has
Right.
to be 45, right? 45, 44, 46. Just check these three values whether maximum that's the optimal case.
Yes. Like
but that
take
is
n
not
equal
the
to
case.
20,
It's
25
I mean,
and
the
then work with that.
differentiation is correct. The derivative is correct, so the construction is wrong. Maybe it's a better
If the
construction.
derivative is correct, then I think the original value that we differentiated, that is wrong. Because
No,
according
that's
to
also
the
correct.
derivative, k small is best. But
There's
k small
probably
is
ways to
evidently
optimize this,
not
like
best.
make it stronger.
No. The
What?
differentiation is correct. So the original expression is
Oh, try this. Instead of trying to
Let's do
make
better construction.
the first row have root n large values, pick the first root n by root n grid and make that have huge values.
Wait, it
That's not
contributes to column and
helpful.
row. It
That's not
contributes to
helpful.
column
It
and row.
contributes to column as well. That's
Ah.
not helpful. Like the
Or
idea is
maybe
just
they,
like
or is
avoid
it a
a
scam?
matching.
Like they give 225, but they actually wanted to take the root of 4050.
Probably, like looking
nah.
at 1, 2,
They won't do
3.
that. They won't do that.
Looking at 1, 2,
I-
3 is probably possible.
Like there are only two possibilities. Either it works for all n,
What is the
or
square root of
something
405?
special about 2025 being a
63.
square.
But there's a
63.
23. Okay.
Yeah, I
It's a
think
perfect
so.
square.
No. It's
What?
63 and 64 between that. 64 square is 4096.
You're talking about root of 4050. No? I don't
So
think that
K is
even
approximately
matters.
63, right? K is approximately 63 or something.
Yeah.
Yeah.
probably works out, guys. It's like calculate.
So like k is equal to root 2 times 45. That's stuff.
But root probably works actually.
No, like they definitely won't give anything that involves square root of 4050. Like
Why not? Maybe
be
they're
sure
Why
that.
not?
maybe
Because
that's
this is
the
not
whole
a
trick.
China TST P6. This is a EGMO P6.
But it is
This
though.
looks like a complete China problem. Like
I know,
I can bet this was in China some contest.
At China TST P6, they have like random constants and like pi or e might just spawn out of nowhere, but this is not that.
This is a stream, man. I don't think I should
Wait.
say that.
No. So do this. Like
Where
separate it off. Like take root n and then offset by this.
Wait, Abel.
And you get what I'm trying to say? Like the large values
Who should
appear
I
like
follow? Who
this.
should I follow?
it's
Like this.
Follow. Let's
This,
minimize it.
this. And this
What are
happens.
you
What?
doing?
Each of these has length root n, and this is happening root n times. This
This
is
is
how you
not
put the
helpful. This is
huge values. Why?
okay. This might be helpful.
This is
Okay,
helpful.
this might
Why
be
not?
helpful.
Why?
Wait,
Let's
wait,
move
wait.
it
Yeah,
here.
all these are
Move it
huge.
here.
Like these root and things are huge. No, like
Whereas
take
if you look
take
at
a
rows
concrete
will have
example.
everything large because everything has something large.
No.
Right, that makes
Consider
sense.
n equal to 4, for example. So you have these two into one things that are large,
Very big. Yes.
and the
Yeah,
rest are small. Does that give you a good construction?
I think so. I
Let's
think this
erase
gets us
them.
2. This should get us 2.
Let's take 1,
Kind of 2.
0,
Like 1 1 1
Zero,
1 and then
zero.
everything 0.
1, 1,
No, you can't do that. That is not a valid.
0, 0.
Oh,
Now
yeah.
these two sum up to 2. So we take 0.5,
Uh-huh.
0.5, 0.5, 0.5.
No, take everything 1 by 2. Everything else is 1 by 2.
Ah,
Yeah,
0.5.
0.5.
Yes.
But it said
0.5, 1
So
by
you
2.
have 1 by 2, 1 by 2.
This is probably
Never there,
intelligent.
1, 1, 1, 1.
1, 1, 1.
That's
This
like
is
4 by
multiplicity
3.
constant.
what?
No, it's not a
In
multiplicity.
generally like some random root n thing coming in.
How are you going to prove anything anyway?
That is
I don't know
very
about that, but like let's at least try some the constructions first, maybe.
Okay, maybe 4 by 3 is optimal. If 4 by 3 is optimal, that gives us a very huge leg up that root n is actually a good thing.
Yeah, true. We should probably actually just figure out what the answer for.
Maybe can we just figure it
4x.
out for 4 into 4?
Yeah. I'll do general in the meantime.
Okay, in the meantime, let's just prove this for 4 into
Like
4.
all of these are root n.
Yeah, and
Why
And
root 10? Okay.
No, just keep any number. Just
Fine,
keep
fine.
like
1, 1, 1.
150.
Root n is good. Root n is good.
Root n is fine. Get n.
All everything is 1.
Oh yeah, they all add up to n. Like
this sounds to like what?
So n
And
Like
plus n minus
the
root
rows
n.
are now like n minus root n by n. 1
This is
minus
2n
1
minus
is
root
1
n.
will.
This is 2n minus root n.
2n minus root n.
No, I'm wrong. See, this is root n n times.
how many? N times. Okay.
N plus,
Plus-
and now you divide
No, not
N minus
N
root
times.
n.
It should be
n minus root n.
n minus root n by n.
n minus root times 1. It's 1 over here,
No,
right?
n by n minus root n.
yeah, it's
No.
basically
What?
one
It's all
minus
ones here.
1 over root n.
N minus
Like
root
this
n by
is the
n
number.
minus 2.
What?
No, this is the number. 1 minus 1 over root n.
Yes.
Here it's n root
Or
n.
1 minus root n over
And you
n.
need to multiply it by n minus root n. You need to multiply it by
Wait,
n
is
minus.
this correct? Is this correct?
So that's just root n.
Hello
This time
everyone.
n is
Is this
equal to
correct? Is this correct?
n
Uh,
root n.
Come up a bit.
How?
Come
n
up.
root n by 2n. Nah.
Are you doing column? This is like
But rows are all root n's, n times root n.
yes.
yes,
Columns
yes.
are, yeah.
Yeah.
What I've written is correct, right?
How is
Yeah.
it 2n minus root n at the bottom? I don't understand.
Root
it's
n rows are root n. Root n of the columns are n, and other n minus root n
Yes.
are all 1.
Yeah.
How are they all 1?
They are all
Wait,
1.
no.
Check it.
They're not.
You want
Oh,
the
yeah,
sum
they're all
to
ones.
be
They are all
you want
one.
the sum to
Each-
be
They're all
n
one.
minus root n.
They're
How
all
are
one.
they
They're all
one?
one. They're all one.
And
They're
the-
not
Guys, they're all
one.
one. They're
No,
all
you
one.
have
N minus
here
They're all
already.
dumb.
Yeah.
written all
That's
one.
why they're 1. Exactly. That's why they're 1.
Guys, it's
These
all
are all
one.
supposed to be
It's all one.
zeros.
Yeah, and it's all ones. That's it.
Yeah.
And then you have n
No,
minus
it's not
root n
all
choice.
ones.
It
Are
is
you
all
all
1.
ones.
All
Just
one.
add and check. Just add.
Some is
My
like
bad.
root n.
Yeah.
Root n space. This is root
So
n.
it's
Yeah.
And
all
root-
ones. That is so nice.
Ah,
But this
okay.
is so weird. And root n by 2n minus root n. What is this expression?
Yes,
This
yes,
is
yes.
Okay,
n
now
by
what is the answer that we get over here?
2
No,
root n minus 1.
Yeah.
Yes.
No, wait.
Yeah, wow,
Instead,
very nice.
Wow.
let's read it. It's like if k
This looks
Is
cube
it better than the
divided by
previous thing? Is it better than this expression?
This
2
looks
k
very
square
good. It's
minus
like
k.
root n
Yeah, it's
size,
better.
right?
It's better.
It's very big.
Yeah, it's order of
Oh,
root n.
root
We have k cube by 2k square minus k.
It's very
Is it
good.
is it better
Like
than
in
the
general,
previous?
Now,
Better than
wait.
everything else.
125
Same thing,
by
like root n.
This is the best we have so far, right?
Oh my god, guys, this is the answer.
Not 69,
my
89,
God.
but yeah.
69.
89, 89.
It's
Okay.
89.
Like someone just
Oh
wanted
my
to
God.
write 69 over there, but okay.
Yeah, I was like, okay.
They should have
Okay,
given
guys,
n
we have
equal
a
to
lower
35
bound
squared.
of 20,
No,
25 by
this shouldn't be
89.
an
That's
answer.
so good.
45 times 2 is 890.
Like who got that 45 times 2 minus 1 is 69? Wow.
Nero, I think.
Okay, can we
Oh, this
improve
looks
upon 20?
this looks very good. This looks very
Yeah,
good.
like this, we got a order of
Oh,
root
89.
and answer. Order of root and is good.
Yeah, that's
Yeah,
good.
the answer is huge, but it's
It's actually crazy that this is unbounded as n grows large.
Yeah, which is surprising.
There's no
That's
limit.
nice. And if it
let's
grows
prove it
in,
for focus 4. Let's prove it for focus
Yes,
4.
we should
Why is
focus.
it 4
Let's
by
try
3?
focus 4. What
Yeah.
by
4 by 3. Why is it 4 by 3?
yeah, so according to the equation, we do get 4 by 3, but is that the best we can do?
Maybe some smoothing type argument.
Smoothing for like using root n is nice.
No, like you take a very small epsilon and you add a permutation matrix with weight epsilon. How does that change stuff? How big does epsilon have to be so that the max start of changing and then something happens?
Yeah. 25 by 89 is the current answer.
By 3.
This is better than the previous thing, right? When we plug in square root 2 in that
Yeah,
expression.
this is way better.
Yeah,
Like
this is
No,
that
no,
one
because
is
that also evaluates to something
bounded.
like. Wait,
4 by
what was the ratio here? Sorry. Oh, it's n minus 1. Oh, yeah. This is achieving like O of 1 ratio. somehow.
Yeah,
Like
that's not very good.
every ratio that we got till now was bounded above by 2 or something like that.
Got
This
it,
is
got it.
much better.
But 4 is still bound above by 2.
Is 4 by 3
I'll tell you
optimal for
something.
a
It is
4 into 4
bounded
grid?
in general, like for any fixed time. It's bounded. Even the answer 2025 is bounded. It's not unbounded. Actually, wait. Do we have a proof for that?
Of what?
Do we have proof that it's like it can't be unbounded?
No, because 225 by it's order of root in right now.
No.
I mean,
What I'm saying is like
Upper bound. Do we have an upper bound on the answer even? We don't, right?
we do.
No,
We
we
do.
don't.
Maximal number exists.
ah
So it's at most n.
It's at most n. We have a maximum bound of n and we have a lower bound of order of root n, which is good, I guess.
Between root n by 2 and n.
Yeah, it'll get like
order of
reconstruction
root n.
points probably in contest.
Okay, yeah, we have a maximal bound of upper bound of n, that fn is less than or equal to n.
Yeah.
very
Can we
interesting.
prove for 4? Let's prove for focus 4. What
Yeah.
do we do?
Oh, and you know the craziest thing of the n by 2 root n minus formula is that it works for 1 as well, which is very good. Like things working for n equal to 1 means you're on the right track.
N equal to 2. Whatever.
N equal to 2, no, okay.
we take root 2 elements equal to root 2 and root 2 elements
Yeah,
equal to
And I take the limiting case of
Or
that.
root 2 columns.
root 2 columns.
But for 4, is 4 by 3 optimal is the question. I don't think we can do better than that.
It is likely that this problem was selected because 2025 is a perfect square. Like any other
Yes,
year, then they would not
yes.
have selected this because like
This
floor
would not
etc.
work.
something
So
would have been there.
that gives us a big clue that the answer might be O of root n because 2025 is
Yeah.
fine.
Or maybe they accepted it because the answer
Also,
seems to be
technically,
root
we
n
don't
but
have
it's
a
not root
like to
n.
be very pedantic about this. We don't have a O of root n bound. We have a omega of root n bound. Like we know that it's at least root n, the maximum. O is always upper bound.
Yes.
Correct.
You can say theta if you want. That
Oh,
is
yeah,
just
yeah.
giving
Yeah.
those, like,
We don't know
theta.
that. We don't know it's theta. We just know it's omega.
The interesting part
But
is
it's so
about
scuffed that they made P5 and P6 a square grid problem. Like, how many square grid problems in a test?
2.
This is not a square grid test. This is an algebra problem.
Yeah.
But it is algebra with square grids.
No,
Like,
doubly
you know, you do
stochastic
P5
metrics.
and you're like, I'm sick of square
No,
grids.
like
Let's do
P5 is
P6.
like
And then P6 is also a square grid. You're like, what the hell is
it's
happening?
not a square grid. This is like real algebra. P5
But
is
yeah,
real.
this problem is very nice compared to P5.
How?
I mean, if
It looks-
n by 2 root n minus 1 is correct. If it's
then it's ultra nice.
By the way, subtracting one gets us something interesting. It's like root n minus 1 whole squared, the denominator, the numerator.
Numerator.
Yeah, wait.
So maybe we want to look at 44
want
cross
to look at-
44 cells somehow, somewhere, and get 44 square from them, maybe.
Okay, where is the maximum element? It's here.
You can permute rows and columns, so like you can obviously do some things. with
Okay, so
that.
you can assume the maximum element is here, right?
Yeah,
What do we
we
do
can
with
do
it?
that.
So this
Yeah, like
constitutes M.
scaling doesn't matter, permuting doesn't matter.
So this is M, this is M.
Yes.
We can assume that, yeah, the ultra maximum is in the top left.
Yeah.
Ultra
Wait.
maximum.
Why cannot be in here? Okay, yeah, sure.
By permuting the rows and the columns.
Yeah.
What else can we assume? We can even assume like M equal to 1 or something if needed.
I don't know.
If needed.
Okay.
We do not need that.
Wait, why not just mark all the 2n cells that are in consideration? Like,
Yeah.
Yeah.
Okay,
How
yeah.
do they look?
They look beautiful.
How do they look at the construction? Here. My dots are too small. Here, and which one do we pick?
maybe we
for
look at
the
like
others?
maximal stuff. Like look at the maximum cells you can select which form a valid permutation, and the sum of those numbers is maximal. So like you're going over all the possible permutation cells of size n.
Mhm.
And you take the one which has maximum sum. Does that help? Is it true that these are used whenever possible? Probably not.
We can
Guys, I
case
think for
bash
4
for 4,
that
like
that
for case
4
4
by
you
3
can
is correct for 4.
just like blindly case bash and do something nonsense with it.
Yeah, like by some mild attempt at by blind case bash, like I'm always getting 4 by 3.
As in like you can't have all distinct for the rows, for distinct columns. Then you just case bash if you have 3 distinct, you have 2 distinct columns, and if you have one distinct
what
column,
is
Or
one
you
distinct
do
is not
some
possible.
smoothing to make 2 rows equal or 2 columns equal, and
No,
then
so
work
like
with
for
that.
example,
Actually,
imagine you
smoothing is
split.
probably better.
No, so you split
Yeah.
n square into like n square distinct values, like a1 less than a2 dot less than am. So there's like m distinct values on the cells. And now take like ai and ai minus 1 and just smoosh them. Like change them into ai plus ai minus 1 by 2 simultaneously. What does that do? What effect does that have? Or like increasing by epsilon ai and decreasing ai minus 1.
Wait, you can't do that. Like, wait, how do you maintain the sum column?
Oh, we just like
Like
we can
row
smooth on it.
columns, like columns are
Could be
also
doable.
implemented. So you need to like take a cycle and do it.
2 by 2. Can you get 2 by 2 thing?
You can take a 2 by 2 grid or take any in general cycle and like epsilon and plus minus epsilon.
Yeah.
And keep
So
on
you can, for any 2 by 2 grid in general, you can make opposite corners equal or something like that.
Yeah,
No, wait, you can't do that.
not opposite corners.
This is
But
by
yeah,
the way
you
equivalent
can
to like
permute them so that the sum remains the same,
which is
as
like
long as they're
1
not
1 here.
maximums.
Yes.
Like and everything here is fixed, and then subtracting the same epsilon with the same permutation here, but then you flip these two.
So if you
Yeah,
have
not
like a
even
very
epsilon, like it doesn't
useless,
change anything.
So,
If
so
you have-
essentially, we can just use permutation matrix.
like basically if you have very useless 2 by 2 cell, you can a user as in like it's not
Okay,
contributing to
call a
matrix
cell
any
good.
column.
Call a cell good if it's being used as a row max. So like just
Fine.
first
Essentially,
There are multiple
we
romaxes.
don't
There are
care
multiple
about the
romaxes.
every cell other than
non-maximums.
row max, you're interested in keeping it as small as
Yes.
possible.
Yes.
No,
You use
like
smoothing.
you can permute them however, and it doesn't matter as long as you can achieve non-negative for the whole grid. We only care about the row maxes where a non-negative is achievable, and that's
So
it.
we should like try to make them all uniform, right? Like everything which is not a row max should just sort of be equal. It should be like a uniform distribution, and then these guys
No, like
drop.
in our construction
everything-
for n by 2 root n minus 1,
I
they're
think
all
we can
either 0 or 1.
we can at least prove this.
Correct.
Like everything which is not in a row max column should all be constant.
Yes.
Something similar to that, right?
That's
By
At least that
repeatedly
row
doing
should
this,
be at least that row should be constant. Like at least that row or something.
That column should be constant.
Whatever, something column. Yeah, column. Say.
No,
Okay,
why is this?
can
Wait,
we
no,
do
so
that?
we're just proving to this.
Yeah, so if we have a column such that none of its elements is a row max and we change all of them to be 1 by n.
Can't
Where
just
we are
change it
assuming the sum to
immediately.
be
You
1.
can't do that. You can't do that. You
You
need
can
like
do
a
that.
cycle. You need a
Oh
cycle.
shit, you need a cycle. You need cycle.
Because you have
That
two
is true.
columns which are like not involved in any row maxes. Then you can, I
And you
think,
can
do
change
that.
one to
No,
make
no,
them
no. You
all
get one
equal,
of
and the
them.
other
Get
one
one of
you
You
them,
can
can.
the
only,
other will.
yeah.
But the other will go up too much and
Because
become a
at
row max
most
or
one
something.
column which is not all row max, it is not going to be all ones. Right?
Yeah.
Yeah.
Right. No, 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 no.
It-
What if the sum is less than 1? What if the sum of the two things is less than 1? Then you can't make it 1. What if like a
Wait, did the problem say positive things in the grid?
non-negative,
Non-negative,
non-negative.
non-negative.
Non-negative. Non-negative.
If it said positive, that would be weird because you could just take a small
Oh,
epsilon
right,
and add
right,
everything.
right,
But
No, then the answer would be like everything that is greater than
it would
n
be the
by
same
2 root
for
n by
it.
1.
Is
Instead
then.
of at least you have greater. So that's all the change.
Yeah, but that wouldn't give a defined maximum. It would give a undefined.
No, because you know that in the optimal answer, no matter what you do, there's going to be a 0. Because otherwise, you just take the mean value and subtract everywhere, and that is going to be better.
Yeah, exactly. Yeah.
Wow. Very interesting.
So then you could write the minimum value does not exist and then like refuse to elaborate and leave. Like because you asked for a minimum. There is no minimum.
How smart? Maximum. But yeah, what?
Okay, Chinese people are not that dumb. They made the problem good enough.
Chinese?
I'm pretty
I
sure
mean,
this
they're
problem is
certainly
also
not dumb. They're like this, you don't have to be good taste.
But are we like blindly assuming that this problem was proposed by China or something?
I mean, has
Yes.
to be.
Because I mean this type of structure I've seen China do this multiple
Even Nikolai Beluga might propose this.
No.
This is certainly not him. He
Why
proposes
he
vanilla
stuffed
combi type
combi?
stuff.
Yeah, he proposed good comedy, like novel ideas,
He
something
proposed like
very
very
good.
hard good combi. It's interesting, but it's too hard, bro. It's
Problem
too
is
hard.
not from China.
100% this is Chinese.
And someone
Like
doesn't
I
like
could see this
Nikolai
on a
Beluga.
China contest and
Yeah, and be like, yeah, okay, sure, makes sense.
Yeah, this is the like stereotype China TST P6 and those random NTs as well.
that beta of m is less than root m to the 1 by 3.
But an answer that is order of root in like is nice.
It had to be. We're in 2025.
Of course.
23 years later, it's all going to be log n.
Now to make the next problem, like they have to wait 111 years to make something like this.
Okay, guys, I
91
Okay,
have
let's
a-
just solve the problem. Let's just
yeah,
solve
I have a nice suggestion. Let's just solve this problem. Yeah,
Okay.
that's the
By the way,
better.
they have to wait 91 years. Not
91, yes.
Oh,
Yes.
stop it.
I know I messed up my arithmetic like the 69 case only.
Yeah.
Okay, anyways, if
Basic,
you
yeah.
have two, like for 4 by 3, let's
Right.
4 by 4. Okay.
Okay.
If you have
We have proved that 4 by
only
3
two row
is
max
optimal.
columns, if you have
Yeah.
only two
Okay.
row max columns,
Okay.
Yeah.
then can you do something with the other two things? Other two
Okay,
columns.
yeah. Let's try that. We have two row max columns. We have this is M. And only
The
the
first two,
first
let's
two
say.
columns have row maxes. So all these columns, all
And the
these
second-
elements are useless. Like
Yeah.
all
Let's second
8
row we
numbers
say
here
some m2.
are useless.
Second row.
Sure.
Yeah.
This is M.
Why is it in the second column? Why not?
Doesn't
No,
matter, you
so
can commute.
Okay.
only the first two columns have row maxes, and the third and fourth columns have utterly useless
Yes,
stuff.
so
Like
you
they have
want
low
them to be
numbers.
like really small, right?
So now, can we make them all equal, or can we make them all really small? We can't make them all 0, obviously, but we
Yeah,
want
so
to make them all
we can
equal.
make them equal. Like we can't make them
Yeah.
really small.
Can you-
Like
We
let's
want
assume
to.
the sum is 1.
Yeah,
So we want to make all of them equal to 1 by n. Can we do
Yeah.
that?
like 1 by n or like something.
That
like
is also not true. Wait. Like each of the row sum is different from the column sum this time.
Wait.
In this
Oh,
only
yeah.
this thing, the
Ah,
column
okay.
sums and row sums are not the same.
Okay.
No, everything is a sum to 1, and we want to prove that in the optimal case, all the
But like those
things are 1 by
only
n.
two elements sum to 1 minus m, and the column sum to 1 minus 1. Like if you forget
Also,
about
Abel,
it,
you should probably show other row maxes in the first two columns. It's not just going to be M and M, right? There have to be other ones.
Okay,
Other-
let's call it M1,
Yeah, like this.
M2, M3, and M4 or something.
Yeah, whatever.
But the question is, what if 3 of the row maxes are in the first column and only 1 is in the second column? Is that better?
That doesn't matter. We're just considering
Can
Oh,
we
that
prove
makes
that
the
in the
maximum
optimal
smaller.
case,
That
there's
makes the
like
maximum
Hope
even
is
smaller.
that there are root n rows which contain the maximums.
Yes.
Yeah. But that
okay.
makes the
And
maximum
in
smaller.
each column there are root and row maxes or something like that.
Each
If you
column.
make more, if you make more row maxes, the maximum maxes become smaller, right?
Yeah.
More you put more
Yes.
maxes, the max smaller than.
Can we assume that all the row maxes are equal? Can we smooth and assume that? Like I can make all the row maxes equal.
I think we want to smooth and assume that these 8 useless things are equal. Can we do that
Wait,
somehow?
no.
Hey, let's
No,
smooth
Take
something.
the first. Wait,
Let's smooth
I'll
something.
answer
Let's
that.
smooth something. Let's smooth something.
Wait. Yes, smooth. I think, can you smooth this square?
This 2 by 2. This 2 by
Yeah.
2.
To make these two equal. Like M1 and
Right,
M2
right.
equal. Can you do that? That's
Is
possible,
that the
right?
optimal case? Do we want both of them to be equal in the optimal
Let's
case?
do it. Let's do it. Let's do it.
Let's
Right?
do it. Yeah.
No harm in doing it.
Like,
But you might hit some negative numbers. That's possible.
Yeah, yeah.
That is
So
a
assume M1 is greater than M2. So this is decreasing. So this must
Yeah.
increase. So this must
Yeah.
decrease.
Assume that M1 is like the absolute maximum, like it's the biggest.
So this
yeah.
is decreasing. So this is the issue. What is happening to this guy? This guy is decreasing. So this
It's
guy should be
fine.
not.
If
No,
this guy
it
decreases, it's fine, right?
could be zero. It could be zero. The guy could be zero and decrease.
Oh, it can go below 0. That is
Yeah.
fine. Correct.
So we need like let's not do 2 by 2 scale. Let's do cycle in some sense, right? It's like just pick a random cycle and just do it.
And
Let's go
smooth
from
it.
M1,
Yes,
go to
yes.
M2, find this thing that goes there and like keep on doing this. At some point we must come back. And that's
Okay,
happening.
can we
We don't
smooth
have.
this
wait,
M1,
this is
this
decreasing.
thing,
This is
M3 and
increasing.
this thing? Can we smooth these 4 things? I think this is more smoothable.
I mean, I think let's take a
No,
cycle
no.
which is like let's not pick a cycle. Let's take a cycle which is dependent on the numbers.
Wait, I'll be back in a
Yes.
while.
Yeah, okay.
Oh,
Wait, so we
okay,
start
I
over
think
here.
we can
It's
assume that
increasing.
something is 0.
We
We can
can only
assume
make
0
You can
by
only make two
smoothing.
numbers equal like this by the smoothing argument if they have the same color, like black and white. Like both of them must be black or both of them. Like opposite color.
No, there's no parity here. Parity does not
There is
There is
exist
parity. There
in
is
parity. There is
any
parity.
parity.
cycle.
There is parity.
Cycles
Is
have
it
parity.
parity?
Yeah,
Some
we're
have
still in a
parity.
grade. We're still in square
No, this is
grade.
not turbo.
maybe like mutant parent.
We're still in square grade. Yeah.
We're still in square phase. We're still doing combo.
Okay, so now when we move from M1 to M1 is a decrease, M2 is an increase. So there should be a neighbor of M2 which is not zero. It will
Yes.
decrease.
Yes.
One of
Sure,
these two has
because
to be not
M1 is the
zero.
biggest. Yeah.
So one of these two has to be not zero, which is not necessary, but is necessary for
Yeah,
us
but
to be
what
able
if
to.
these
Something.
useless guys are non-zero?
Something, bro. Just do it.
No,
Happens.
we don't need
M1.
to consecutive. We don't need to go consecutive. We can jump across.
We can jump.
Exactly, and that's why parity doesn't matter.
Okay,
You
parity
can
doesn't
jump
matter. My
anywhere.
bad.
So
My
how
bad.
does
Right,
parity
right,
come in?
right.
My bad. My bad.
It's any
Okay.
cycle.
Don't
Oh,
do
so we
that.
need to go to one of these three places. One of these three is non-zero, so we jump there.
Yeah.
Okay.
Do it.
And then you can just jump anywhere else. We jump over here. Oh, we are just done.
Yeah. So we
Is
can
that
make
done?
two numbers equal, right? That's doable.
Yeah, we can make M1 equal to M2. M1 equal to M2. Or you can make any two numbers
Okay,
equal.
yeah.
Any two adjacent numbers equal.
We
Any
can make
two.
any two
The adjacent doesn't exist. Like if they're the
same
same
column,
row or the
same
same
row.
column.
Same
Yeah.
column,
Same
same
row
row.
numbers equal.
We can
Correct.
make them equal. Love.
What if like we smooth on these 4 numbers, M1, M3, and the 2 useless things? So if we smooth on that, we can keep increasing M1 and
Well,
M3.
how can we see? If these two can be decreased, but these two will
Yeah,
be zero
so
source.
until one of them hits 0. So we can assume one of them is 0, basically.
Yeah. But
Isn't it better to have
adding
M1
the
equal to M2? Isn't it better to just have M1 equal to M2?
No, isn't it better if
wait,
the
what?
useless things are 0? Make all
What
of them
what's
0 and
happening to R
then
by
do.
C? What's happening to R by C when we made M1 equal to M2?
What is happening to R by C when M1 and M3 are increasing?
Don't know.
R.
Oh yeah. Okay, so basically what's happening is if the previous value was some R by C,
It will
then
become R
it's
by
gonna
C.
become R plus K by C plus K.
No. Wait, that decreases.
Can we
Oh wait,
show
that
that
decreases. Yeah, that's bad.
can we show that the n maximum values in the entire grid are all row maxes? They should be like by just swapping or something weird like that.
Basically, you don't have a very big column max as it's not
Yeah,
row
exactly.
max.
Or column maxes are supposed to be noobs. Like the only time a column max is big is when it's actually also a row max.
That makes sense. That should be possible as well.
Yeah, and in all the columns that don't contain row maxes, they are all equal. They're all some small numbers.
Yes. Yeah, we can do that.
I think this argument, like they're in the same column, pick two numbers. If there's a column max, we can make both of the row max in that row and the column max in that row equal by this smoothing argument. So that's good enough, right?
Wait, repeat.
Okay, so if you have a column
So,
max,
what are you
which is not a row
what are you
max,
proving?
like
Column
a
max?
column max is a row max.
Wait, column max is not a row max over here. This is a column max. It's not a row max.
I mean, it's at most the row max. So not
Okay.
bigger than a row max.
A column max
So
represents
if
the
you
row
have
max in that row.
so if a column max is bigger than the row max in that row, then by smoothing argument we can make them equal.
Wait. A column max is obviously the row max in that row because the row max is the row max.
The row max is the row max.
I am an idiot.
Wait 1 minute.
Lovely.
What all ideas other than have you done yet? Like, what did you guys cook in the time I was?
We can smooth, but we don't know if it's really worth smooth.
Like we
But
can
this
smooth to
non-negative
maximum
condition is
row
also
max, right?
good. So.
Big.
I mean, like smoothing does not help. Smoothing may do anything to RBC. It may increase RBC, it may decrease RBC.
We do not know.
Blindly smooth.
Wait, no. Why does it change R by C? M1 and M2 still says okay. Some other random guy might increase.
So M1 M2 change to equal, right?
Yeah, it doesn't.
But
But change by the sum stays constant.
But
And
if you
columns, the only issue is columns, some random guy might just increase and say hi.
can't we see this as the sum of n like permutation matrices?
Permutation matrices.
Permutation man. I knew you were gonna say that before you said that. What is this?
I mean, it is that. It is quite literally that, and that is like a classification of all things that satisfy this condition.
Yeah, but
What if it's a
max
sum
row
of
maxes are.
infinite permutation matrices?
What do you do to row maxes?
You sort of relax it in a bit. For example, the R being sum of row maxes, you can ignore. It can just be sum of some cells, right? Because the maximum will choose that anyway.
Okay, so C is the important
Okay,
thing.
but
Now,
C
C is the
also is
problem.
chosen in terms of the max, which is not good.
Yeah. So you fix the column maxes or something. Nah. Weird.
We haven't improved it for 4, by the way.
Yeah.
Yeah,
They're coping
no,
on
but
5
it
and
looks
6
like very true. Like it's almost 100% 4/3.
Yeah, pretty sure.
Let's actually look at
They're completely coping on 5 and 6 right now.
Don't try 5 and 6. Try 9 if you're trying anything after this.
what?
What?
P5 and P6.
P5 and P6, right?
Oh, P5 and P6. I thought you were trying 5 into 5 and 6 into 6 grid.
Try P9.
Okay. No, we're completely coping
Or
on
you're
both
not able
P5
to
and
do
P6.
it, and you want to do 9.
But we're coping more on P5 because it's a turbo problem and we just like absolutely screwed it up. P6 is fine. We are destined to cope on it anyway. So. Coping on P5 is good.
Wait, it's been like 1 hour on P6. Nice.
That's
1
fine.
hour on P6 as well?
Yeah. Like
Lovely.
50
No,
minutes.
What is this? We
From
finished
P5
day
to
1 in
P6,
20
we go back to,
minutes
like-
and we've been like coping on
I
day
think this
2.
was the same case last year also. Like 1, 2, 3, 4 were all very doable, and then 5 and 6 were the actual problem.
Right.
I think every EGMO is like 1
2
less
years
than
ago,
2 less than
Oh,
3 less
Yeah,
than
yeah.
4 less
No,
than 5.
EGMO is like 1 less than 2 less than 3 less than 4 less than 5 less than 6.
And this year 4 less than 1, but like
Yeah,
Like
4
this year's 3 was also trivial. It was some random length bash. Like
I mean,
I don't know.
not that
trivial is a big word. Should say
Yeah, it was not that trivial to be
correct bash motivations. It should be possible to do it.
Yeah.
honest. No bash.
I mean, if you just spot that the circumcenter of AMN lies on that line, then it's like
Yeah.
so
But like-
bashable.
Yeah, but intersecting.
All you have to spot is the circumcenter of AMN.
Angle chase superior guy.
In some cases.
But okay, so what do you guys think more doable right now?
How
Physics?
about we angle chase this problem?
Okay, sure.
I would rather complex bashes problem.
When you can trace this in the like so. But can you trace this in like complex number?
Oh,
Yes. What if you fill the grid with complex numbers instead of real numbers?
And find
Yeah.
maximum
Absolute
value.
value.
Consider
And
the
find
complex
maximum value.
ratio.
Maximum value in a complex number, right?
Yeah.
Oh no! You take the
absolute
maximum value of the
absolute
absolute value of the less.
Take a
But
note.
somebody has written this. 1 is less than 6, less than 5, less than 4, less than 2, less than 3.
What is a
No. You take maximum of the distance from the origin for
Yeah.
complex
On
ordering.
the live stream.
Yeah.
I'll delete some.
Let me open using my. What is this link?
What are you guys doing?
6 and 5 are the easiest problems I see. After 1.
Who said that?
Interesting comments.
Oh shit.
You
And 3 is like the hardest problem of that.
Without a doubt.
I think 3 was the fastest solve of us. Faster than even 1 and 2.
Yeah. 3 was faster than 1 and 2 for us, which was
No, 4
crazy.
was faster, I guess. Like.
Nah, I think
Nah, 3
Okay,
was the
so 4 was
fastest.
faster. 4 was faster.
4
Yeah,
was
4
faster, sure.
Okay, both the geos were just scuffed.
I mean, yeah. I mean, 2 was like, we did 2 and take a time. We should do, I guess,
2
like
2
P5.
was the one thing that we did properly, so yeah.
And I guess we should do like P5. P5 is doable. Or, yeah.
Like we have an option, like P5 or P6. What do we do? P5 we coped hard on it for a long time.
Guys, choose P5 or P6.
We should probably try like both for a
P6.
little while longer and then like give up and accept our fate.
No, like it would be very sad if we don't solve at least one. We should solve either one
Yeah.
of them.
Yeah, we should
That's
start.
like
Solving 6
target.
has more gloat points, so we should try
Yes.
6.
Yeah, let's do 6. Let's do 6.
But getting
Accepting
defeated by
defeat
5
turbo.
has more turbo
Let's just
speedy
solve
points.
6 in like 5 minutes and then do 5 also in 5 minutes. Like
No,
that.
we do 5 in 6 minutes.
Okay.
Okay.
Sure.
Sure.
Okay.
Okay, sure.
Okay. So
When does
how
the time
bad
start?
can the time starts when 5 minutes before we solve the problem.
Okay, guys, the time is 1:01.
No. Time
Why
starts
not?
5 minutes before you start the problem.
Yeah. Time starts when
Okay.
5 minutes before we solve the problem. So like yeah.
Makes
So,
sense.
yeah.
I think now is the time that we're 5 minutes away from solving the problem.
Great. It's not even 5 minutes to
Great.
solving 4x4 case, but sure.
We are so fast. Now,
Okay, let's do 4x4
2025
case.
by 2025.
4
case.
Let's do 4x4, right?
Okay, let's do 4x4 case. How about something like
Bash it out, like just bash.
2,
Okay.
6? Yeah, how
Oh
about
my
something like
god,
that?
what is broken?
Then this is like 000.
What are you doing?
Yeah.
Hoping for a better construction.
Yeah.
What?
Oh no, this one
Why are
is
there so many
bad.
tools?
This is
Uh,
bad. This is bad.
This is just like,
What
yeah.
is this?
But it has to be so many
That
tools.
is-
There's no other way we can fix it. That is very
Like,
sad.
why are you fixing it? We just prove right. Like, I think this should be true. Like, this is just correct.
4/3. See, that's root n. It is coming root n hits.
Yeah. 4/3 looks very correct, but we can't.
We will prove
Oh,
it
shit.
now. We should.
This is also wrong. Shit.
What? Okay, you're trying to achieve 4/3 another way.
10 versus what?
You've already failed, by the way. 10 by something integer it will be. It won't be 4/3. Like, that's not happening.
What are you doing?
Say this.
Hoping.
Is the sum supposed to be 6, 4, 10,
6.
6.
Shit,
Why?
okay.
What's the second column? What about the second column?
Yeah. I understand you. I feel you. Now we do some more jugaad, obviously.
Sugar.
4, 2, 2.
This is
What? Whoa! This is
What?
not
No,
fair.
you don't.
I just got I achieved 1. I achieved R by C equal to 1.
Yes, nice. That's the
Wait, hold on. Let's try this. Let's split the grid into like these root n by root n. You get what I'm saying, right? Like split into 45 by 45 grids, and then like
Yeah.
do something on each grid individually, something like that.
Or like
The quality case is very different.
consider
The
like
quality case is very
construction.
different. Yeah.
Maybe order them in decreasing row max or something.
Also, like you can
Um.
permute the rows, you can permute the columns, so nothing matters.
Yeah.
Yeah.
So you
Because
can
the
Give
grades
the
don't really
column so
matter.
that you
Grades
put
can be
all the
split.
row maxes together in one root n by root n grid. And you
wait.
get
So
something special
first we
about
can
that.
assume that let's say that the row maxes span k columns, and like you can assume that they're all consecutive. So it's like m1, m2,
Yeah.
this.
Yeah. Exactly.
Just the same way the root n construction we've written.
Yes.
Like in
With
the
n equal to 4, n equal to 4, right?
Yeah.
Yeah, so we're going to do n equal to 4, and we have split the 4 to 4 grid into this thing.
Yeah.
If there are 4
Mhm.
distinct row maxes in the whole columns, then it fails.
Yeah, so can we prove that all the row
distinct
maxes
row
are in the
So
first
row-
2 columns? Can we
So row
prove that?
maxes will be either in 2 columns or 3 columns, right? That's all.
Yes.
4
Okay,
columns.
now if there are 3 columns, suppose there are 3 columns.
Suppose there are 3
3
columns.
columns. Like we have M1, M2, M3,
Both of them are the same,
and
so M1 and M2 are the same.
M4
and-
is like chilling over here.
Yeah. Now, I think this should be direct, right?
Okay,
should
we'll
be-
just prove that this is not possible. Or
Okay,
Like
so
with 4, 3.
C1, C2, CM, like the first column C1 is at least column SL, my bad. C1 is at least M1. C2 is at
Comma
least
M2.
M3. C3 is at least, I assume M1 is at least M2. And C3 is at least M4.
Yeah.
The only
Okay.
thing that you're left with is the last guy, right?
And
Yeah,
it's at
let's
most.
say without loss of generality, assume
You
like
get 4 by 3 here,
M1
by
is
the way,
big.
because like
Do
no,
you? No.
you get 4 by
Okay.
3 if M1, M2, M3, M4 are all equal.
Are all equal. That's correct.
It's there. You get it even if M1
Directly.
and M2 are the largest. Even
No,
if
no, no, no,
M1,
no.
one of M1 and M2 is the
Wait, wait,
largest.
wait, wait.
Or something
See,
like that.
we've assumed that M1 greater
You can
than or
assume
equal
one
to
of
M2,
M1,
right?
M2 is the largest because
Yeah,
otherwise
we
you just
assume that M1 is the largest over here.
Huh.
Among
And
M1 and M2, but not among the rest of the.
yeah, not among the rest. So what if M3 and M4 are very big? Then we have like something good.
No,
you
no.
should try to
No.
them
Even
like
M3
big.
M2 is small.
Oh, M3, M4 small and M1, M2 very big. Right, right.
I don't know, man.
Yeah.
Which case?
M1, M2 big, M3, M4 small. Like let's assume like this is 100, 100 again. And like something small, something small.
Can we phrase this in flows?
So total row sum is at most M1 plus
No,
M2 plus
again.
M3 plus M4. So which means in the second thing,
Total row sum is at most
last
4
one.
M1 plus 4 M2 plus 4 M3 plus 4 M4.
No.
So M1 plus M2 plus M3 plus M4 is at most 1.
Yes. 8.
8?
80, 80.
80?
Why are you not
Why?
dividing by 10?
Yeah.
No, no.
Where's 8?
divide
Where's
by
80? What are you doing?
Are you using your Karam flashbacks or something
10. Karam flashbacks?
to figure out which number to put? Like, why not dividing by 3? Like, what is 10? What is the point of keeping multiples of 10?
Okay. This fails because these only sum to 190, which is bad. Oh, wait.
What's
I
supposed to
got
be
the
220?
I feel
Oh,
like you should be able to bound at least something like last column.
very
We
annoying,
can
no?
probably do some stupid bound.
We should try to make all the row maxes equal.
Indeed.
So make this even.
Wait. Last C4 is at most minimum of M1, M2, M3, M4, right?
Yeah.
why 8? Why?
Wait.
No, it's
What
not.
if it's
My
more than
bad.
M4?
My bad.
To the left, right? Okay.
My bad.
That was maximum of M1.
Yeah.
And you got at least. What is at least?
Yeah, we know that X is at most M1, M2, M3, M4 outside.
Yeah, M1 plus M2 plus M4. We want it at least.
Because M1, M2,
At
M3, M4 are the row
least. It's
maxes.
at least 1.
At least one.
Yeah.
Congrats.
So this is 1. Just having. M1 is at most 1, right? No.
Wait. What are you
What?
assuming the sum to be? The sum is N.
1.
1. Then X is
No, no,
at least
N.
Huh? Okay.
N. 4.
So you want this, right? M1 plus M3 plus M4 plus X.
1. Why X?
Okay, you want it. You're just taking it to be 1.
Why not?
Let's take
Or we
1.
can take X, whatever. It's not to make it homogeneous if you want.
Yeah. This is what you want, right?
Yes.
Yeah, so 4X
Now
is at
remove
least
all
3
the
and
common factors from just take
Damn. Crazy.
M1 plus 3 M2 plus.
Wait,
3M2
did I do
plus
some?
M1 plus M2 plus
Yeah.
Oh, you
M3.
bet
No,
no.
I
no
mean,
3M2 minus.
Just cancel it out.
this, right?
Okay.
Not 3M2, 3M4. No,
2.
3M2.
3 into
Yeah, 2.
Wait,
Wait.
uh,
Remove that M1, M2. Yeah, this is what we want.
Uh,
Horrible. Looks horrible.
Can we achieve this?
so we can't even do it even assuming 3 things are missing something. Not doing something. Right? Should we try smoothing maybe?
Oh wait, the sign of the inequality is flipped, right? We want the opposite.
We do.
Oh no, we
You
are
want
trying to
R by
No,
prove
no,
this.
you're right.
Yeah, we're trying to prove this, right?
prove this right.
Oh,
Here
right.
We want to prove this.
We want to
Oh,
prove
okay,
this
okay,
inequality. Yeah, correct.
Maybe see it as a bipartite graph. I don't know. Maybe that helps in viewing it better.
And
Like
then
now
use
it's like
Hall's marriage theorem.
no, for every vertex, you're looking at the maximum label on the left side, and you're doing the same thing from the right side. And you want the left side to have higher labels on each of its vertices. Maybe in the graph, it's like immediate what is going on. I don't know. In the graph, it should look like a root n cross n, something like that going on. Right? No, 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 no. A root n, not a root n cross.
Yes, we are coping.
Yeah. Oh, Rushless was also there.
Nice to see. I wasn't the only one who thought P5 is too hard. I agree with you.
P5 is very tricky.
But P5 still gets points for trolling.
P5
If
is a
someone
low.
like spent 3 hours trying to prove the odd case.
No one's going to do it.
It's so sad for them. And then they
Like,
come
you'll
out and
first try
realize
to
shit,
solve
it's
it for
zero.
free and you'll realize that there's no cycle in the first place.
True.
That'll happen. What you struggle with is n equal to 4.
So n equal to 4 is true in both cases.
Grid problem and 4x4 is impossible.
Both P5 and P6 are problems for us. Lovely.
Yeah, we're coping.
My God.
And 4 was the only problem we solved on this day. So
Yeah.
it's also strangely tricky.
I mean, I guess we can solve like P5. It's not that hard.
When will we rename INMO to SCAMO? Scamo.
What?
I think
We
it
will
happened
rename
already.
it soon.
I think it happened already this year.
Yeah, this year was Scamo, but happens.
Karan, we should probably not be saying that.
Sorry, I take that back. I think it was very high quality.
Kana, you just said something on
I mean,
screen.
I'm not asking you to lie.
It's like you ask me no questions, I tell you no lies. No, just don't say anything.
Exactly. Anything you say will and can and will be used against you.
Oh, what is going on? This is so.
Why can't we do this?
Maybe you should think of this as 1 plus something. And now that something is like 44 square by 89.
Square by
No, P6 is just hard. How do you smooth it
Guys,
to
I think
make
we're
that
just tired. Let's
written
do some time pass and then we can go back.
Kana, I think you fail to understand the point of an EGMO live.
Yeah, bro, won't you like stream like love letter on EGMO live stream or something like that?
Oh no.
So somebody's asking if we have solved all two.
No.
Reply with yes.
Yeah, I will.
Not solved. We have only solved 1 to 4 so far. When the
That was
5
like 2 hours ago.
that was true.
It was 2 hours.
Yeah, we've been
Okay, but
coping
I
for
think
the
we
past
have
year.
like we have something like we have the easier halves of both of P5
Bro,
and
why is bro commenting on the live stream saying happy to join for a game of Avalon? Right?
So I
Like,
said that.
bro, it's
No,
like
so like I think like
peak
we certainly have the
disrespect to-
easier halves of both P5 and P6. Probably.
Certainly.
P6,
yes, certainly.
P6, I
Like
don't
with
know.
P5 we've solved
Yes.
odd, which is too good.
Yeah.
And
With
with
the
P6
teddy
we've
bears,
like
That's not the
We
easier
were,
half.
like, restricted the answer.
Easier half. In
Like
honesty,
half, I thought half
easier
to be
half I
easier.
meant like n square by 4.
yeah,
No,
proving
no,
multiples of n
fine.
square by 4.
That
Like
is,
we proved
I
the
think
lower
N0
bound
is
for both.
the harder than that. I think N0
Without
is
a
harder
doubt.
than that.
Like we've solved 3/4 of the problem. And we've got lower bounds for both in some sense. Like there we
Yeah.
got a lower bound of n square by 4. Here we got a lower bound of
And there
n
we
by
just got
root n minus
We
1.
also have an upper bound of n square by 2. So we know we have
Yeah,
received.
we just have actually two options.
we
We just have two options.
two
We just have
answers.
two options. We know that
Yeah.
the answer is
In
n square by
P5 we
4
have
or
only
n
two
square by
options,
2.
yes.
We just don't know which happens when.
That's correct. P6 we have proved that it's
We have random
between
lower
order
bound.
of n and
We can get root
theta
n.
of
We can
root
get.
n over.
Can we prove just asymptotically at most root n? Let's try to do some batching. Like
Oh yeah, let's just prove asymptotic of root n and then call it a day and go.
yeah, exactly. Like let's give up on proving exact 25 by 18 and
Exact number, but we say it grows in
let's
order
get
of
at
root n,
most
like
10 root
so.
n or something, and then like
Sure.
go home.
I think I can prove root n times root n.
Of course, of
Crazy.
course.
Go
I
solve
can
any
do 45 root n. I can do 45 root.
Yeah, I can do for
Can you do 45 root n for large n? Is the question.
25 so large.
Can you
25
do? Can
so
you
large.
no? So let's try to do 100 root n for n equal to 10 to the power 500.
Okay.
How is that
500.
even helpful? How is that remotely helpful?
No, that will
That's
be
not
helpful.
asymptotics.
It could be like root n log 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 log.
Oh,
Not
yes.
log log, just one log.
Just log.
Two logs.
Just log.
Two logs.
One log.
Logs are too powerful, yeah.
Maybe into a log also.
Yeah, maybe the answer is root n polylog n or something.
Root n log n, yeah.
It's not no problem, guys.
I mean, I don't see many y products with root n log n.
Don't worry, we'll make one.
Let's actually like solve problem instead of facing the
Yeah, let's stop
solution.
yapping and solve problems.
Guys, we're not going anywhere. Like we've been stuck
How do
for the
we
last 30
prove
minutes.
any sort
not
of
doing
reasonable
anything.
product? Like smoothing is certainly an idea, but then how do you do it?
But yeah,
How do you-
it's possible. Maybe there's some like random inequalities that you just add up and like do some weighting on them and just add them randomly.
Like
Yes,
the
yes.
random inequality being 4x greater than or equal
Probabilities. Like
Not
randomly choose your stuff.
Like just you have some inequalities by some sum and you just add them up very with nice weights and like that just somehow does your job.
Yeah, maybe what if the n into a matrix is filled with like quantum bits? And
Quantum
they
Okay.
count out combinations. It's an entire state
Prove it from complex bashing to quantum bashing.
quantum math, come on.
How to use quantum computing on math olympiads? We need a lecture from you, Abel.
I wish.
Oh, we have received a hint from chat, apparently. Think
Okay.
of bounding the row sum by the number of columns the row maxes occupy. I mean,
That's
we
what we're
literally
doing.
were doing this.
Just stuck at equal to just get 3 columns, 4 maximas.
Yeah. Huh.
We need some like good lower bounds on X. How do we get lower bounds on X?
Linear programming.
Wow. We're doing everything but solving the problem.
I swear.
Like if all the row maxes are in the first 4 columns, then what is the maximum?
Just like you want to. Well, we do know that there is at most n square of these
what?
random permutation matrices that we need to care about.
Why?
Because like every time you remove something, it will get 0.
Huh? What?
Yeah.
What did you say?
Like we can show that it's the sum of at most n square scaled up permutation matrices, the thing that we're dealing with.
Why?
Because like every time, just fix a threshold. Like suppose
Okay,
the
wait,
minimum
okay, take the
value,
smallest element. Take the smallest element, subtract it.
smallest element other than 0, and then like draw edges and remove. And like at least one you think turns to 0 every turn. So 2025 by 89.
Is it even correct?
Imagine it was wrong.
What
This
if
would.
it's just wrong? What if the answer is O of n or something?
Okay, but okay. So even if it's wrong, even
N
if
by
even
2.
if it's like a better root n or something, do we have any upper bounds?
Yes, n.
I mean, n is not good enough. And do
Maybe
you
the
have
answer is
a
O of
We
N.
know that it's like, come on.
So
Like,
offense. It's just n by 89. Like, this is so offense.
yeah, we can prove that something is less than n by 8. Between n by 89 and n. Yeah.
So, wait. Come on.
There are more hints which are coming in.
No. Wait.
Let's
This is
just check the chat for a
very.
second.
Why is this recommended to me? I think somebody just joined.
4x is at least okay. Oh my god. 4x is at least 1 and 2 is 3 by 2.
4x at least 4.
Okay, you're doing 4x is at least 4, sure. So 4x is at least 4.
Wait, is that very useful, I guess?
3m2 minus m1 is at most 2m2, which is at most m1 plus m2, which is at most 4.
Yeah.
That's supposed to be impressive.
That's supposed to prove that 4 by 3 works.
Why is M1 plus M2 at most? Oh, what? What?
Wait, what?
Assume m1 is at least m2, right?
Wait.
Yeah.
Can you
What
prove
is
that
this
4 by
proof?
3 is optimal from scratch, like from the beginning?
No, not 4 by 3. If we're proving for 3 columns case.
Three
Yeah,
columns.
for this 3 column case.
Okay,
And
what
now
this
we have to
work?
work
What is
with
this
the
random thing
2-column
work?
case as well. It's okay. 3-column case is a good start. Now let's try 2-column case then. There are only 2 cases.
But its proof is very random, right?
Extremely random, yes.
Yeah, what if the entire P6 is just a random inequality and it just works?
It is. I mean,
I think this is an inequality. Like you just stated it in a grid problem. It's an inequality. Wait, this
Inequality
works,
disguised as
right?
a grid, yeah.
Yeah.
So we just have to do this nonsense. I'm convinced.
Yeah, you just take like root n cases for the number of columns that have row maxes.
Let's do.
And
No,
for
we
each
do,
case,
yeah, we
just
take,
do a random
we take
inequality
n
and
cases
it
and we just
works
keep
and you
writing
win.
n cases.
We just do like 45 cases, guys. Just 45 cases.
Yeah, it's just 2025, so it's a finite number
it's
of
not
cases.
even 45
Just
cases.
count
It's
it all.
like
So 25 minus 45,
Oh,
which is one
Yeah,
1980.
it's 2 to the 45
1980
cases
cases.
because partitions.
my God.
We can permute the rows in front, that is fine.
Finite. We're cooking. I think let's just do some
Yeah, like,
inequalities.
no matter what, can we
So
solve this
stop
by
computing the
computer
Wait, so
algebra
can
or
we
something?
prove
Like,
that if they span at least 46 columns, we are done? We can't even prove that yet. Just to let
Let's
you
We
know.
know
try to
that
do
we know that for
something.
4 cross 4. For 4 cross 4, we know we can consider spanning towards.
Because
yeah.
because
So
2
for
root n
focus,
minus 1 is equal to n minus 1. You're getting lucky there. Like 3 is
Yeah,
just.
yeah.
but
Let's
what
at
if we
least
can
focus
extend
4.
to n
Maybe,
minus 2, n minus 3, and so on?
maybe.
Let's finish focus 4. Let's finish focus 4. It's
Let's
now
finish focus
confined to 2
4.
columns.
Yes.
Confined to 2
Thank you.
columns.
Okay. Let's do the 2-column case for n equal to 4.
Now, first case we'll do M1, M2, M3 are the same column, M4 is the same column.
Yeah, but I think that case would be very easy to dispel, and then we do the main case.
But let's do the not main case.
Okay, let's do the
Can't-
dumb case first. So we have M1, M2, M3.
But now we have
and
X and
M4.
Y, guys.
As usual, we assume that M1 is the maximum, M4 over here.
M1 plus M2 plus M3 is at most 4.
Let's assume both of them 2 is 1 only, right? Let's just do this. M1 plus
Why are we
M4.
assuming X equal to Y again?
I mean, we're just making it bigger, right? X is at least 1, Y is at
Yeah.
least 1.
At
We're just
least
like very
one.
confident.
Yeah.
Into 4, right? Into 4.
Why can't
Oh.
it be 0?
Wait, no, into 3 by, not 4 by 3, 3 by 4. No, so 3 by 4, not 4 by 3.
Oh, it can't be 0 because of that.
That's right.
Wait, blue guy, go.
Blue guy, go. Blue guy, don't believe. 8 is at least 3m2 plus 3m3 minus m1 minus m4.
So now 3m2 plus 3m3 minus m1 minus m1 is going to be at most 2 into m1 plus m2 plus m3.
Yeah.
Just believe that.
So this
M4 can be assumed to be 0.
Yeah, so 2m2 plus 3m3.
Wait, hold on. Why is M1 the
M3.
column max?
2M2 plus 2M3 plus.
Why is M1 the column max?
No, right 2M3, right 2M3. I'm assuming
Okay.
right.
Okay.
2M3 plus 2M1.
Why is M1
This
the
will be
column
true.
max?
This will be true.
What? This
Why is
just
M1
this,
the
right?
column max?
Because
This is
M
true.
is largest. Like
Oh,
M1
we
is
just WLOG
Plus
assume that
3.
M1
Plus 2M1. Plus
is
2M1.
large.
You can't. That one
Why?
cell could be bigger.
Why are you doing
That one-
this?
that
No,
one
let's
cell
finish,
could be
right?
bigger.
take
This is
like
finished.
maximum element.
This finishes. Yeah, this
If
finishes.
it's
Okay.
true, now we check if it's true. It is
Wait,
true. 3M1 is
It's
bigger than
obviously
that.
true. It's obviously true.
3M1
Is
is
this
bigger than
true?
that.
Is this
Yeah,
true?
done.
Yeah,
We're
this is
done.
true.
How you
Oh yeah,
know?
we know their sum is at most 4. Oh
Wait,
my
no,
god.
hold on. Why can't
Correct,
why is
correct.
M1
It's a
the
generator.
column max? The first column max.
Assume it.
I
Assume
Assume it. It can be M1, M2 or
Oh, you're
M3.
just
It doesn't
weakening
matter.
it. Okay.
Okay, guys. Now
not
we're gonna
weakening, you
do
can prove
the
it, bro.
main
How
guy.
you go
we
from
can read worked out. Very we can read worked out.
Yeah, okay, this is probably very stupid, I'm convinced.
Okay, now in this case we have M1
Wait,
and
no,
M3
you
are
can't
Do the
assume
exact
column
same
max
logic.
like that. You can't
Why?
assume column max like that because you have to maximize it. Selecting a better column will
Of course you
decrease.
can assume.
What? I mean, it's M1, M2 or M3, right? Relabel M1, M2,
No,
M3 to make it
it could
M1.
also be the fourth cell.
I mean, then in that case,
No,
It doesn't become weaker.
What?
it could
I
be
Row
don't
the
max
know.
is
fourth.
on top, column max is on bottom. So
Bro,
you
are
have
you
to
you
trying
want
to
column
minimize
max?
R
So,
by C or something? That's like if you were trying to minimize R by C, that's what you would do.
Huh.
We're not trying to minimize R by C.
I like to,
You
I
are.
try to maximize R by C. And prove it's at most 4 by 3.
Yeah.
Oh, right. Okay.
So you want to take the smaller max size.
Okay. Makes sense. Sorry. Good.
And these are the 4 row maxes. So yeah.
Okay, so wait, actually, x equal to y equal to 1 again. Not a,
X equal to Y equal to 1 as usual. So
we have like
this
a
is
strict
true.
strategy which working. It's a good
Yeah,
sign.
yeah.
Okay, does this nice inequality strategy work?
So just implement the strategy, like assume M1, M2, and so on, and then somehow it will spit it out. Just have
Well,
faith.
Yeah,
but
that's
we're
the
not
idea.
clear as yet on how to extend it to higher end. See.
Yeah.
Okay, no, again, what will it be? This will be like what?
2m2 plus 2m1
No.
plus
plus.
No, did you just
2m4
did you
plus
just
Not
2m3.
two,
pick the
not two. One
inequalities
one
like
each, one each,
Yeah, one
not two each.
one each works. Wait, no, does one work? Yeah, one works.
Do it, and then check if
One
it works
works.
later.
One works. One works. Done.
At this point, let's just work with the general version, right? Like,
Yeah, now I think this is generalizable. This looks very
Okay,
nice.
wait.
we're done,
How does this work?
we're done. Yeah, this is
Wait.
correct.
Why does this not work?
Okay, this works fine.
Yeah, because these two are
3m2.
in 2 columns, right? These are in 2 columns.
Okay,
That
this
works.
works. I believe it.
Yeah,
Oh my god, this
key
is
inequality,
crazy.
guys. Key inequality.
Yeah, and now we just have to consider 1980 cases. Just consider 2025 minus 45
Brother,
cases.
there's probably some like dumb generalized way.
No, let's say we are in case number K, and
Yeah,
then we do
Archit
some
is
nice
doing
inequality.
good stuff. Thank you.
Yeah, so I think now we are basically done with the problem.
Yeah, now we should be like
We are
very
not
done.
basically done. We have to prove
We are
like
basically
2025
done.
more
We are
random
done, bro.
inequalities
We are
and
done.
then
I am
we're
We are
done.
convinced
basically
we are
done.
done.
This worked 3 times in a row. This will work every time.
Yes.
Are you sure that this
by
random inequality will always just
by
work?
induction, we are
It
done.
will work. Yeah, the strategy worked very
We're
I mean,
nicely.
inducting on
just like, we have
inequalities.
no
Wow.
intuition on where root 10 will show up. Like, we have no idea where that will show up, but well,
It
like,
worked. It
let's-
worked. It was
Well, okay,
it was
like-
perfectly worked. So
Jai
we
Hind,
can
Jai
Perfectly
Hind.
work.
Jai Hind,
work.
Jai
You
Hind.
know
It will
the
work.
constant n by
It should
2
work.
root n minus 1. It will just magically work. All the inequalities will
It will work.
come and
Because
it'll
it
all
worked
be
in 4.
correct.
It works. Yeah.
Like
It
it's the
works. It
magic
will
of the
work.
constant that does it.
I'm gonna go with the constant C right now because I don't know what is gonna work out, right?
No, okay,
No.
yeah, just say we want to prove that C equal to 2025 by 89 satisfies all the inequalities. But let's just write for some random C.
Okay, Steve. And let's not write 2025. Let's obviously write n.
Oh shit.
I'm writing it right
Okay.
here.
wait, let me
Right.
increase the boldness of my.
We started at like
Uh,
100% zoom, now we are at 13% zoom.
I'm at 11% zoom.
Yeah.
guys,
Yeah.
go to 14% zoom. Because that's what I'm
Why?
sharing it on.
Okay.
That's why you're writing aneurysms on the board.
Yeah, we
Yeah,
started
I
at
like
50,
50.
but we're going.
Constant time summation m.
Okay,
This
how
is
is
it,
the
right?
random inequality looking?
Lovely it is. I love
Oh
this.
my
one.
god, this looks so good.
What's happening here?
Like,
What are these weird symbols?
J1, J2, JK.
Okay.
Lovely, right?
no.
It's lovely. You have to agree it's lovely.
Wait, and we have a bound for sigma mi that it's
Wait, we didn't
CNK,
assume
right?
this case. We didn't do the case and all of them are in one column.
No, wait.
That is not possible. That is not possible.
All ones.
Yeah.
Yeah, one column.
So
Anyways,
we're basically using the bound that sigma mi is
should I
at
replace
most
C with
nk, right?
like k square by 2k minus 1?
No, don't.
No.
I mean,
Do
other
Because
do.
than
C is
that,
not k square by 2k minus 1. It's not.
Okay,
It's
sure. Wait, I will take
it's n by 2 root n minus 1. So let's
Yeah,
replace
k
that
square by 2k
exactly
minus
k square.
1.
Okay, not k square. It's not k
K
square.
is not root n. We are not taking
My
k root
bad,
n.
my
K is
bad.
random.
Let me take it to some m, right? How about this?
Yes.
No, but you
Yes.
could take it to k and then argue that k square by
take
2k
like
minus
L or something.
Yeah, we want to
maybe
prove
not
that that's
k square by 2k
optimal.
minus
But
1, but maybe something like that. Like I don't know, what is something that will maximize itself around root n? Like some function of k which maximizes at root n, and then you could
yes,
prove the
yes.
bound there.
Oh, you also wait. This is lovely because you get the minus 1 as well. You get m minus 1 squared. This is
Oh,
brilliant. I not in S. Call this set S. Okay. Like set
Okay.
S is like ji, whatever.
Okay.
So I not in S, you get m square, and the subtracting that you get, like you want to show n minus k, is at least m minus 1 squared, right?
Yeah.
Is.
Yeah.
This is lovely.
wait, hold
Yeah,
on. How did
Not
you get
lovely.
that the column axis at least 1?
it's at least 1, right? Because sum is n.
Because
M
the sum is n.
square.
We are
Oh,
assuming
M
sum is
square.
n and
ah,
we're
Sum is m square.
the-
You're scaling, so that's all sums
Yeah.
are m square.
like we're
Yeah.
assuming all the column axes are 1 because we can obviously do that.
You can decrease column axis.
now
Yeah, so the sum is n minus k over here.
Not n. What's n? N is m square.
yeah, n
N is
m
m square, yeah. M is equal to root n. And
Right
k is just random.
Oh.
Okay, now we do the obvious inequality. Let you use what inequality.
It is all
Wait,
right.
Okay,
Wait,
now
I missed some
wait.
constant.
You
2m
need
minus
Yeah.
1 into 2m minus 1.
Yeah. My
2m
bad.
minus 1. Yeah. Wait, it's n minus k. Why n minus? What?
because there are n minus k ones,
Where
right?
did
N
c
minus k
disappear?
1.
Where did c
C
disappear?
is equal to m
I
square by 2m
replace.
minus 1.
Yeah.
c is
Like
equal
c
to
is in terms of m right now. Okay, wait,
M
I'll write
square
that
by
Wait,
2m
together.
n
minus
is
1.
equal to root n. Okay, sure. Okay, then.
C is equal to m
Wait,
square
wait.
by 2m
Were we
minus
getting
1.
very lucky previously? How are we getting like
Yeah,
4 times 2 always?
like we always got the
Oh,
exact
oh,
constant.
I messed
No, we
up the
got 4 times
constant.
1.
I messed up the constant. It's 2m minus 1 by m squared, not m squared by 2m minus 1.
ah
Ah.
yeah.
Lovely. Okay, let's
What is
rewrite
lovely
this.
in that, bro? Like
Let's rewrite. Let me rewrite this. Summation mi I in S. I want this, right?
Yes, but like okay, then we just flip the inequality over here.
Plus n minus k right here, or m squared minus k. So I have m squared times m squared minus k. Be at least the elements in S will.
No, so the idea is the sum of the elements of S is at most nk, no matter what, because they're k columns.
hmm.
So you just
This is
use the
something that
bound
you
nk
get.
somewhere.
Okay, where is the bounds being written?
Just follow me.
Following you.
I
In S.
not in S. I in S.
Just
Wait,
to confirm,
what?
S is the set of columns, right?
But are you sure
Yeah,
this
S
is
is
fine?
like these m1, mi1 plus 1. Like this is S. I'll just underline it on the grid.
Wait, what is S?
This is like the same.
Look at the
The
grid.
maximum
Look at the
in
grid.
Yeah.
Like
S
the
is these random
The
the ones
rectangles,
the
right?
ones that are underlined. Like
Yeah,
the
yeah,
ones
this
in the
underlined
underlined.
one.
Maximus in each column.
Yeah,
Ah.
max.
Okay, makes sense. Yeah.
This set is this.
It's just
Yes,
k
yes.
elements then.
Okay, now you hope to prove that this guy right here. Okay, wait. Let me just change my color or something. You hope to prove that this
Square
guy
minus k
right here
times.
is it at most m square minus k times summation all of m, right?
Basically, this
Right.
whole problem is just praying that an inequality
No.
works.
Summation,
Wait.
no.
Why
Each,
not?
this is like only one of the semis, right? You need to consider each of the semis. What is summation? M square minus k by k. M square minus k by k.
By k.
Yes.
Sure. Are you sure?
Right, because summation of mi contains k columns. Each column has at most m
Yeah.
square.
My bad. Yes, correct.
You're
Okay,
assuming you're putting
this is what you want to
assigning
show.
equal weight to all of them. And you're grouping it.
This is what you want to show. Okay, let's just look at one particular set. So you have m1, which is like the biggest guy. M2 is at least say ml. Right?
Wait, let's expand this and like regroup this properly, right?
Yeah, that's what I'm trying to do.
You
So
know,
you
like
have
this
2m
expression,
minus 1.
this expression, like you just write it in terms of in S and not in S. Like this
I
thing
think
is in
we
both.
can
By the way, it will
inequalities,
probably
right?
make the bounding better, but instead of selecting like mi there and I in S or whatever, select the average of the maxes in that column. That probably makes life easier.
Huh?
Why?
Because then you can do
If
some
it works,
bounding,
if
like
it works,
Cauchy
does it
Schwarz
even
type stuff.
work?
You'll
No,
have
why is
brackets
it the
like
best
I1,
to
I2,
take the
and then
average
they
of
sum to something. They sum to
what do you call
Maximum
it?
is safer, right? Maximum is safer than.
maximum is safer, yes, but it won't get you the bounds because it will be weird. Whereas if you do that, then you can maybe hope to do some
Oh,
inequalities.
wait, what are you doing? You're doing it for each term separately. This may not work.
That
This depends
that
on
was working
K.
previously. That was working
No,
previously.
no. We did everything together, right?
Yeah, what if
We
this
did?
works?
Look at
Let's
the
just
bottom
pretend
of
that
No,
it
no.
we
works
did
now.
Why
everything
not
together.
replace with average? Why not? That will
No,
get us some
because
inequality. I
we
think
can't
the
assume average unless
No,
we do
no, no.
smoothing. We can't
Average
assume
is a bit
average.
strong. Average is a bit strong,
Listen,
right?
listen, guys. The eventual inequality, I believe, will be I1 plus I2 dot ik times 1 by I1 plus 1 by I2 dot 1 by ik is at least as large as that. So there's going to be a Cauchy-Schwarz at some point. This is my conjecture.
What?
Wait, let's just. What you're doing
Okay,
is weakening it,
let's
right?
try
Let's
with
just work it
maximum. Let's
strong. Let's
try
just
with
work it
S, and
strong,
then
right?
if
Why
doesn't
weaken
work,
it?
then we'll go to smoothing or
Wait,
something.
Achit, what you're doing is weakening it, right?
Yes, I'm just
Why do
replacing.
it? Let's make it strong first. Let's do strong version
Fine.
first. Why weaken it? And it gonna why are you doing this? Why not just work
Yeah,
with
my
the
bad.
whole
I
thing?
realized that. I realized that.
Just like split it into inequality of in S and not in S. Like can you do that? Like I don't have my pen. Can you split this inequality into in S and not in S?
That is what I split it into. What do you mean by that?
Yeah,
Like
but this
take
side,
plus
this
some.
side, this side, this
Some
side.
take. Okay, okay. I see what you mean. I see what you mean. So you want to show. So like we want to show 2m minus 1. I'll go back to red because red I was superior. It is 2m minus 1 times. Okay, I'll just call them something. Like let me call this capital N. Let me call this capital B.
Wait, what? In this case, 2m minus 1 is smaller than m minus 1 square. In our case, 2m minus 1 was bigger than m minus 1 square. This shouldn't matter, hopefully.
It's fine.
If this fails, I'll be very disappointed.
I think this might fail. It just looks very failable.
Tool.
So then let's go back and like fix what we're doing. Maybe I have
No,
to
okay,
put
just
some
let's just
weightage.
continue with it. Let's just continue with it.
No, this
This
is
K
wrong,
is very
right?
random, right?
Yeah, what if we just take A
This
to
is
be
wrong,
like
right?
very
When you
large
say
or
I
something,
not
then
in
it
S,
fails.
you don't mean all the other, like what?
What?
Oh,
This is
Never mind. Okay,
right.
okay. Fine, this is fine.
This is what we have. We have to.
Yeah.
Okay.
Very suspicious.
Oh,
Yeah, these
okay.
expressions
You
don't look
also
nice
have
at all.
to
Those expressions
you have to
always look
use the
nice.
following bound. You have to use that A is greater than or equal to K, and B is less than or equal to
Okay, no,
n
okay.
minus 1 times K.
I think what we weighted each column identically, right? I don't think we should weight each column identically, right?
Right.
You
That's
want to
possible.
weight it on the number of things that are in that
Elements
column.
in that column. Yes.
Let's try to individually bound this somehow. Individually just bound this somehow.
Do it using the average.
Wait, why m1 squared?
How can
What's
we
square
assume
doing?
Oh, it's
average,
not an M.
Ashit?
Yeah, square. My bad.
Okay, no, m1 is at least right.
M1 is at least all of these values, and you want to bound it to some, say, constant times some, right?
m1 plus m2. Yeah. Yes.
So this should just be like, you want C plus m minus 1 squared. Wait, did I mess up above?
minus something.
You didn't mess up. You didn't mess up.
No, like this is here. This part I messed up. यहाँ पे sign minus आएगा.
Also, maybe like write this as
Whatever,
let's
we'll
talk here.
come back
Let's
to
talk
that.
here. Come
Yeah,
here.
let's come back. Yeah, but this
P
quantity
plus m minus square into m1.
time.
m1.
Oh, 1 second.
why not write it as 2m minus 1 times total sum minus m square times m1? That's cleaner, right?
What? Yeah, maybe. I don't know.
Like
Basically, get this.
write it as 2m times total sum, which you all have on that side. It's like 2ms, 2m minus 1 times s.
Let's just finish what we're doing here.
Okay.
We're already getting.
This
Yeah.
works, right?
Is it 2m minus 1 minus c?
Yeah.
Yes. This thing.
So this is the C
Find
that we want
C.
to calculate.
Yeah, find C. Yeah, and then you're just hoping that summation of all C is k.
So use Jensen or something.
Just expand it. I think that's the better thing.
Yeah, basically the idea is the optimal
L,
constancy
CL,
is order of
CL,
root n,
CL.
but here like we know that. CL,
Right, CL.
because you're adding thing as well.
This, yeah. Yes. Now
C is
we
equal to this lovely quantity.
now we add this over all L.
And now the best possible value for this is 2025 by 89.
Magically it will
What?
come up, huh?
Wow.
2m minus
Wait, there's a
1.
different C. This C is different C. This is a different C than that C.
Yeah.
Oh, wait. This is 89 by 2025, right? This
This
is
is
No,
like
this
one
is
part
not
of the
C. This
sum,
is a
right?
different
No,
This is
C.
something
yeah.
very
You need to sum this
This
up.
is very different. C is not
Yeah.
the old C.
Wait,
This is a
what do
new
you
C.
define C as?
You need to like sum this
Yeah.
up, right?
Some hopeful constant. C is
Okay.
defined as
Okay,
this
okay.
blue thing.
Let's find the optimal new C.
Wait, no, we don't need to find optimal new C. We want to sum it over all things and then prove that that's at least.
Hey guys,
Optimal.
this is
2025
actually
by
very
89.
nice looking.
Okay,
This
at least
expression
M
actually
square
looks
minus
like
K.
this. This expression equal to this, which is equal to very nice. It's equal to 2m minus 1 minus m squared by L.
Can we sum this up over all things?
K, right?
Okay.
No. Yes, K. Sum over all K.
K times.
Yeah.
So summing all of this, I get 2m minus 1 times, whatever,
K.
K times K
times K minus
plus.
summation m squared by those Li's things.
Oh, okay.
Yes, and you want this to
Yes, yes.
be at most M square minus K. At
Yeah,
most
so
M square
you're
minus
basically
K.
trying to
At most M
What
square
bound
minus
do I
this
K.
want
sum
this to be?
sigma
At
1 by
most
Four
M
times
Li.
m
square
squared
minus
minus
K.
K, right?
No, yeah, no, M square minus
Oh,
K.
yeah,
M square is already
for
counted.
all. Right.
M square is already
Okay.
counted.
Oh, now we can actually use some
M1
sort
plus
of
M2 plus ML
pencil
is
type
at
thing.
most M
Like
squared.
we want to bound sigma 1 by Li. So
Wait,
we
wait,
want the
wait.
Li
Yeah,
to be
so we
equal.
can use
Guys,
Scotchy, I guess. Like.
everyone
Wait,
slow
wait,
down.
wait, wait. Wait,
Everyone
Kanav,
slow
it's
down. Like,
M1 plus M2 plus ML is at most M squared. Use that. It's C into that,
m1
right?
plus.
Look here,
Ah.
come here. Come, follow me.
Wait, let me just follow. Yeah, I'll just come. Yes.
This is at most M square already. This should correspond only to M square minus K.
Right. Got it.
Yeah, so only M square minus K. That's what you want.
Oh, shh.
Oh, wait, what?
What happened?
Yeah,
Oh,
lovely.
okay.
We are cooking, guys. We're cooking.
So summation of
So-
1 by Li is how much?
Yeah,
Summation of
this
Li
is-
is known to be M. Summation of Li is known to be M squared.
So
And
Cauchy
now
was-
use Scottish words.
Yeah,
now
yeah,
you use Cauchy's words.
Oh my god. Are
Yeah.
we actually cooking
That's
this?
the point.
Wait, at least, yeah, at least. Is at least what?
I'm just writing
Okay.
this expression.
Wait,
Okay.
no, according to what is sigma Li? Yeah, this is this Cauchy.
This is what you get.
You want to
Yes.
prove.
Why?
This is what you want to prove.
And it's
Yeah.
Scotchy.
That is Cauchy. If
Yeah.
No,
sigma
let's
Li
check,
is
let's
given.
check, let's check, let's check. Summation, so what we know is that M square times summation 1 by Li is at least K square. Ah, it
Yeah, we're
works.
actually using Cauchy's words.
Yes.
K by M
1
square,
by
K by
Li.
M whole square. K by M whole square. Summation Li is M square.
Summation 1 by
The
Li
summation of Li is n, right?
And so
M
like
square,
K
and it's
must
M
be equal
square.
to M as well for equality.
Yes, this is all perfectly works out.
Yes.
Wow.
Oh my
wow.
god.
Wow.
Oh.
Would weighting by averages have worked as well then? Because that
This
is
was
what
very
we-
close. This is so close.
because
This is close.
if you assume average, we're solving a weaker problem. Like this is the full problem.
No, but you
I mean-
did the same thing here.
I mean,
Like the
this was close, right? This was close. Okay, no. No, look at this then. Actually, come here. You're saying you want
Oh
to
my
make this
God.
M1 an average.
Yeah.
That's weakening stuff.
So basically, how do you assume that all the MIs are equal in one column? You can't.
like use the fact that M1 is pretty big.
Yeah.
Hmm.
And
my God,
this
so-
was like close, right?
Yeah, very close.
Wow.
Wait, are we done now? Are we done?
Yeah,
Yeah,
yeah.
So
Whoa.
P6 is basically Cauchy's words.
Yes.
Oh my days.
And final AMG. No, finally
Yeah, and-
use
Yeah, sure.
K
like,
minus
and
K
it
by M
works out for
30.
n squares.
Okay,
Okay,
so crazy.
answer-
2025 by 89 is answer. That is
That's
crazy.
such a pro constant. I love this.
Yeah.
Okay.
My god.
Okay, now no one cares about P5. Like this is beautiful. Like we
No,
found
we
a
should-
constant of 2025 by 89.
We should solve it. We should solve P5. Like,
Yeah.
Yeah.
hey, at T minus 5 minutes, solve this around 5 minutes. My god.
It's been
That
like-
was
Crazy,
that
crazy.
was crazy.
This is
Slowly
the
you can
only
increase
good
the
math
text
that
size
we did today.
decreasing.
Yes.
The text size decreasing is all you'll see. Like it starts with like some huge thing, and the zoom percentage started from like 100. Now it's
You know,
6.
you guys should just see the screen. I'm going to zoom out to the whole thing. And we started with all that fan art there. Text is very big. And you just keep going diagonally. It is getting smaller.
No,
and
we go
smaller.
like first.
But where is
These
the
Makes sense
random.
because you write left to right in paper, right?
No, but
What's
we're going
happening?
in a diagonal line like this.
Hey, we went a bit left and then we started going rightwards.
Yeah. Wait, I guess we can just do the P5 now.
I'll just finish it.
Yeah, let's just.
Finish it.
Wait, also like, can you just sketch the whole proof of P6 again?
Oh, I'm not doing all this again, man. Like,
No,
Okay, just
we'll
explain.
write it up
okay,
on
we'll just,
AOPs
Yeah,
or
we'll write it up
something.
later.
yeah,
We'll
we'll
write
write it
later.
on
We'll write it up
We'll
later.
write it up on it.
This is actually
Yeah.
not so bad to write up also. So
Yeah.
something worked out
Yeah,
nicely.
yeah.
After
You're
a point,
just
the
writing it
algebra was
as an
fitting, yeah.
inequality, so it's very nice to write up actually.
My God, my
It's
God.
hard to solve it.
That was a complete China problem. Like,
Yeah.
No, but that was such a cook, like just figuring that just plain inequality works and reducing it to Cauchy's first.
Okay. Yes.
oof,
Yeah.
oof.
No, like
Now
one of the
P5.
hard parts of P6 is figuring out that root n is optimal. And then if you know that, then you
Yeah,
can use that to cook up some inequality.
that is true.
Yeah, construction is not so bad. Just do some random stuff.
Construction
Also,
is
like
very
the
nice as well.
bound
It's very
barely
nice.
uses root n. The bound like barely uses root n. Like if
No,
you just
except in
do
that Cauchy Schwarz part,
At the
you
end,
make
then
all
and
the
it just
allies
comes
equal
up.
and that gives root n. It gives
no,
li equal
Cauchy
to
Schwarz
root n.
also. Yeah, Cauchy Schwarz
No,
like
at the-
just the last step
Yeah,
is
last
not
step.
the
easy.
only thing that gives you root n is that all the allies are equal. Hence, all the allies are equal to root n, and that
Wait,
finishes.
no,
Yeah.
and the last step at the inequality k by m minus 1 whole squared.
Yeah,
Yeah.
K must be equal
The
to
k
m.
equal to m.
K by m minus 1 whole
Okay.
square was the main. Yeah.
Oh,
Good
okay,
game.
okay. So we're minimizing k by m minus 1 whole square. Wow.
Yeah.
Nice.
Very exhausting problem.
Hey, it's
Very
fine.
Chad problem.
Now let's just like figure out 5. 5 should not be hard.
Yeah, guys.
Yes, yes.
solve
After
that.
after doing so much Cauchy, it should not be hard.
Maybe everything was actually Cauchy Schwarz all along.
No, it was complex bash.
Yeah,
and
there was no
inequalities.
complex.
No, Cauchy Schwarz is complex numbers maybe.
Oh, wow.
Nah, it's not. It's always Cauchy
Yeah,
Schwarz
yeah,
complex.
sure.
Cauchy Schwarz were equal to 2 is complex numbers, right? No.
Yes.
Vectors.
Yes.
Vectors is
Whatever.
complex numbers.
I'll come in a minute.
Wait, how do you do P5 now? Like,
Like some stupid parity thing should work. Like,
Some
I don't think
So
that's the
P5,
case.
we have
There is
two
some not.
answers. We just want to find
There's some
which
not-
one of them it is. That's it.
should be like some.
I think it's probably n square by 4 in
You should probably first study like Hamiltonian like cycles. Like, what properties do they satisfy? Like, do we have a good description of them? For example, can we count the number of Hamiltonian cycles? By the way, H.
Just look at the.
Oh, does this get n
Patterns.
square by 2?
You guys solve it.
Yeah.
No.
Too bad.
We need your help,
Zero
Kana.
is-
Without you, it's impossible.
Nah. Wait, you got n square by 2 or what?
No.
Or
I say
four,
to it
maybe-
finish.
Uh,
Answer is either n square by 4 or n square by 2 for each end.
Yeah.
Let's
Getting anything would finish.
Hey, we use Cauchy, so we basically use some amount of complex numbers there. We must use complex there as well.
Relax.
We use complex. We use vectors in like Cauchy's vectors, so we must use angle chasing, Barry bashing here. Wait, is this stream all right? Because for
Yeah.
me, it is like
Oh, Ibr is.
yeah, if it's gone.
but
Okay, I'm here.
yeah,
I'm
like, is the
streaming
stream
like
all right?
P5 only. I'm sharing P5 only.
Yeah.
Wait, what is the
Ah,
stream
I'm where
streaming?
Om is.
because what the stream is, yeah, what is the stream streaming with? I think the stream is streaming very
Where is
late
Om?
or slow.
No,
Is
it's
the
a
stream-
bit delayed. That's a delay.
It is a bit.
My screen shows the stream is on like P6 right now. We haven't like where.
No,
Are you
yeah,
sure you're live?
it is live.
Are you, Kanav, are you looking at the live stream?
Oh, I'm
Live.
looking at the thing that I'm supposed to share. Like, I might be okay. Yeah, it's delayed. It's delayed by like, oh my god, 40 minutes.
40 minutes.
Not for me, not for like you. Probably on the right thing. It's just
No. I'm on the stream right now and we're like
Wait, you don't go to
absolutely
stream. You're sharing screen.
No, I'm on a different screen when I'm
Okay,
answering.
okay.
Okay. Let's just cook p5.
Because
And let's just cook it. Then it'll be done. Finally. How do we cook on p5? Mute all this.
So p6 is definitely algebra.
What are the
It always
possible
can't
paths
be, but
that
it is
like
just algebra.
no, like we were thinking of this earlier as well. Like
What?
what happens at corners? What are the possible like states that we could enter, exit, etc. from?
We wanted the corners. Like corners was just you're just getting very stuck at corners.
We know that if you have two working arrangements, then in both of them, every single direction must be different. And so
But
that
Repeat
basically
what?
tells you that
Repeat what?
that basically tells you like this, right? Hold on, let me open the where is the mirror?
So what did we
Yeah.
have last? We had this two column, two things.
Let me follow.
We
Yeah. So like
don't even have the partition.
if you look at like the corners again, then like you know that if you like you could like assign some number here denoting which direction you're going in, then it's like all of them will have to be opposite.
opposite of like second
If
cycle.
if you have a
But
0
what?
and 3, not opposite, but like different. But they'll have to be opposite because there are only two possibilities.
Wait,
Yeah.
repeat again. What are you doing?
So at this cell, the only two directions, Emil, can you get rid of yeah. So the only two cells are like this and this,
Yeah.
Right.
and this and this, and this and this, and this and this. And if you have a 0 and 3 construction for this cell, then all four must have different stuff. Because otherwise it would be the same cycle.
Yeah.
So I think that forces that this cycle must look like this, like at the corner. So at this corner you must do like this. At this corner you must do this. At this corner you must do this. And here you must do this.
Oh, that
And
is
then in
forced
the
anyway. That
and
is
then in the
forced
three
anyway.
more.
That's forced.
No, that's not always forced. You could do like
That's
this.
forced by non-self-intersecting path.
Yeah. Like if
Wait,
you go
no,
right on the
why is
top
this wrong?
left, you're forced to
Why is
do
that
this.
possible? Why is this
No,
not
no,
possible?
you could do this. You could do
You could
this.
do like something like wait. Can
Yeah,
someone come
exactly.
here
It
and why is
always
that
hit
possible?
itself. If it's a Hamiltonian cycle, it has to be,
It
the
is
corners have to cycle through like that.
Wait,
Yeah.
no, why not? Why?
Wait,
Like,
why
give
can't I?
Oh, right.
give an
Yes.
example where it doesn't. Like,
Yes.
it goes like
No,
this,
no, no,
it'll
no,
come and
no.
hit itself.
No. You can do this.
Okay.
Yeah. Yeah, and then how do you come back here? How do you come back here?
Oh, right, you have to come back.
So since it's a cycle, like that's you
Formally
get
proving
this
it would
for
be.
free.
So it's like only this
It
way.
It wouldn't be that much of a pain. Just think of a convex polygon or something.
Wait,
Yeah.
so then you know. Oh, wait, hold on. So that means you know stuff about
Yeah. Corners.
no, the cell right adjacent to the corner as well. Like, hold on,
Yeah.
let me.
Yes.
So, like, let's say you get rid of all of this. So let's say that in the zero mod thing, you were like following a clockwise order on these guys. Then it's
Okay. So yeah, I get what you mean. So
And
then
in
like
it's
the
like
three thing,
this
you'll be
cell
following
has to
a
point up.
counterclockwise
if this
also.
pointing
cell
up,
has to
then
point
this has to be pointing like same
this.
direction. This because afterwards it will go here. Then if
Uh,
it's
Forget about that. Don't draw that. Like that doesn't matter. And like this will have to point downward, and this will have to point right.
and we can
Yes.
tell about this cells also, the other cells.
And then when things switch around, when you work with 3 mod 4, then this guy needs to point this way.
No, so can you draw where they point in 0 mod 4 case? Where do they point in 0 mod 4? Like just
Yeah, exactly. Let's try
turn
to
it or
figure that
something.
out. So in 0 mod 4 case, this guy has two choices. In the 3 mod case, it would point up. And so
So
now
hence you can rotate it to find the 0 mod 4 case.
here and like here it must point here or here. This guy points here or here. And this guy points here or here.
How do both work? Only one works.
Only one can work, but oh yeah, only
So
one can work.
by rotation, because just see what happens in 3x4 and rotate that.
Yeah, so you get that this direction is fixed. So in the 0 mod 4 case,
Yes.
it has to look like this.
Yes.
Yeah. Yes. Yeah. Exactly.
So you have this,
Wait,
this,
so wait, what
and this,
have you
in
done?
the 0 mod 4 case.
We
Not
have
that.
forced
Wait, wait,
that
wait.
in the 0 mod 4 case, the arrows should look like this.
So now we're making a Hamiltonian path where the arrows are like this. Okay.
Wait, what?
It looks like a sort of swastika, right? Nazism, chill.
Ed Island?
So
I'm drawing it out.
Okay, let me come to where you are.
So like what I'm saying is in the 0 mod 4 case, it must look like this, first of all. You can assume without losing generality. Then you can prove that, okay, so this also has to happen.
no, then the rotation comes.
Mhm.
I guess it should be on the same side as the first one. Wait, once you go here to here, this will rotate, right? This should be
No. So we are drawing in the like.
We're drawing the path,
Okay,
not the rotated, only the
not
path.
only the
Okay,
path.
only the
Actually.
path, yeah.
And now, like the point is, when you switch over to 3 mod 4, there is still a path starting at this cell, which then means that this guy, first of all, will point either upward or downward, right? Same state as this in 0 mod 4 case.
Yeah.
It can't point outward, so it has to point inward.
Why can't it point outward?
बाहर चला जाएगा.
Yeah, correct.
I mean, when you come there, it should have changed direction.
No, we're putting how it is
In
in
the
the
path, in
0
the
mod
path,
4
in the
case.
path.
Oh, it is in the path. Yeah.
Right.
So now this must happen.
Yeah. And this points
Oh,
up and that
okay.
points right.
Wait, this seems.
So in the
Why
3
am I
mod
being
4
now
case, we just like
convinced?
flipped everything to some sense.
So like we know that 0 mod 4 has
Wait.
all of it.
Okay,
And
now the zero.
when it switches
Wait,
to
wait,
3
I have a
mod 4,
question.
all of these get flipped. Like
Wait, so it's in the 0 mod
But
4
no,
path.
it doesn't. What if the order is different?
it doesn't matter. You will start at 0, right? Like you can't not start at 0. Like if your first move from 0 is a right, you have to reach the right cell first. And if it is a down, which has to be in the 3 mod 4 case, you will reach down. So that completely determines
Zero mod
everything.
3, in the 0 mod 4 case and 3 mod 4 case, everything is flipped, right? For every. At
No,
every
so like
vertex, it's flipped.
it will just be like following an opposite type of path. So instead of like this will flip, this will also
Exactly.
this will
Wait,
also
so,
flip.
wait, so in the 0 mod 4 by 3 mod 4 path, everything changes from up down to left right or left right up down.
Something like that, yeah.
Is that correct?
Yeah.
Because of Manhattan.
This is Manhattan.
Yes.
Okay, so now you. Wait, now what if you take like this? Wait, like the zone of these two parts or something?
The XOR.
Yeah.
That is
Zor. Parthian.
No.
Can we do that here?
Wait, is this a valid construction for a 6x6? This swastika.
Okay, for a 4 by
It
4, the
satisfies
edge.
all the
For a
conditions.
4 by
What
4,
is this
the edge
danger?
thing also works, right? For
Oh,
4 by
that's
4,
just
the
like
edge
random.
thing satisfies things. Like the edge.
Yeah.
No, the edge doesn't work. So that's what even I thought in the 4x4. But we want
No.
these
So
to be
now
oriented like
this
this.
thing must point this direction. Or this
Wait,
direction.
where are you?
Like it should point this way or this way.
Why?
Yeah, and depending on the
Wait,
Then how will you
gravity
reach
is
this?
fixed, but depending on 2 mod 4 or
Why? It
0
will come
mod
like
4,
this. It will come like this.
point
It will
that,
come like this, right? Why not come like this?
No, that's fine, but you have to reach this guy, na? How will you reach this guy?
Huh.
You can't
This-
reach through here because that would form a cycle.
Oh,
So
yeah,
you have
yeah,
to
yeah.
reach from here.
Yes. But that still doesn't give us that this guy is pointing up. He can be pointing down also due to the
Oh, then how will you
2
reach
mod 4
this?
case. Because it's 2 mod 4 in that case, and this guy turns twice.
No, this is the path in the real sense, like the path that it follows ultimately.
Oh,
not
then
what it always
this
does.
obviously has to be like that, like
Yeah.
without a doubt. Yeah. But that's all information we have. We don't know more.
Wait, Ajay, why not like this?
No, because this is
No,
already
because
taken.
that would
This
become
is
a
already
cycle.
taken.
Like this would become a cycle, right?
Oh.
Yeah, correct.
So are you like going to reconstruct the entire path here?
Maybe.
By
I'm
hand.
becoming more and more convinced that the swastika is the
Bro,
optimal
they
path.
should have asked 2025 plus 25 grid only. In this one as
Then it
well.
would have done by hand.
Yeah,
Oh,
then
and
you would have
then
been
answer
done
is
Maybe
by
that's why
zero.
they didn't do
Like,
it.
bye-bye.
Because the answer is 0.
That means so good.
Now you could enter this guy this way.
Or from down, we have no idea.
Okay, we have a hint from chat. The solution is even stupider.
It's the answer and square by 2.
Turbo
This
can't go
construct
to a
and
corner both ways. But it must. I mean, if the answer is n square by 2. So
yeah, exactly. So maybe you can prove in a very obvious way that it can't go to the corner both ways and just finish.
why?
I don't know.
It can.
Why?
I'm pretty sure the solution is just scuffed. We are overthinking this. The solution will be some easy shit that we just haven't thought of. Let's see.
Can we sort the two parts? Does it give anything?
How does XORing the two paths give you
I mean, like
anything of
sort the
value?
edges. Sort the edges. It'll break into cycles.
Wait,
Does
wait,
that
how do
give
you
anything?
define the XOR of an edge?
I mean, like every edge, there are two cycles, right?
Oh, if it
Every edge
exists in
occurs
both.
in.
Okay. If you XOR two paths, no, then you'll get way too many edges after that. Like something bad will happen.
Well, it'll break into multiple cycles. And here's something very weird, right? Like because of the flip in direction.
Pretty sure XOR is just like too scuffed.
Wait. Let's be like very strong about this. Like, you know that it looks like this in the zero case, right? So what does that tell us about so like, okay, so let's say that this happens in turn 0,
Where are
this
you?
happens in turn 1, this happens in turn -1, which means that the true structure of these three things looks like what? It must look like this, and then this should be fixed to this. This should be fixed to this, right?
No, I think that even that should be fixed that way because
No. All
Yeah.
two
three
by
have
two
to be fixed to
construction.
the same
Yeah.
orientation. Same
Because
orientation.
2 by 2 they're all same orientation.
Yeah. Not like this. Actually, they have to be like this.
Yeah.
Okay.
No.
2 by 2. Look at 2 by 2. 2 by 2 all right work.
Then the 2 by 2 construction is wrong.
No, 2 by 2 construction is
No.
complete.
Like that does not work. Like,
So, I mean, flip clockwise and counterclockwise if you want to.
okay, fine. Then okay, but like let's work with
People might
something.
have got confused.
What do you propose we work with? Clockwise or counterclockwise? Like fix one right now. It'll be important.
Work with all right.
Counterclockwise.
Work with all right. Work with all right. Whatever gives all right, work with it.
Okay, so
Yeah.
you're working with clockwise. Fine.
Whatever it
What?
is.
No.
all right.
We have to work it counterclockwise because like
No,
complex
whatever gives
numbers.
all right. Whatever gives
like-
all right, you work with that.
Yeah.
Okay. Like, what's wrong with all left, bro? Like, okay.
No,
We
right
did
is
all
superior.
right.
They're all right-handed.
All right, bro. All right.
Wait, are you all right handed?
Oh, Archit, all right.
All right, bro. All right.
I mean, fine. I'm working with counterclockwise because that's what the problem says. Okay.
Yeah.
Okay. So this is what it
Right.
must look like.
What is this? One is right,
What
all
is
is left.
this?
Either pick all left or all right. Don't like
No. Sorry, -1. So it should be flipping in the opposite way. So it should actually be.
I think it's all down, Arshit.
It should be
It's all right. It's all right.
I don't get.
It's all right. We're not getting anywhere close.
Wait,
now.
It's
It
all right.
is-
It's all right. Don't go.
this doesn't work. What?
Yeah. So basically, it must look like this. The actual.
But are you sure? Are you sure?
Yes, I'm
2
sure.
by 2, this does not work, right? Oh, maybe it's not supposed to.
It does. Like you're seeing clockwise, anti-clockwise wrong. Probably.
Wait,
I-
Arshit, are you working with
You
counterclockwise?
should start here. You start here.
Yes, because that's what the problem
Then you're
says.
gonna go here.
Yeah,
Everything is
I
done.
agree with you, but then it's already messed up over here. It has to face left. The
What
corner
has to
has to be
face
right and the other two have to be left.
No. This is
Yes.
-1. This is
Yes.
at residue
So it's
3.
3 mod 4. So it's 3 mod 4.
It
So
has to
when you
be
come
left.
to
It
3
has to be
mod 4,
left.
it'll be
It has to be
rotated
left.
clockwise.
Yeah.
Does that make sense? Like 3 counterclockwise rotations is 1 clockwise rotation. So if you want it to be rotating up at 3 mod 4, then you want it to be 9 o'clock right now. If you want it to be 12 o'clock later. So you have 3 o'clock, 9 o'clock, 9 o'clock.
Bruh, don't say clocks like that.
Please.
I'm not going to understand that.
Let us work with this.
Clockwise, anti-clockwise. Simple.
Achha, try. Try.
Wait, so you're saying it's this?
It's
No.
right. No, other way. It's left.
Left.
Shit, am I saying?
That's what I drew first, no?
Yeah, it was
It's
right.
correct. What you drew first is correct.
Nobody questioned that. We just wanted to make all the same
Right.
direction.
Okay, fine. Are you happy that this is the actual thing now?
Yes,
Yes.
I completely agree.
Very happy.
Now we're
This is
starting
actual
at
thing,
zero.
but
Everything you mean.
Now we're starting at 0 with 3 mod 4. So that means that this
Okay.
will point down. Which direction will this guy point in?
Up, right.
So this
Yeah,
guy
and-
has 2 options now. This guy has 2 options. He can either go down or right. So in the original, he has to be pointing either up or left.
No, so look at the 3 mod 4 case. So here you're at 3 mod 4. So now you'll be
Right.
at 0 mod 4 here.
Well, there's your
so it goes left. It goes out.
Oh wait,
Done. What?
we know for sure that this
It
guy
went out.
is
What is
pointing
happening here?
down. We know that.
Wait, why did it just go out?
Like in the
No, it
original
won't
one.
go out. It'll change, right?
How?
Because it has
This
to
is zero
rotate.
mod. Yeah, this is a 0 mod for everything, right? This is everything 0 mod for.
Yes, it just goes out, Lamar.
So what we have done? What?
What even?
Something's
What even?
What? No, something.
high probability of fixed
I
yes.
think this is what.
Turbo is turbo, man.
Like
Probably
explain
messed up
it.
something.
From 0 mod 4 and 3 mod
This is
4. Right?
really
No,
good.
what have I done wrong?
Okay, let's start afresh. Okay, let's start afresh.
Yeah, let's
Okay,
just do
let's
it
start
over.
from scratch again. All we have
Yeah,
is
and like-
multiply by 4.
No, not so much scratch. Like let's start from scratch.
Don't
Drawing
scratch.
arrows.
So much scratch.
What's Archit? What is the Ajay?
Just focus on 3 corner cells. I think that's all we need.
Yeah, that's all we need, right?
It is
Yeah.
exactly as that one user said.
You go
Okay.
right.
Wow.
This goes right.
So this is like diagram of
So
like
this
what?
happens in the actual path.
Okay, yeah. Yes, actual path.
This will be proven later, right? We'll just confirm later.
This should be the actual part to like work in both ways.
Okay, this is the actual path, which is everything is its own mod for.
Yeah. 0 mod 4.
Wait, so
Like
wait.
you're drawing the actual Hamiltonian cycle. So then
Yeah, so
this
this is
like
in
this.
0 mod 4 state. This is 1 mod 4 state. This is in 3 mod 4 state. No, we don't care
And
about
this
that.
guy
We
is
don't care
in
about
2
that.
mod
Wait,
4
Abel,
state. We have that
remove
also.
that. Remove that. We don't care.
We
about
don't
that.
care about that.
Huh?
We only care about these
No,
three.
but we
It's
might as
there,
well
but
use
we
it.
don't-
But yeah, sure.
So this is in
Okay,
0,
alright.
1, 2, 3 states. Yes. So in the
Okay.
original states, what are they? Not 0 states. Yeah.
That's
should
what
be-
Archit did is correct.
Clockwise. So like, yeah.
Yes.
So this is counterclockwise, right? And this is counter. Yeah. This is in 0,
Yeah, it's
4,
perfect,
0
it's perfect.
state. And now we move to 3 state.
Okay, we move it to 3 state. All right.
The center line is 3 state. This is in 3 state. Wait, we don't even need the right one though. We just need these two. Wait, not all three state.
No.
Not all
You
3
move
state.
0 to 3. You move 1 to
No.
0, and you move
This is 3 state.
3
No.
to...
This is no. This is 3 state. This is 3 state. That's all. Okay. What happens when this is 3 state?
Yes.
It goes down.
It goes down.
So this must be what state? This must be 1. This must be 0 state.
This
And what
should
is
be
this 0 state? Out.
Two
Let out.
state, right?
What?
What terrible.
Oh, so
You
you
don't
follow
even
the
need
concept.
cells.
Wait,
Yeah.
but
These
what
two
if
cells.
instead
You
of
don't
3
even-
state, it's 1 state? In that case,
How?
it runs away through that or something.
Oh, in that case, the other guy dies. In that case, the other
Ah.
guy
Other guy
dies.
dies. We don't
Oh
even need
my
that.
God.
So we don't even need
No,
that. We just
in the
needed
one
these two.
state, like
just
Turbo
needed
just
these
walks
two
out on the
things.
first turn itself. Bro, in the one state,
Yeah, in the
oh
one
my
state it
God.
goes above our
In the
line.
one state, the corner is just pointing out.
Yeah.
Yeah.
So only
What
3
is
state
this?
can work, and in 3 state, he goes, oh my God.
The
I think
average
this is worse
turbo
than
experience.
IMOP5.
Like,
I think this is
average
worse
turbo
than
problem.
IMOP5.
Wait, actually, we don't even
Nah.
need this cell. We don't need
Yeah,
this
we just
cell. I
need
will
2
consider
cells. We
this
just
cell.
need 2 cells.
No, this cell and that cell. That's it.
Lama.
We don't need an n square. We just need 2 cells to consider.
Okay, like this is the biggest troll in history, bro. It's like
Oh.
building on IM.
Wait, what happens in... No, what if it was 1 mod 4 instead?
Then the first move
The
itself
first time is
points up, right?
What's up?
So
Out.
Turbo just walks out. If it's 2 mod 4, also Turbo just walks out.
0 is
No.
right. 1 is up.
Oh
2
my
is left.
God.
My
One is
Crazy.
down.
God.
My
This is-
days, bro.
Bro,
Shit ever.
It's gonna continue, guys. I'm a P5 is always
Like
going to be.
no, the fact that only 2 cells matter for the entire bound is just so scuffed. And we were
Oh,
thinking
God.
of graphs or cycles and shit. Oh my
Okay, so
god.
5 was a silly problem. So which means the only good problem on
The
the
problem
test
was
was
P6.
which was an
Exactly.
inequality. I mean, that speaks.
Like imagine giving a test where the only good problem is an inequality. That's sad.
The problems speak for themselves.
Oh, P5 is
That-
so sad.
So scam, man.
Okay, GG.
Okay.
So we're done. We're done.
Yes.
with the
Yeah,
live.
we're done. We're done with all six. I know we're
Let's just zoom out.
going to write up.
Massively
I
go
guess
back to the
right
fan.
over like okay, first like just like
Do we write up on stream?
No,
Let's write
no.
up on let's
No,
write up
no, no.
only P6 on stream. Like all else just leave.
P6 is
P6
the
Why,
only
why do you want
problem
to write
that's
up on stream?
worth.
We'll
Why
write
do you
up
want to
later.
write up on
Write up
stream?
later.
Yeah, we'll write up later.
it's already like what? No,
Like stream write up, what are they seeing? Like we
We should
type
probably
in
go have
stream.
lunch. Lunch is probably.
yes,
Yeah, we should have lunch.
No, you know,
Yeah.
like in Evan streams,
My
he
God,
always
it's been
writes up the
I
problem
guess we
during
should
stream. The idea is that you
like, basically
consolidate the
do, like,
entire
all the
proof
proofs and
into
then
a
just
thing.
just end the stream.
Yeah,
Or
but-
we'll ask them to read the solutions later.
True.
There's nothing to read on this mirror.
Not on Miro when we write up.
I mean, we can write up later. We can just end the stream now.
Yeah.
Yeah.
You can go.
Okay. It was fun doing this, people. You should say goodbye to YouTube. Goodbye, YouTube.
Goodbye.
Thank you for P6. The rest was just
Wait, Pranav did not tell me how to end the stream.
Wait, I'll end
Okay.
stream. I'll end stream.
I have an option. Okay.
Goodbye.
So,
Just say end stream. Yeah.
so I'm just gonna end stream so everyone can say bye bye.
Goodbye. Goodbye, people.
Goodbye.
Bye
goodbye,
everyone.
Agnes.
I hope you enjoyed.
Yes. I
So we're ending the stream in 3, 2, 1.
Bye.
End.
Okay, now we confirm that it's actually ended.
it's not.
It's not
It won't end for a few minutes.
okay. I mean, like.
We are not live